Hello, my name is Charles Severance, and I'd like to welcome you to Web Applications for Everybody. One of the questions that I get a lot is, why do you teach PHP? And that's because I'm old, and I've seen a lot, and the future, the newest and latest thing is often not the thing that lasts into the future. As you can sort of well understand with my steampunk costume. Steampunk is an alternate future where not all the cool things that we imagine that have been invented get invented, and we imagine what would be like if all these cool things didn't get invented. And the problem is the latest tricky framework like Angular 1 or Angular 2 or Angular 4 or Angular 75, I mean, they're fun, and you hear about them in a coffee shop, but what I've learned is I've got code running that's 10 years old, and that code is not sexy, and I didn't hear it in a coffee shop. As a matter of fact, code that I wrote 10, 15 years ago where I heard somebody talking about something cool in a coffee shop, that code's crap, doesn't work, hard to use, totally broken. But the boring stuff, the non-sexy stuff, I still have that running. So for me, it's kind of like the future is not always as rosy as it seems, and some of these things that are fun. And by the way, if you're going to use one of those things and start your little company, it's fine. You just have to throw it away in a couple of years. The other thing that's important is this course is not about coding. This course is about the request-response cycle, how a browser works with a web server, works with a database, what SQL is, what HTML is, and what AJAX is, and what the layout of a web application is. And PHP just happens to be sort of part of that. And I really want you to learn more than one language. And so if I teach you PHP now, and later you go to take a boot camp on Ruby on Rails, you're going to rock in that Ruby on Rails boot camp, and then you can go get a Ruby on Rails job, right? And so I'm really into more than one language. And so why do I pick the language to start in teaching that's the easiest to install, the cheapest to host, the most widely used, and literally there are probably more PHP jobs than any other job for web application development. And so I'm not really doing you a favor if I teach you something like Angular 7. That there might be a few really cool jobs at Angular 7. I know Angular 7 doesn't even exist yet, but there might be some cool jobs for Angular 4, and then in a week there's no more cool jobs, right? So I want you to take something with you that'll last you the rest of your career. The other thing I think is important is we're trying to teach a worldwide audience here, not just audience of people in San Francisco or Seattle who need Ruby on Rails or need Django or whatever the latest thing that the kids in the coffee shop have dreamed up. And so I want to teach you something that you can use as easily in Iran or India or Pakistan as you can in the United States. And so PHP is that universal language for the web. Other people say, like, why don't you use Python? You teach a Python course. I love Python. You teach great. And Python is not designed for the web. Python is great for data mining and data analysis, and it's a great language to learn. But just because it's a language you know doesn't mean that it's the right language for the web. And so PHP, everything about the PHP community, if you go from PHP 1 to 2 to 3 to 4 to 5 to 7, they skip PHP 6. Every innovation that's ever been put into PHP has been to make it better and more suitable as a way to build web applications. Scalable web applications, Facebook uses it, all kinds of people use it, they tweak it. All these things are high performance and easily used and really wonderful. And they may not be the right thing for you, but I think without a doubt, they're the right thing that you should learn for the very first time. So I encourage you to enjoy your learning of PHP. Understand it may not be the only thing that you do. It may not be the thing that you get paid to do, but we are going to build a foundation so that everyone can learn how to program web applications. See you in class. Hello and welcome to class. My name is Charles Severance and I'm your instructor. This is the first class in our specialization, and I kind of debated about what to put in the class. It turned out to be a little long. We really like maybe 5 classes, 5 weeks in a class, but I just couldn't find a place to break this into 2 classes. So this is a good class, and if you finish this class, you've kind of hit on the essential basis, the essential basics of the things that we need to do. We're going to cover HTML, HyperText Markup Language, Cascading Style Sheets, CSS, HyperText Transport Protocol, and PHP. Now I'm hoping that you already know CSS a little bit.
And I'm not really trying to teach you how to become a web designer to show you the look of all these things. We just want you to be kind of a web mechanic, because we're going to work more in the back end and how we create applications, not how to build a beautiful application. If you want to learn how to build a beautiful application, a responsive application, an accessible application, that's web design for everybody, taught by my colleague, Colleen Van Lent. And you kind of technically can take either specialization in either order, or you could sort of learn sort of the mechanics of it, and then you could learn sort of how to make it look good, or you could learn to make it look good in the mechanics. I would prefer, I think the best way to do it is to do web design first and then web application second. And that's kind of how Colleen and I marked it out when we came up with the two specializations. But you can go in any direction. And if you're here first, go ahead and start. And remember that we're not going to show you how to make things beautiful, and there's a whole nother specialization that tells you how to do that. And so, if you have problems, hit us up in the forums where the instructional staff can help you out. Instructional staff can do things like, look at your submissions and help you out. And if you need to get a hold of me, the best way to get a hold of me is on Twitter, and you just mention at Dr. Chuck, DrChuck, and usually I'm sort of somewhere on the planet, and within a few minutes I'll see it. So if it's like, oh, assignment 4 is broken, I'll find out about it really quick. So with that, I'll welcome you again to the class, and good luck, and hope to see you at the end and with everything finished up. So welcome to Web Applications for Everybody. I'd like to take this first lecture to talk a little bit about the core technologies and the people that built some of these core technologies. Of course, every one of these requires a group of people, but I have some cool interviews that I'd like you to take a look at. Not so much because I want you to memorize what they say, but I also want you to kind of understand the kind of people that made these things and how technology is made by people. We're people, and people made technology. And nothing's perfect. Everything is a set of compromises and a set of choices. And so there's no magic to all this. And so if you say, oh, this is kind of funky or flawed, it's funky or flawed often because it wants to be like that, or it's naturally someone made a choice. And so we'll talk about the web server. We're going to talk about the PHP programming language, SQL, the language you talk to databases, how we talk inside the browser using JavaScript, and jQuery, which is like a library that makes Java client-side coding so much easier, and then how we send data back and forth between the browser and the server using a protocol called JSON. So the kind of the foundation of everything we're going to do is the Apache Web Server. It's an open source project. It was part of the 1992, 93, 94 project at NCSA, the National Center for Supercomputing Applications, that was part of the Mosaic. And the Mosaic was a browser, a client, and the Apache Web Server was the HTTPD, which stands for HyperText Transfer Protocol Daemon. Daemon was the thing that was always there so the client could talk to it. When the Mosaic project kind of went down at NCSA, it was open source, and a bunch of people picked it up. And Brian Ballendorf was one of those people. Apache stands for, depending on your interpretation, Apache, like very patchy web server, because they kept patching this thing. And that created the Apache Open Source Foundation as the first product. It's open source. It's written in this programming language called C, which is a very low-level and powerful programming language that really underpins lots of the technologies that we use. And so this is sort of a slide where I talk a little bit about the history of all these programming languages. And so C is an interesting programming language because in 1972, it's the programming language that was used to write Unix, was used to write Linux, was used to write Python. So if you look at Python itself, Python is written in C. And so prior to C, in the beginning, we tended to do lots of calculations. We saw computers as really fast calculators, and so a lot of the things we did was either write very simple machine language programs or Fortran programs that really were trying to use it as a fast calculator. And so sometime in the 15, 20 years between the 1950s and the 1970s, we realized that computers were going to be used for things like email and social networking and sending text. And there was a whole bunch of fancy text languages that were built, but none of them really were a combination of text-savvy languages and super fast languages. So the first language that I recall that was both really good with text and good with numbers and really fast and suitable for writing systems kinds of programs was this language called C. And a lot of us fell in love with it. It was a very succinct programming language. It uses curly braces for if statements and for statements. It uses this for syntax with the 2 semicolons in the middle. And so if you've seen Java or JavaScript or C++ or Objective-C or C#, you've seen this language, because all of these languages at the top here, the kind of system-y programming languages, take their very much cues. JavaScript is kind of on the gray area between fun languages and system programming languages. But they all took their cues from this C language, which was used to write, like I said, Linux and Unix, and even Python is written in C. So Python was written in C. And in addition to the sort of system-y languages, there's a whole series of easy-to-use languages. And Perl was this language that stands for something report language, and it was about sort of handling simple data stuff. And Perl was really an inspiration for Python, but Python was written in C, and so Python took a lot of inspiration from C. And I hope by now that you know the Python language. And the PHP language, which is another of the languages we're going to learn in this series of classes, it's also written in PHP. It took a lot of inspiration from C. PHP is written in C and takes a lot of inspiration from it, but it also takes a lot of inspiration from Perl, and to a lesser degree probably inspiration from Python. And this bottom set of languages, these are really simpler programming languages that have simpler primitives that are easier to use. And JavaScript kind of lives in the middle. JavaScript is increasingly both a system programming language and kind of a lightweight fun language, and we'll use it in some ways for both things. So JavaScript is a very interesting language. I prefer not to teach JavaScript as the first language because it's so sort of beautiful, elegant, and powerful. I mean, it's easy to find a little bit of code and stick it in your web page and have it work, but to truly understand JavaScript, it's probably better for it to be your third or fourth language that you learn. And if you've learned Python and PHP and SQL, HTML and CSS, and then you finally learn JavaScript, to me that's the right order, and that's the order that we're going to do in this class. But I still want to introduce you then to some of the folks who've built these basic technologies. So the PHP language is a programming language that is a templating language that's merged into HTML pages. And so it's like you've got HTML and then code and HTML and code and HTML and code. And so it's very easy to add little tiny bits of dynamic calculations and dynamic code to part of a web page. So some of the web page comes from code that runs and has print statements in it, and then some of the web page just comes from the HTML. So PHP was created by a fellow named Rasmus Leerdorf. Now thousands of people maintain it as a large open source project. Rasmus was not a trained computer scientist. I encourage you to watch his video. He'll honestly tell you that he's more interested in practical, easy-to-use stuff than he is about building the world's greatest programming language. Now, PHP is from the 80s, and so it's almost 20-some years old, and so it's gotten more elegant as time has passed. So PHP 5 and PHP 7 are much more elegant than PHP 1 and PHP 2. But the idea is to get you as the programmer building a web application productive as soon as possible. He was having trouble in the mid 1990s because he was writing all of his web pages in C, and C is very, very, very hard. So take a look at it, and Rasmus is a fun guy, and PHP is very much a reflection of his early approach to building it. SQL, I hope by now perhaps you've seen a little bit of SQL. SQL is a glorious and beautiful language. SQL basically takes a very complex problem, and that's how to optimally store data in memory of the computer and on the disk of the computer and get things next to each other that are likely to be pulled up at the same time. Joins and inserts and selects and updates and deletes. And databases themselves are like super complex. I mean, you could have 20 careers with PhDs in all 20 of them, and you still wouldn't know enough to know all the stuff that database applications are capable of doing. But we have this thing called SQL where all that complexity is beautifully abstracted for us, and we just say, I would like to do this, and you magically figure it out. So that magic figured out is full of PhDs in computer science, but we don't have to worry about that. And SQL is such a beautiful language. The birth story of SQL is a little different than the other languages. In the 60s, all the database vendors, IBM and Oracle and Sybase and companies that don't even exist, were fighting over the marketplace. And they all had a different view of how databases should be built. And so they did. And each one would have their PhDs in computer science. And they would build different databases. And they would build different languages to talk to those databases. And then the U.S. government, in the form of the National Institute of Standards and Technology, NIST, said, look, we're tired of arguing with you about which is the best database. And what we need is a standard language to talk to any database. You can implement them any way you want. Go ahead. And so they said, hey, you industry people, you get together and you develop a standard. And SQL was that standard. And Elizabeth Fong, I did an interview with her, went to visit her at NIST, and she talks about how this happened. And it was kind of a magical thing because all these vendors got together and produced something beautiful. And it wasn't abstraction in that it really wasn't a direct implementation. The language didn't directly implement any of the vendors' databases, but it was a way to talk to any of them in a very beautiful abstraction. So it turns out to be a very, very beautiful language, and I think you'll agree once we get talking to them. So after we're done in the server, we're going to start playing in the browser, in the client. And so JavaScript is like this C-like programming language in that it has curly braces, et cetera, et cetera. But its early design was to be done inside of a web browser, web page. And so it actually has these predefined constants like document and window that allow it to mess with your browser. So you're sort of watching your browser page and JavaScript is sneaking around and fiddling with the page and doing things, and you're seeing those changes through what's called the document object model or the window, where that's how you can be in a page and like, boop, a new thing pops up. Boop, boop, little red bop. That's all done with JavaScript. And so JavaScript is really cool. It was in 1995. Brendan Eich was the inventor of this. It was at the Mozilla Foundation, part of the Netscape project. And I encourage you to take a look at Brendan's video. Brendan is very different than Rasmus in that Brendan is even smarter than a computer scientist. Brendan is a physicist, which good computer scientists look up to physicists because physicists are so smart, know a lot of math. Brendan really saw JavaScript as his chance, in a very hurry, without really telling anybody, building what he considered truly the most beautiful programming language that humanity had ever seen. That's how high of a goal he had for it. And he's just smart enough that he'd seen so many languages, he had things he liked about them, and he sort of took that C-like language from Java, the C-like syntax from Java, and built a very beautiful language. And when I get to telling you about like how object-oriented PHP compares with object-oriented JavaScript, I'll totally geek out about it because I'm like, look how elegant this is. And you'll be like, just show me the syntax. So what I'm saying is JavaScript is a beautiful language, and that's why JavaScript keeps increasing in popularity. You may be working at an organization that uses JavaScript in the server in addition to in the browser using a framework called Node.js or other JavaScript frameworks. And so take a look at the JavaScript interview. It's really, I think, quite cool. And again, sense the personality of these people. Now, JavaScript is this beautiful programming language, and it talks to the browsers through this thing called the DOM, the Document Object Model. And they standardized JavaScript very quickly. So JavaScript is all the same, but they didn't standardize the Document Object Model, the things that JavaScript does to change what's going on in the browser. Okay? And so the problem is if you had Internet Explorer 6 or Internet Explorer 8 or Chrome or Firefox, they all were different. Not JavaScript, but how JavaScript did things in the browser. And so jQuery was a portability layer that was built by John Resig. And it was a very elegant and portable way to do things in the document object model. And so John is like 10 years after all these other folks in that he is trying to make it easier for us to do. So a lot of people these days just assume jQuery is JavaScript because it's a better way to talk to the document object model, and it's a really great way to do stuff, and it keeps our code in the browser much shorter. And so I encourage you to take a look at John Resig. And so the last thing we're going to talk about is what's called JSON, or JavaScript Object Notation. And that is basically the format of data that once you have really smart browser code and really smart server code, and the code, instead of the page, but the code behind the page wants to talk to the server on your behalf and start sending things without even you doing anything. You'll just be like, and it'll send something. Like, go check to see if there's any new messages. Go check to see if there's any new messages. Well, the new messages come back in a format called JSON. And this video that I have, Douglas Crockford, who doesn't credit himself as the inventor of JSON, he is the discoverer of JSON. And that's because it was actually part of JavaScript. He just took part of the JavaScript language and created a protocol that then captured that, and then we use that for a lot of different things. And so I encourage you to take a look at these videos when you have some time. They're not essential, right? You're not going to learn JSON from watching a Douglas Crockford video, or you're not going to learn from Liz Fong's not going to be able to teach you SQL. But I think it helps you to understand that all these things are the creation of people. And people working together to kind of come up with something, and there's all kind of compromises, and it's all very interesting stuff. And you may ultimately end up writing with Node or Ruby on Rails, or who knows what you're going to actually write your web applications. But at the end of the day, everything is something that we people have created and then we people use and use from each other. So now we're going to talk about how web pages get constructed. Now you might say, why are we looking at all this detail? Partly because what I want you to really understand is how web applications work. Because web applications, and frankly many mobile applications, have multiple layers of components, multiple parts that work together. In the web browser, you got the browser, and then you got the server, and then you got a database server. And so what I want you to understand is I want you to be able to, as you write code, know what part of this multi-system that you're working with. And so the browser is the thing that runs on your hard drive. It might run on your phone or something. And the technologies that we're going to learn are like HTML and CSS. Later we'll learn about the document object model, which is a way of HTML is what formats this. CSS kind of picks the fonts and things. And the document object model is the way that JavaScript goes in and plays with stuff, changes words. We'll learn all that, how that happens. And jQuery makes that even easier. And so we have a lot of technologies in the browser that we're going to learn, and then we're going to have a lot of technologies in the server that we're going to learn. We're going to learn about PHP so that we can write code in the server. We're going to write SQL so we can find stuff hidden throughout in our databases and bring that all out and send it back. And then we're going to learn about the request-response cycle, and that is where the browser is talking to the server and we're writing code in the server to respond, and what goes back and forth, and that's HTTP, HyperText Transport Protocol. Also, JSON is part of what we're going to do back and forth. So when we have JavaScript talking and getting data back and forth, it uses JSON. And so in this first, I have to start somewhere, right? And so where I want to start is I want to start to give you a sense of what happens here, because this is the basic separation point between what goes on in the browser and what goes on in the server. We'll talk a little bit about the HyperText Transport Protocol, but mostly I'm trying to give you a way to realize that there are different pieces of code and technologies that are being used in these applications. So HTTP is the dominant application layer protocol. It was invented in 1989, 1990 by Tim Berners-Lee and Robert Cailliau when they invented the web. And there's other protocols that predate HTTP, like FTP for file transfer, Telnet, SMTP for simple mail transfer. These were all well developed. But Tim Berners-Lee and Robert Cailliau, they wanted a easy protocol, mostly because they weren't protocol developers. They just wanted to build an application that could show pages and let people edit those pages. So they kind of built the simplest possible protocol. Some of these protocols go back and forth and back and forth. In HTTP, it makes a connection, it asks for a document, and it gets a document back. It's really quite simple. And I'm not sure it was engineered to be simple, but what happened was we were able to layer on top of this simple things like web services and other things that are kind of just a slight variation on it. And so most of the new protocols that we use are simply protocols that sort of take a different convention on top of HTTP. So it's beautiful in its elegance, and it's the only one that we can hack because it's so simple that we can hack it. I used to be able to hack the mail protocol, but then security got in the way and made it difficult to use. Another of the core contributions of HTTP, again by Tim and Robert in the early 1990s, is that the notion of a uniform resource locator. Now you'll find this on, you'll pick up a brochure, it'd be the HTTP colon blah, 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 blah. And you're like, oh, okay, I know what that is. And I type that into my browser and I go get a document or a set of documents. But there's actually some science that goes into these uniform resource locators. And before the web, you had to know what host to go to, what protocol, what set of commands to send to that host, and then what kind of things on that host that you might want to retrieve. The URL just comes up with a convention and then concatenates these things together. So http:// is the protocol. There are more than just that one. The server that you talk to, and there's like out in the cloud, there's like server. Which of these servers has the document? What protocol is what we do to talk to it? And then within the server, there's files. And so this document within the server tells us what we're going to look at. Now, it's more complex than that. You can put parameters on the end of this. You can put what are called anchors on the end of it. So there's all kinds of things, x equals 2. But that's the basic idea of a URL, is how to get it, where to go get it, and what to get, all concatenated into one long string. And so the idea is if we have one of these URLs and we type it in the browser, we get it. The other way that we can do this is not just typing the URL in the browser, but embedded in the HTML are what are called anchor tags, which are clickable links that have an href, a hypertext reference, inside that. And we'll talk about this in the next HTTP lecture. The href that says, oh, when someone clicks on this link, go throw this page away and go to a different page. And so it's the hypertext aspect of it. So you click on a link and then you go to the next link. And so the link turns into a GET request, which retrieves a page, which gives us back new HTML, which then is shown in our browser. And so the first thing we're going to do is type a URL. So if you type data.pr4e.org/page1.htm, and then you hit enter, you have told it to go get a GET request. And if I take a look at the source code here, view page source, you might have to put like a developer mode on or something to see view page source, but we can see the page source here. You see this markup. This is HTML. We'll talk about this in some detail. And this is an anchor tag that says when this second page is clicked on, go and get this URL. So we're on page1.htm and this is page2.htm. And so if I click on this, it'll just be like instantaneous. But we've been to another page, and there's a link back to the first page, back to the second page, back to the first page. Okay? And so that's basically hypertext navigation, but our browsers are doing things and seeing these little clicks and then doing something and getting a different page. Now, of course, it's far more complex than that, and we'll see that in just a moment. But I want to go and take a very close look at exactly the steps that happen with this simple hypertext navigation. So at some point, we typed our URL into the browser. We hit the enter key, and that caused a GET request to happen, and now we see this page. And now we have an anchor tag in there that's a hypertext reference. And in the early days, they were all colored blue, and they all were underlined because people needed permission to click on things. We're so used to looking at pages that you couldn't click. Now everyone thinks hypertext is right, and you'll just click on everything. See what can I click on here? Well, in the old days, we used blue text and underlines to say click here. So when you click on this, your browser is a piece of code that's running on your computer. So this big white box is your computer, whether it's your phone or whatever. Browser is a piece of software like Chrome, Firefox, Internet Explorer, I guess they call it Edge now, Safari, Opera, Lots of browsers. Those are software applications that are your client that views the web. They're a browser. So the browser is an application. It's the thing that is showing you this page. And when you click on it, the browser on your computer says, oh, somebody clicked on a link. And it goes and looks to figure out what link you want. And then when it knows what link you asked for, it then makes a connection based on parsing that link. It makes a connection to the right web server on a port called port 80, which is the normal port for web servers to live on. And then it sends a request. It sends a little line of text that looks just like this, sends this whole line, says that is the document I want. Then somehow in this web server, this is the internet, right? This is the internet, and this is somehow on this web server, it either generates the response or reads it off of a disk or something, and out comes the response, and it comes back to us. And That response itself is in the format HTML, Hypertext Markup Language, just like I showed you in the view source. These are tags, end tag, 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 and then there is a hypertext reference here that turns this second page into, turns this first page into a hypertext link. And this one's purple because I clearly clicked on it before I took the screenshot. So when this HTML comes back, your browser parses it and then renders it. There's the document object model that's kind of in the middle here, that it parses it, puts a document object model, and it comes to your page. But that's the basic idea. You click request, page is done, response, parsed, shown, and you get the page. Click, request response, click, request response. Now, it's going to be way more complex by the time we're done. There'll be like many request response cycles, okay? But that's the basic request response cycle. Now, this is all governed by internet standards. And the internet standards come from a very open source and a very open culture. They were developed by a group called the Internet Engineering Task Force that predates what we think of as the modern internet, which is mid-'80s. The IETFs came from even the 70s, an earlier network called the ARPANET, and they came up with the idea of the IETF, Internet Engineering Task Force, and these standards. And these standards are open, they're free, they're unencumbered, meaning that anyone can read them and implement things that comply with these standards, and then as such build yourself a web browser or build yourself a web server if such a thing doesn't exist. Of course, these days, all these things exist and we just download them. But the sort of thing that governs the protocols that we all use so that our code interoperates are these IETFs. There's other sources of standards like the World Wide Web Consortium for things like HTML and CSS, but the protocol stuff is very much through IETF. Now, the fun thing about this is these are the name of these things are called RFCs, which stands for Request for Comments. And that's kind of a nerdy engineering acknowledgement that no standard is ever perfect. And even when they're done and they are 10 or 15 years old, or like 1981 to 2017, that's like 30 some years old now, they still might need to be improved. So that even though it's 30 years old plus, it's still waiting for comments. If you have a comment, if you find something wrong, or you have a better way to build it, then engineers want to hear about that. So that's kind of a fun, ironic naming conventions for these internet standards, RFCs. And so if you were to pick up, there's many standards that govern HTTP, the Hypertext Transfer Protocol. You go read them, and you could page down, page, and you will realize quickly that you don't want to write a browser. You'd much rather use a browser, but eventually you'll get down to a page way, way, way down that basically says how to make a request. And if you keep looking, it tells you that you're supposed to put the method, followed by the URI, a protocol version, and then end with a carriage return and line feed, right? That's what it's saying right here. The method token, which is going to be get in our case, followed by the URI, URL, ending with a carriage return line feed, etc., etc., etc. And so if you read long enough, you could eventually see how we're supposed to do that. And so based on how we're supposed to do that, up next, I'm going to show you how to manually hack an HTTP request. So now what we're going to do is we're going to try to dig even a little bit deeper in how these HTTP requests work, and we're going to make one up by hand. I'll show you how to talk to one by hand. So if we look at the RFC, we see that we make a connection to the server. In this case, we're going to go to data.pr4e.org. And I'm using the original old protocol from 1990. And increasingly, servers are refusing to serve documents using the old protocol. They want at least HTTP 1.1. But so not all servers do this, but this data.pr4e.org, I've got it on a special ancient server, so it always talks HTTP 1.0. So I can do this demonstration. HTTP 1.1 is similar. It's just a little more sophisticated, but it's harder to type it by hand, okay? And so that's why I use an old server that does HTTP 1.0. The HTTP 1.1 still has a get thing and a URL, and it just has more stuff afterwards that you got to put in. So, but let's go back to the basics, back to the way it was in 1990, 1991. And that is you talk to your server, you send a GET request, and hit enter, and then away you go, okay? So here's kind of what I'm going to show you. I'm going to use a command on my Macintosh called Telnet. Telnet predates the internet. It's one of the early protocols, FTP, File Transfer Protocol, SMTP, Simple Mail Transfer Protocol. Telnet was the way we logged into servers, but I'm going to connect to this server, but instead of connecting to the normal login port, I'm going to connect to port 80. Port 80 is where we expect a web server to be listening. And so if there's a web server, then it will connect, and then it will stop, and then I will type this command. Hopefully I'll type it fast enough for the server to not run out of patience with me. So I'll hit the enter, and this is exactly what the server is going to do. So I'm typing this, and the server is going to respond this. This is the request, and this is the response. And you can do this too, but realize that fewer and fewer servers talk the classic HTTP 1.0 protocol. It's so sad. But I keep this. This is my antique server that I can talk the old protocol. Okay? So I'm going to start this up. Oh, by the way, if you're on Windows, it doesn't come with Telnet, but the Bash shell probably might come with Telnet. I don't know about that, but you can Google how to make Telnet work on Windows, and so then you can do this on Windows also. You can write Telnet hostname space port name, and it should work. You should be able to eventually do this on Windows. You just can't do it out of the box. Linux, of course, this works perfectly on Linux and Macintosh right out of the box. And so now I want to show this to you in Telnet. Now, again, you have to do something a little weird on Windows, but on the Macintosh, it's easy. So I'm going to type the command telnet. This is just a local command, data.pr4e.org. So that's the server I'm going to talk to in port 80. And so there's all these web servers or mail servers or whatever servers, and there are ports, which are like phone extensions that tell you what application to talk to. And I'm trying to talk to a web server. And you'll see it's going to use that information to find the IP address, the actual address of the web server, which is 192.241.136.170. Now, it is waiting for me to type an HTTP command. And I got to type get, which is the verb that's give me a document, and then I have to type the URI or URL / data.pr4e.org page 1.htm. So this is what your browser is sending, http:/1.0. Now I have to hit enter, and then I have to hit enter again. So now the server responded. And so if you look, this is what I typed. I typed that, and I typed this blank line. I typed that, and then the server came back. This is the entire server response, and then the server closed the connection. That's Telnet telling me that the connection got closed. So this is a super simple protocol. I type 2 lines, and I get all this data back from the server. And this data can be broken into 2 parts. The data can be broken into a header part and a body part. And so there's a blank line here, and that's exactly what the protocol says. There is a blank line between the header of the response and the body of the response. And so the header is all metadata that the browser knows things like how big this file is. That's how big it's going to be. It knows that it's not supposed to be cached. It knows that it was last modified on this date, and what kind of a server. We're talking to an Apache server. Remember, I was talking about Apache in a previous thing. And this running on a Linux operating system called Ubuntu. And one of the more important things in here is this content type, which tells basically the kind of information. So right now this is an HTML page, and so it says the thing I'm about to give you after this blank line is HTML. But this could be an image or something else, and then we wouldn't be able to look at this very well. It would look like, but it would be really the image. And so if you're bringing pictures down or PDFs down or whatever, you get the actual picture of the PDF here. But because this is HTML, we get HTML, which has tags in it, and it's got its own little anchor tag, and an href, and some new clickable text, etc., etc., etc. And so this is sort of what the browser is doing on your behalf when you click on a link. Okay? So that's what happens. Those of you who've had classes from me before, you know that I am obsessed with the command line. And you may or may not have heard me told this story. This is a movie scene that was written by one of my former students. His name's also Chuck. And it was initially in The Matrix Reloaded, where Trinity is breaking into the power grid to shut everything down. And this is actually command line hacking. The scene was originally written for some kind of Minority Report-like UI, and he said that's not how people hack. People hack in the command line. just like I just did. And so part of all cool security hacking movies now is doing something in the command line, and that just reinforces how much I love the command line and how much I want you to be able to know how the command line works, just because it's super cool. And you can also take a look at the URL and watch that. Another part of this class ultimately is to get to know our browsers. And so I just showed you how to hack it, but you don't really need to do that. That's the hardcore way. Even though sometimes I do that to figure out what's really wrong, because I have to type the HTTP 1.1 protocol, which is harder than the HTTP 1.0 protocol that I just showed you. And so our browsers have this developer mode. Safari has preferences. Sometimes you have to turn these things on. So I want you to go turn them on, and I want you to be able to look at this stuff, because this is where you, as a normal web developer, are going to diagnose problems with your application. Because, like, did it screw up in the client? Did it screw up in the server? Was there bad data going back and forth? And so you're going to get used to this, believe me, by the time you're all done. And concept of developer mode, even if you're not even writing the application, it's fun to go figure out when stuff breaks, what's going wrong in someone else's application. And so let's take a look at this. So let me bring up my browser here. Take a look at a web page, www.dr-chuck.com. When I type that URL, that goes and does a GET request. But this is a much more complex page because it has pictures and stuff. And they don't come down as to all with one request. And so I can do view developer console, and I can see things. And so I'm going to go and take a look at my network tab, and I'm going to do this again. And so I'm going to highlight it and type enter, which causes that initial GET request to happen again. And then you can see all of the network requests that happen. Okay, and so what happened is, to generate this page, it did 71 request response cycles. And if I scroll all the way back up to the top here, this was the first one. The first one was a GET request. Okay, this was a GET request. It was a GET request to this URL, and 200 OK. Oh, I forgot to show you. Let me see if I still got it. I forgot to show you that the first line of this header response is an indication of it's good or not. 404, for example, says I didn't find it. So this was it did find it. If I had made a typo mistake here, I could have got a 404. Well, let me do this. I'll make it go a 404. I'm going to say get http://data.pr4e.org/page4.htm, which I know doesn't exist, http://1.0. So this is a URL that doesn't exist. This is what happens when your browser sends a request and it doesn't get a page back. See, 404 not found. This first line of the header. Again, I typed this stuff, first line of header, 404 not found, then the blank line. Now it says something about, hey, I couldn't find it, but also sends this 404 not found. Like I said, you don't have to do this by hand. You do it here. And it says, oh, you got a 200. And then it got all, remember the headers? The headers are sitting right here. Response headers. If I go to data.pr4e.org/page1.htm, there we go. So this is that page, and look, we asked for this URL. This is what we asked for. We did a GET. We got a 200 OK. The address this was the address. Away we go. And here's the response headers. We saw those response headers. They're pretty much the same as these response headers. And the HTTP 1.1. We used HTTP 1.1 in this one, and we actually sent a bunch of other stuff. This stuff here that says, you know, what my preferred language is, what kind of browser I'm using, et cetera, et cetera, et cetera. And so that's some of the data, this request header stuff. It actually goes right here. Remember when I typed that enter key? You know, there's a bunch of stuff that goes here, and then you type the enter key, and it's all these request headers that are communicating to the browser something about, communicating to the server something about what your browser is doing. You'll get better at this. So there's the request headers. Then there is the response, which is the body part, right? That's it's showing you the headers over here, and then the body over here, and then the preview if it has a preview, but we're not going to worry about that. So now let's go back to this one. So it got some page, www.drchuck.com. It was a GET request, 200 OK. This is the IP address of that server. And we can take a look at the response, and it's a bunch of HTML, blah, 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 some CSS, blah, 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 blah. And that's the first page. Now, the problem is in this page, you know, we haven't done HTML yet, but in this page somewhere, there is a picture that says load this image. And so it reads this as your browser is reading and parsing this. It's, oh, I got to go get a picture. So it goes and does another request response cycle. So here's the request for drchuck.com, Ian Dolphin small JPEG, which is that little picture in the upper left-hand corner. And it got a 200 OK because it already received it once. And the response, it was an image JPEG. Remember, the other one was an image text HTML. And so that's the response headers. I don't know if I can see a preview. Yes, you got to see a preview. It would look yucky, so we don't see the actual text of the actual response. So there's the second request. Then it went to this rate my professor picture, then some other thing, and on and on and on, away it goes. And it just read that, and it just had to get all kinds of other things, JavaScript and widgets. Now we will eventually write applications as that do lots of these things. And like I said, eventually, it did 78 requests to get this page constructed. So there's a lot of things that you can do, and some of the early assignments will be asking you to do things with this developer console, again, so that you can really get to understand the request response cycle. So we have so much more to learn. Technologies in the browser, HTML, CSS, the DOM, and JavaScript, jQuery. In the web server, we got our web server, PHP, MySQL, all these things. We got so many things. And this is a picture that you're going to get tired of, because this is my favorite picture in the whole world, because I can tell you in this picture about the browser that has a document object model, and I'll draw pictures that look like this. And don't worry. So this is where HTTP happens. So there's the network. And then often the database server and the web server on different servers, and there's SQL that goes back and forth between them. Even if they're on the same server, it's kind of like a virtual network connection. There's the SQL software. There's the Apache web server. So you will click on a request. That request will be sent to a server using HTTP. Then maybe that will have some PHP that comes in. It goes and runs the PHP. It makes a connection to the database. The database reads some data, comes back, sends some stuff back, does a response. The response populates the object model, maybe runs some JavaScript, which also messes with the document object model, and then you see the document object model. You don't have to know this right now. I will hit this almost every single lecture, because in a web application, the notion that there's a browser, there's a web server, there's a database server, and there are different things going back and forth, and that web developer console is really looking at this area right here. And so you have to debug so many things, and there's a way to debug these things and debug these things. There's just so much more. And it's so cool. It's so cool. When you really understand how this works, then you can use any web framework, any browser framework, and this notion of database backend, web server middle, and browser. So again, this is not the only way to write applications, but the concept of the web browser and even mobile applications have kind of like these three layers sometimes, where they have code that runs in the mobile device, server code, and then database code. And so there's a lot to understand, and we'll just start picking this up one thing at a time, build a whole bunch of building blocks, and then put them all together so you really understand how web applications work. Welcome to our lecture on HTML. My goal in this lecture is not to make you the world's greatest web designer or a front-end expert. I just want to teach you enough HTML so that you can sort of do the rest of this class. Because the rest of this class is like, here's some HTML, and now we're going to come up with cool ways to make more HTML. And that really is the theme of this class. I never tire of this particular picture, but you might get tired, because I always want to place everything we're doing in the right context, right? Because there's really three major pieces of software and two network connections that sort of govern everything we do in web applications. This is you out here. Okay, so you're sitting there, you're sitting in a browser, you got a keyboard, you got a mouse, you got whatever, right? And you have a piece of software running on your laptop. So this is your laptop. Then that talks to, over the network, to a web server, and we're going to run PHP and all kinds of things in there, the Apache web server. This is like Chrome. This is Apache. And then we have MySQL, which is often on a third piece of hardware and a network connection, even though when you're doing your own development for this class, these two computers will be the same, but they still talk to each other over a virtual loopback network. And so here we are. The document object model is the thing that effectively is the view. And HTML
is when you make a request and somehow it runs in the server, maybe it reads some data in a database and it comes back, and then the request comes back, HTML is the format of that request, and then it gets parsed by your browser. It reads right through those things, looking for less thans and greater thans and all those things that lead to sort of a set of pixels on the screen in the little image that you see. And so this is HTML. And so HTTP is the protocol we use to retrieve these documents, and HTML is the format of those documents when they're retrieved. And so HTML is very much a browser thing. It tells us how we create look and feel in the browser. And the idea of HTML, it's a way to mark up text. And if you're old enough, you remember things like word processors with reveal codes. Now that really reveals how old you really are. But the notion of saying this is bold and this is italics and this is normal text, that's just something that you need to do in any kind of word processing. And so one thing that's cool about HTML is they came up with a format that you can actually look at. And so if you dig deep into Microsoft Word, you might find in a doc file it's some weird thing you can't look at. But HTML, it's internal format. It's an internal way of representing the markup that talks about the look and feel of a document, except you can look at it. And I, as a programmer, I just love to look at stuff because then I can write a Python program to generate HTML or another program to generate JavaScript, because you just know what it is because it's really just text. But then we have text that has meaning. And so the tagging is meaning. So less than P, greater than P says start a paragraph. Less than strong, greater than start bold. Slash strong says stop bold. So again, we tag them, and less than and greater than and slash are special characters. Now we have ways to represent those, and we'll talk about that in a second. But the idea is this is a user viewable markup format. There are many markup formats. Word documents are a markup format, although there's docx, which is XML, so it's easier for you to see what's in XML. And so the web started out in the early 1990s. It became popular in 1994, and so we're over 20 years past this. And it kind of helps to understand where we're at and understand why HTML is the way it is it started out in a really small effort. And so a group of two people, Tim Berners-Lee and Robert Cailliau, invented sort of the first round of the web in the 1990s. And they weren't a gigantic company. They were just two people. And so they had to build simple things. And so we are in their debt because they were engineers that engineered something easy. And so now we get this richness of what we can do with the web, but at the core level, it's kind of easy and beautiful. Now, it's important, if you watch that video of Robert Cailliau, that the web, when it was invented in 1990, was not exactly the web that we have today. The web was really very much for serious documentation, serious kinds of things. It wasn't really intended to be sort of fun and frivolous and entertaining and to watch movies and to consume information. That all came later. And so HTML was a sort of it was a workhorse. It was designed to get some stuff done, to show pictures of design documents, and images opened in a new window, and it seemed like it made a ton of sense to do that. And I have a video of what it was like actually to surf the web using one of the early Mosaic, a piece of software circa 1994 that I regurgitated. I found some old source code and I made it work on a Mac, and I'll show you a video of all that. But even sort of from 1994-95, then the web evolved a great deal after that. People were just amazed that there was a place on the screen that you could click and you would go somewhere else. I mean, that was enough. We were excited. And so you see all these blue links that are underlined that really are saying, click me, click me, click me, click. Please, I'm a page full of useful information. Please click me. Now, this is functional, and I recall in 1996 when I would see this, I'm like, oh, so beautiful. This is the future. Well, this sort of was the future in 96, but then what happens is that as people that are not like me use the web, it had to be prettier. And so it's evolved a lot. And the good news is sitting here in 2017 or later, so much good stuff is done that we're not even going to teach you the bad stuff. I'll show you a couple of bad things, sort of these old thing. But we're at the point now where web pages are powerful engines of commerce and money. And they do things in Yahoo where they count the number of pixels in this little white bar, and they will add one and subtract one and decide if people like the page better based on the number of pixels. And all they're doing is they're figuring out what is pleasing to us, and they're optimizing to make very pleasing user interfaces. And compare and contrast that obsession with beauty with, hey, the click works. That's amazing. And CSS is a big part of this, which we'll talk about in an upcoming lecture. And so in the good old days, HTML was really tolerant. It just didn't matter. You could have tags that didn't finish. You could have all kinds of things. You could have uppercase tags. You could have attributes that didn't have double quotes on it. You didn't have to put a /li at the end of this thing. All these uppercase tags. In the old days, the browsers wanted to be friendly. They didn't want to show broken, right? You didn't want to oh, bad page, don't look at said page, right? And so the browsers were really tolerant. They let us, a lot of HTML was built by hand, and people were would make mistakes, and the browsers wanted to fix those mistakes and show us, relatively simple code. Now, in 1994, 95, 96, the idea, it was very, very clear that this HTML and the web was an engine of commerce and productivity, et cetera, et cetera, et cetera. And so it became very important for us to build standards around that. And so Tim Berners-Lee, one of the other initial creators of the World Wide Web, moved from CERN to MIT, Massachusetts Institute of Technology. CERN, of course, is in Switzerland. It's a physics lab. It's not a computer science place. MIT is more of a technical computer science place. And so the home of the standards for the World Wide Web is an organization called the World Wide Web Consortium, or the W3C, that comes out of MIT. And so HTML moved from a thing that a couple of engineers put together at CERN to solve a problem they had to solve to something that became a foundational technology for the future of industry. So HTML started getting revised, more professional, more clear. So we got HTML1, we have HTML2, 3, 4. 3 didn't last very long, 4 lasted a long time, and now HTML5 is what we're using today. And so this has been something that the World Wide Web Consortium has been guiding. And the whole idea, and if you look at my Internet History, Technology, and Security class, you will see that this whole thing was actually fraught with peril, right? And the World Wide Web Consortium was the good guys, and there were bad guys, and Microsoft was good guys in that particular one. But this is not a history class. Well, it's a little bit of a history class. I can't help myself. But the World Wide Web Consortium was founded and underpins all the things that we do on the web today, and really enables all the beauty that we see on the web, and yet it's still simple enough to understand. Part of the problem is in the interim years, like 2000 through 2008, it was just kind of a mess, and then finally it got cleaned up about 4 or 5 years ago. So there's just some rules now, and so the World Wide Web Consortium said this is what HTML should look like, and things like tags have to be lowercase, okay? All tags have to start and stop. If you have an attribute, it's got to have double quotes around it. And browsers will still tolerate all kinds of mistakes. Okay, here's a paragraph tag, beginning paragraph, ended paragraph, list tag, /li, etc. And so now, because of the sort of maturing of this whole thing, we now have rules that we follow, and that in the old days we used to do sort of all kinds of irresponsible things when it came to the web. So up next, we're going to talk a little bit about how HTML documents are put together and a little more detail in HTML. So now we're going to talk a little bit more detail about how HTML works. It's just some more of the things. And again, I'm not trying to make you an expert. So the first thing to talk about is the fact that there are 2 basic parts to any HTML document. There is the HTML tag, that is in effect, scopes out. The doc type talks about the different versions of HTML, and I think a lot of people are starting to just not even put doc type out, but you might. HTML tag sort of is the whole body, the whole document, and then there is kind of like an HTTP, there is some metadata in the document that doesn't actually show up, but describes the document. We load CSS in here, do other things, and then the body is actual visible stuff. I'm not going to show all this in every one of my examples, but understand that a page itself kind of is supposed to be bracketed in a HTML tag with head material, which is metadata, and the page content that is in the body tag.
You'll also notice as you start creating HTML files that there are some files that are special. So if you have like a URL that points to a directory, like blah, 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 /ABC, which is just a folder, and ABC is a folder, then inside this folder there might be a special file like index.html, index.htm, or index.php. And so this is part of that Apache web server. It has a configuration that says if someone navigates to a folder, go look up a particular default. And usually index.htm these days is the most common one. Index.html is kind of old. In the old days, there was kind of like a la-di-da. The Unix people had more than 3 character suffixes. And so this was like the cool Unix people, and this was the non-cool Windows people. But now Windows can have longer suffixes, and so everyone just kind of gave up and uses index.htm most of the time. So you'll probably build most of your files that are HTML files with a .htm suffix. Of course, later we'll make PHP files that dynamically allow code to run and dynamically generate HTML. And that's something that we will do in an upcoming lecture. But there is a way when you're using a web server like Apache, which means you're in a browser that's localhost or, blah, 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 then Apache, when you go to a folder, it goes and gets the file name as the default view of that folder. So you can also put multiple files in a folder, and so you have kind of this index, in this case, index.htm, which is kind of the file that is shown to the browser if the folder is navigated to, and other HTML files, which you can link between these, and then perhaps even image files that are in the same folder. And so, like I said, you can have all these tags. HTML has all these tags that allow you to mark up, and they start and they stop, and you put bold, and then these basically show bold or italics or whatever. Now the other thing is that none of the new lines or the blank lines or the end lines inside the HTML actually matters. Unless you work extra hard, the browser wants, as you resize the width, it resizes these things, right? So this is not exactly precise presentation that says put the letter A in the upper left-hand corner and put the word the here and put the word developer there. No, we basically allow within paragraphs the wrapping to happen dynamically. And so this allows us, depending on, if this is a really tiny screen or a large screen, or maybe you've got a bunch of windows open on your computer, a lot of HTML will rewrap automatically. Now with CSS, you can do things like put solid margins on things, and some folks like to build websites that don't wrap. That's actually sort of a stylistic argument, but this is not a design class. For now, unless you do otherwise, content will be wrapped dynamically. Tags have beginnings and end. So anything in a less than, greater than pair is a tag, and a start tag. An end tag is basically the same name as the start tag with a slash. And so this is like start bold, end bold. And it applies to the text in between those tags. Another thing you can have is attributes on tag. These are called attributes. They're key value pairs. So this is an image tag. And so this is also a self-closing tag, because this basically says wherever we're at, put this image here wherever we're at. And where do you get the source? Well, that is the image file sitting in this same folder that's going to show up in this image. So these are attributes. You can have more than, you don't have to just have one of them. You can have as many attributes as you like. You also need to be able to put in things like less than and greater than, because in effect you're writing code. So HTML is very simple programming. It's very declarative programming. It's relatively easy. You can kind of look at it and go, oh, I kind of get what that's doing. But in this programming language, less than is like code, right? And greater than is code. So how do you do this? Well, we've got these things called HTML entities, and ampersand is also a special character, but it's used to escape these HTML entities. So ampersand less than semicolon becomes less than. Ampersand greater than colon becomes greater than. Oh, what about ampersand? Haha. Well, we got that too. Ampersand amp. And then there's some other fun things, and you can put special characters and smiley faces and various things like ampersand, heart, semicolon, and go look up all these things. These are called HTML entities. I actually like these little arrow guys, because then I don't have to have images for arrows. I just say, hey, be an arrow, a left arrow, an up arrow, a right arrow, and a down arrow. And that just, our browsers will show you that. And that's really just a character. And of course, for kids these days, you can make emojis. So emojis also, many emojis even have these kinds of things in them. And so it's cool. Who knows, eventually we will find that
these old characters 100 years from now, we like, what? That's like what ancient people used to write on cave walls. We only talk in emoji now. But who knows if that'll happen. Okay, HTML comments. Any programming language needs to have some kind of a mechanism to have comments. Less than, exclamation, dash, dash. This is the beginning of comment. And then dash, dash, greater than is the end of comment. These can go across multiple lines. And this basically is something that shows up in the HTML source, but has no effect on the HTML output. And if you're a programmer, you kind of know that comments are sometimes there to say something, or sometimes you use it to sort of like comment something out. Like you comment this out by putting less than, exclamation, dash, dash, and then dash, dash, question. And then all of a sudden this sort of ceases to exist, except you really didn't want to delete it. You wanted to suppress it because you're testing something. So you can use comments either for annotations for future developers. I once saw an organization that basically had less than, exclamation, dash, dash, a big thing in their web page that was, if you are reading this, you might be the kind of person that wants to apply for a job at our company. Here is the URL for our job application. So it's like, oh, who's viewing the source of this HTML page? And if you're that kind of person or running it in Developer Console, then maybe you're the kind of person that wants to work for our company. So people put all kinds of secret things. The University of Michigan page at one point had like a comment in it that had a big block M in letters, written out in letters. And so that's just like, that's like an Easter egg. So sometimes people put Easter eggs inside their HTML comments, but we're just programmers. You can put an Easter egg in if you want. Okay, so let's talk about links, because HTML stands for HyperText Markup Language, and HyperText is links to other things. And so that's the whole idea. And literally these hypertext links are like why search engines work, it turns out. I mean, without hypertext links, there would be no search engines. I mean, it's great for navigation, but it's even greater for search engines, because search engines effectively look at the links as the way to A, discover content, and B, the way to determine which content is more or less relevant. And so it is really kind of very, very, very important stuff. And so when you build pages, the pages that you link to, you're creating sort of collective knowledge. Each website that you build that connects to other websites, in effect, contributes to the collective knowledge. So there's one tag that allows you to do links called the anchor tag. And that's the A for anchor, and it has an attribute. So A and then href is the attribute. Remember, this is the tag, right? Href equals, and then attributes have to have double quotes, and then you can say a URL. And what you're basically saying, and this is the text, so there's a beginning tag and an end tag. This is the end of the beginning tag, not the end tag. This is the end tag. So between the beginning anchor and the end anchor is the text that's going to be highlighted. And you'll notice that because I haven't used CSS, it's styled as blue because I haven't clicked it yet, and underlined. Okay, so blue and underlined, and says when I click it. Now this is a piece of software, in this case it's Chrome, and it's a browser, and this software is running on your computer, and you're moving your mouse around, and it's something like click. Now then it looks at this and says, oh, what did you mean to do? And that's where the request response cycle, which we talked about in an earlier lecture, happens. Okay, but that's an anchor tag, how you say this text is supposed to be highlighted, and upon click, go to this place. These links can be relative or absolute, and so if we're in a particular folder and don't put the whole HTTP, you can put just the relative, which is a file in the same folder. And so we can go back to the first page. I clearly have clicked on this because it's now purple. The default styling, for better for worse, again, you have to go back 20 years to realize why we do this by default. If it's purple and underlined, it's a link that has been clicked on before. Part of that was keep on going and explore new parts of the World Wide Web. That was back when the World Wide Web was small enough that we tried to get you to go places. Now you go places. Now all of us go places without really thinking too much. And so these are just two example anchor tags. They're anchor, the start tag. That is the start tag. This is an end tag. And then this is an attribute in that. And we can either have a relative or absolute link. So images are another part of this. Actually, if you go and you can find perhaps the original arguments, whether or not images were supposed to be inlined or not, in, 92, 93, 1992, 1993, there was an argument that we shouldn't have images on the same page as text. And it used to be that all images would open up in a new window. And that was a fierce argument, and the images within the text won. And so the image tag, I probably should put a slash here. I missed that slash. The image tag is sort of like the anchor tag has text that it sort of starts and ends, right? And so the image tag is like a character. It's more like a character. And so you say images can be right in the middle of text, and so this is like images can be right in the middle of text. So you can think of this as grab this little tiny image and stick it in the text, and it reflows. And if you change the width of this, it would reflow everything, and away you go. Now you can actually, if you think of the image as kind of like just a super special awesome character, small, medium, or large, I put this image in the middle of an anchor tag. So here's the start anchor tag, here's the end anchor tag, and the clickable thing is this little link. And so you can go do this and play with this code on, code images HTML. You click on that thing and it will go to list.html. So you're just going kind of back and forth. And all this stuff is up there, and you can play with all of these URLs at webapplicationsforeverybody.com. This is a list. It's another thing to talk about. So lists of things, there's a couple different kind of lists. There's lists with numbers and lists with bullets. We do a lot of lists. And again, we're kind of helping things like Google figure out semantically what this page is about. This is somehow some roughly equivalent set of stuff. And so this is going to be an unnumbered list. That's what the UL means, which means it's going to have bullets. And so unnumbered list, and then LI to /LI. And so LI is the list item, and so that's just telling you when to put the bullets in and when to sort of break the justification. Now, and you'll see that I also have a paragraph tag, and that's because the default styling of list items does not put any white space in between things, and so the paragraph says put some white space. So this white space here is coming from the paragraph, not the list tag. And so if you just do this, you can do it without the paragraph tag, but you won't get this white space, and it'll look kind of whatever, so it'll look kind of tight. And so the rest of this is just HTML, some anchor tags, et cetera, et cetera, et cetera. This whole little sample stuff is so you can kind of click back and forth and view source. Usually you right click and view source, and you can see this from that page. That's one of the wonderful things about HTML is however clever someone was in making an HTML page, you can always view source. You might have to turn that on in developer mode so that you can view the source of the web page, but it's really, really useful because you can see everybody's cool tricks. Tables are an important part of HTML for tabular data. In the old days, I know I keep going back to the old days. In the old days, tables were used for graphic layout, but that was like super tacky. Now we use CSS for graphic layout. That's the next thing we're going to talk about. But turns out that there are still tables, and so tables are like grids or spreadsheets, and it's just a set of markup patterns that tell us how to mark up tabular data. And so we start with a table tag and end with a table tag, and a table has a series of rows, 1, 2, 3 rows. Civic's not showing up down here. And so there's a header. There's actually there's a T head that I probably should have put in there, and the first row is this header row. And there's a TH and an NTH, and that's basically, making a little grid. You can control with CSS the width of these things. Otherwise, it's actually just like it's resizing these things, it resizes these as well and finds ways to fit them on the screen. Now this is all small, so we're not really overloading it. But if I made one of these things super long, it would sort of expand these things dynamically. And again, with CSS, you get a lot more control over this. And then now we have a row of data. The TD stands for table data /TD. So that's one little grid item, one little grid item, one little grid item, grid item. So those are the grid items. So these tables are pretty easy to do, but you only use them when you really have a table of data. When you have a table of data, like a bunch of rows or courses or all the students in a course or something, you want to use a table because then that is the most semantically accurate way of representing the markup for a table data. And so you can play with this sample code. Go to webapplicationsforeverybody.com/code/HTML. If you set it up, you can go here and you can right click and you'll see a thing that says inspect element. And you can go find it down here and look at this, and you can play around, and we will, over the course of this course, we will learn more and more about this developer console. But for now, we're just kind of playing with the source code. And again, if you've got it set, you can also do a right-click View Source, and then it will pop up in another tab the actual source. And so the source is pretty much exactly what the web server sent back to us, and we'll later realize that this is the actual document object model, which is the thing that you're viewing. And for simple pages, the document object model and the source are one and the same. But after a while, when we start fooling around and change the document object model in JavaScript, we will see situations where this stuff changes, but this stuff does not. But we're kind of getting ahead of ourselves. And so there's a view source view of this, and there is the inspect element view. You will learn to use both of those at the right times. And so that's sort of a zoom through HTML. It started out as a beautifully, elegantly simple. I mean, we go back to Tim and Robert, and it's so beautifully, elegantly simple, made by engineers who were limited in their resources. And then what we've done is, without really throwing it away, we've just evolved it to be super beautiful and super flexible. World Wide Web Consortium and many others have really made HTML and CSS a powerful, powerful formatting mechanism that's very easy to use and extremely flexible with a high degree of control. So up next, we're going to talk about CSS and cascading style sheets.
Hello and welcome to Web Applications for Everybody. In this screencast, we are going to play with some of the sample code, and you can either download it and play with it on your own computer, or you can look at it in your text editor, or if you just want to browse it, you can browse it here and take a look at the version that I'm using. It's really been intended that you look at this in the developer tools, and so you can do things like, say, inspect element. And so here we are. This will also be a little more valuable even when we're doing CSS, but you can see the document object model. Now, the interesting thing here is it shows something I'm always talking about, is the difference between the document object model and the source code. So this is the document object model. It's kind of stylized. If you look at the source code, you have to say view page source. And so the source code, this is literally exactly what's in the file. And if you go look at this file in a text editor, you will see this. And if you're looking at it here, it doesn't quite look exactly the same, and some things have been done a little bit differently. You know, they kind of got this extra stuff. And this is kind of after the browser has looked at it. And we start talking about JavaScript and changing some of this dynamically, you'll see this part is the document object model, but the source never changes. The source is what was originally downloaded when the server sent this back to us. So let's take a basic look at this. I'll hide this unless I need it. I'll go back and forth between the source. So we have a basic document, HTML, with a head tag and a body, and then a header. And of course, here's our header. We're using default styling, and paragraphs are an important part of things. You can squeeze this up as much as you want. White space sort of doesn't matter, right? So this white space kind of doesn't matter here. The fact that this has got extra space, it doesn't much matter. And so you can see an anchor to a strong tag that leads to a boldness. Let's just go ahead and look at it here in the inspect. We'll go down here, we'll find like a strong tag, that's the bold. We got an emphasize tag, and if you look a little farther, you'll see there is the anchor tag, which is the whole anchor tag is this whole tag from the A to the /A list.htm. That's where we're going to go if we click on this text right here. And so you can see, now this is a relative link, and it turns it into an absolute link, and that's because the browser knows where we're at, and so it sort of prefixes everything up to that to the relative link. But that's nice, because if we look in folders, we will see that these folders are all here. Here, let me go find you that folder. It's pretty deep in my... Later, this will all make wonderful sense to you. I do a lot of stuff with web. Code, HTML. Okay, so here we have, after all that, here we have the files, right? And so this is index.htm, and Index.htm is right there, and list.htm. And so if I click here, I'll go to list.htm, and that'll pull this other file up. And so these guys are all in the same folder together. It just means that I can use relative links to go moving between them. A tag that's really becomes more important, especially as when we're talking about writing code inside HTML and showing people code, is the pre-tag. And so the pre-tag, and you can just say inspect to hop right down to where the pre-tag is. The pre-tag respects spaces, so all these spaces happen, the new lines happen, and it also shows it in monospace font. Now you can change all these things once we get to CSS, but pre-tag, when we're printing debug out from, not in files like this, but when running code, sometimes it's good to print debugging out in pre-tags. So let's go to the next page. And so here's a whole series of things we're going to play with. This is a unnumbered list. This whole thing is an unnumbered list from top to bottom. So when I highlight this, you see the whole beginning to end of the list. Then each item in the list has a start and end li tag, right? Down, down, down. So here's this. We should learn about tables, and there's a href. There's another relative link, and so this is sort of my jumping off page to get to all those other things, right? Learn about tables, etc., etc. And so you can see these. We probably use just to take a look at the source code of this page. And so that's the source code that I typed in, and you can see the li tags, the p tags. I'm putting p's inside of li's to get space. Let's see if I can sort of show you that. So if you look at this and you look at the li tag, the li tag is that, and the paragraph is what actually creates the vertical and horizontal space, right? So that orange that you're seeing, that's paragraph. There's space that the paragraph tag has preset. So that's how I do that, putting paragraphs and hrefs. And so that's what this all looks like. So let's take a look at special characters. And so this is an interesting thing because it's not really what came out, because less than requires ampersand LT, but it's kind of processing that. So let's take a look at the source code to this one, because that'll be more instructive. So ampersand LT, ampersand GT, ampersand amp. This is an ampersand in HTML, and then just the letters AMP semicolon. Semicolon's not special. There are only really three truly special characters: less than, greater than, and ampersand. And you can put all kinds of fun stuff: clubs, hearts, and diamonds. And so you got the clubs, hearts, and diamonds, some arrows, stuff like that. What's nice is browsers just have these built in, although they're not necessarily the sexiest or coolest things. And I think what happens when I go back on this link is I go back to the list. So that's just special characters, and you'll notice that the default styling that says we've seen this one, and this is how the web worked 1,000 years now, back in the 90s, is you sort of, oh, it's kind of nice that it's turning purple. And you'll notice that Google does this as well when you're doing Google searches. It actually lets the links change color after you visited them. So let's take a look about links. We look at links. I'll view the source of this guy. Absolute link, ahref, right? And then /a. This is the clickable text, right, between the beginning tag and the ending tag. The attributes are on the beginning tag. Another attribute that you can add, and I do it all the time, is target equals blank. And that basically is the way we say, open this up in a new tab. So you'll notice pop up in a new tab. And so that's where that one goes when it pops up. And so you can decide whether or not you want this to go in the same page, back, or in a new page. And then I got to close the tab to get back. And now I'll go back, because that's just a relative link to list.htm, so I can go back and look at the next thing. Let's take a look at how images are represented. So so this is just a paragraph that has an image in it, right? So it's a paragraph, but there's the image. Source equals medium.jpg. If you look in my folder, You see the image right there, medium.png. You don't see the suffix because Mac is trying to hide it from me. And so that's just, you see this space here and here. The image doesn't have any space. We could add some with CSS later, but the paragraph is what's adding that space. Then we have just a regular old paragraph. I'm not supposed to use a center tag. We'll get to the how to center stuff, so that's what that is saying right there. And you can have an image that's right in the middle, so you see where that image is. I think of images, if they're right in the middle of text, they're like a giant character, and so that's how that works. And you can even sort of stick an image as the thing inside of a link. So here's the anchor tag. It's that bit right there, and then the anchor tag body is an image. And so if I click on that, it's going to go back to list.htm. You'll notice these all go back to list.htm, so I can work on the next thing, right? Tables. Again, you're not supposed to use tables for laying out like blocks of text, which we used to do. We used to do things like use tables to draw borders around things, which we'll see in CSS. But now that's totally verboten, and you're supposed to look at tables in a way that they're, you know, nice and pretty. So let's do a view source here. So let's see, there's our table, our slash table, and a table row. Now let's take a look at the DOM. So apparently I didn't put a T body. We're supposed to put a T body in there, and I didn't do it, but this is the DOM. The DOM put it in. That's put in by the parsing, and so clearly I made a little mistake in my HTML because I didn't put a T body tag, and so that was added by the browser as it was parsing and reading through this. Like, oh, he forgot his T body, so it just like slapped one in for me. And I think the mistake is this is my header row, and I think that should be like a T head. So there I go, bad HTML. It's the story of my life. And then I've got the rows, and you'll notice that the DOM is kind of prettier. So sometimes I do this. The DOM is indented nicely. So this isn't really the source code. This is the data that represents this visual, right? It is the thing that you're seeing, but it read this from the file or from the server, parsed it, and produced the document object model. I only say that like a million times. Okay, so back we go to the lists. We're making pretty good time. So here's some really bad HTML. I'm going to view source on it, and again you'll see sort of the difference between the document object model. When you're debugging these things, you will have to sometimes view source. Sometimes document object model will be the only way to debug it, and sometimes view source. So this is the one that's got bad stuff, like H1 is uppercase. This paragraph tag is not terminated. This UL tag is uppercase. This LI is not terminated. I don't have double quotes here. So there's a series of mistakes that I've made in this HTML, but it looks pretty good. And you'll notice in the document object model, it's fixed all that. Now, each one is lowercase. The P tag is finished. There are double quotes, meaning the document object model is not just your HTML source code. It's like the sensible, parsed, pretty version of the HTML source code, you know. And so, you know, this UL tag, these LI tags are now done. The UL's lowercase, everything's lowercase. So it's like, I'll take care of your mess. I'll patch up and fix your HTML, and then I'll display it for me and make sense of it. So the document object model is not the same. It is sort of like a sweet, awesome, better version of it. But this is what changes that. So let me just show you something, how I can change the document object model. Let's see. Let me see if I can change this text. I change the document object model. That changes. So I'm actually, but that didn't change the source code here. The source that it was retrieved to produce it, but I can change the document object model. And later in the class, we will write code that will actually change the document object model. So we'll change this. We'll call this be going to lists yet again. So I can change the document object model. Doop. So you see it changed it. So when we change document object model, what we see in the browser changes, but the source doesn't change. Did I say that enough times? So let's click on this and go back to lists. Okay, so some HTML can be broken so badly so that it doesn't render at all. Whoops, that didn't work so well. I'll do a view source on it, and then I will let you figure out why this doesn't work, why this doesn't show. You take a look at the source, you figure it out. I hope this has been helpful to you. See you on the net. So now we're going to talk about cascading style sheets. Like our lecture on HTML, my goal is absolutely not to make you the world's greatest graphic designer, because that is a lifetime of effort all by itself. I want to make you just kind of a crude cascading style sheet hacker. This class is kind of a back-end development class, but we need to know enough about the front end so that our back-end stuff looks kind of roughly like it. And that's kind of one of the cool things about CSS is the back-end developer should know enough CSS to make it so the thing doesn't look dismal, and then just hand it to somebody, because that's this whole idea of the separation of concerns, is that it allows things to do. And so here we start with our picture of the universe, right? Browser running on your laptop, web server running in the cloud somewhere, or perhaps on your laptop. Sometimes all these are running on a laptop when you're doing development, but web server, database server, talking HTTP back and forth, talking SQL to the database server. So we hit click on it. We go get an HTML file. The HTML file comes back. We parse it. It starts parsing in the DOM. But one of the things that happens is there is a reference in here to a CSS file maybe. And so then it has to go, oh, hang on, I got to go get that CSS file. It pulls that CSS file in, and then the CSS affects the DOM too. And so the combination of the CSS plus the HTML lead to the pixel perfect layout of what it is that you're seeing on that screen. And so in CSS and HTML, we are still focusing on defining how the browser is going to render stuff. Soon, we will be learning how to code stuff and how to talk database. But for now, we're really talking about the browser. And that's why a lot of this sample code doesn't even have to run off of a web server, because we're not really doing anything dynamic. When we start doing dynamic stuff, you have to have a web server. But here we don't have to have a web server. So if you're going to have Firefox, there is a bit of code that could be really useful to you, and you probably use Chrome. But some of us use Firefox in addition to Chrome, because there's some really cool things that you can do with the Chrome web developer tool that's not the same as Developer Console. It does a lot of cool things and lets you debug your CSS quite nicely. So you might want to go to Firefox and install this and use it. Or actually, it probably works in a bunch of different things. So that's different than just the web developer console, because it's very much about CSS and other design things. So I've said this before, HTML is very old, well over 20 years old now. And it started sort of with this gray background and blue links and underline, and we were just happy to have a list of things, right? The stuff we talked about in the previous lecture. There's an LI tag, there's an anchor tag, there's an image tag, and not much else, right? Not much else. And now we have this sort of beautiful corporate, commerce-based, end-user-oriented, money-generating UI look and feel. And so CSS is that which enables this beautiful look and feel. And like I said, I'm not going to tell you how to be good at CSS. So if you were to look at my website, webapplicationsforeverybody.com, and use the web developer plugin to shut off CSS, that's one of my favorite things to do, is shut off CSS. And what happens is when you shut off CSS, you see the navigation independent of the styling. And one of the things you should do for your website, for accessibility and for many other reasons, is have what's called semantic markup. And that is, your markup without CSS should still make sense, right? And so if you were to look at this with turning CSS off, you would see that there's links, and there's a list of links. And this list of links really is this list of links right here. Isn't that pretty cool? And then there's another list over here. And look how pretty this, I mean, literally, if I wasn't trying to impress you with this website, this is a completely functional website. Oh, and yes, there is, the next thing you see is a video, and then you see some stuff, right? And the thing that's interesting about this, for those of us who are not visually impaired, is for visually impaired people, this is exactly how they see your website. They see none of this, right? They see none of this little, ooh, look at that little cool shading. Isn't that so awesome? Well, no, you can't see that. That's for visual folks. And so this is where you want to separate the visual elements from the semantic elements. And it's not just for people with limited vision. It is for us itself. And as developers, we want to keep this as pretty and as simple as possible, and then allow a really good graphic designer to create the beautiful look and feel. Again, as back-end programmers, we have to make it so it doesn't look crappy. So if you look at all my websites, you can clearly see that I'm far more a back-end developer. I use Bootstrap and the simplest CSS. It doesn't look shamefully bad, but it also doesn't look pretty. Somebody someday might help me and actually make beautiful CSS for this. My goal is to build really beautiful markup and then have adequate CSS so it's not shamefully bad. And then have someone more talented than me make it really beautiful, like say that Yahoo page. Someone very talented really made that beautiful. That's not me. I don't have that skill. Not at all. So if you look, ultimately you have sort of this HTML, right? And it has CSS that it loads, et cetera, et cetera. And in these CSS, there is all kinds of highly detailed markup-y kinds of things of how much space, how wide this little gray bar is, and what font we're going to have for that, and how much space you're going to have here, and how much space you have here. All this is in this CSS, okay? And so you can think of the browser loads the HTML, the browser loads the CSS, and combines those two things together to produce pixel for pixel for pixel, the beautiful, visually beautiful look and feel. But it's important to keep your HTML technically beautiful, or semantically, it's semantic HTML. And so again, we have the sort of the back end and sort of slightly front end developer, which is really what this course is aimed at. You know, we're going to generate some HTML. We're going to try to make this as simple as possible. We'll pull in some CSS, and that's going to tell how to make these things work. And in the CSS is a set of rules that say, you know what, you see that body tag? This is what I want to happen on that body tag. See that paragraph tag? Any paragraph tag? This is what I want to happen on that tag. See this anchor tag? Oh, there's no anchor tags. Sorry, no anchor tags. But you get, oh, here's H1 tag. See this H1 tag? See that? I want that to be blue. And so, but these are two files. And so what happens is I code this up, I build this, and I build a really bad CSS that just gets me through the day. But then I can hand this, and then someone else can just edit this and refresh and make it prettier and prettier and prettier. And so it allows, and sometimes you're both the developer and the designer, but it also allows really talented developers to really specialize in building this, and really talented designers to specialize in making developers look really good. So the CSS syntax is very different than HTML, and it's also different than PHP, and it's different than JavaScript. And so HTML and CSS are really and truly programming languages, but they're not procedural programming languages. HTML is a declarative programming. You say, this is a paragraph, that's a paragraph, you figure out how to show it. The same is true for CSS. It is a declarative language, meaning that you don't write loops, you don't have variables, you don't control logic or steps. You just declare all the things that you want to happen. They kind of all happen at the same time, basically. And so this is the syntax of the CSS programming language, even though it's very different than any procedural programming language. And a lot of people, by the way, love non-procedural programming. They'll be like, oh, I love HTML and I love CSS and I hate PHP. And that's because PHP is procedural and it requires far more detail to say, do this, then do this, then do this, then do that. That's not how CSS works. It's like, find the body tags, find them all, do it, done. The syntax of CSS is pretty simple and pretty elegant, and a lot of people just learn CSS without even taking a class. There is some kind of a selector. The simplest selector is body tag. And then there's a curly brace, and sets the start of the things that we want to apply to the body tag. And then we have a set of properties, and you have to look these properties up on the web or in a cheat sheet or whatever. Font family happens to be the property that we set to set the font. And then we're saying, I would like this to be Arial, and if the Arial font is not available, I would like a generic sans serif font. So this font family happens to be a thing where you give a series of options in decreasing priority order, and then you separate this with a colon and you finish with a semicolon. And so then there can be many of these things here between the open brace and the closed brace. But that's the basic CSS syntax. So you saw on a previous slide where it was all sort of jammed together. White space doesn't matter, but when humans do this, they tend to indent and make it look pretty, even though the indentation is not really syntactically important. But cognitively, for us poor humans that have to read it, it is cognitively very important. Right, so we have the part that the rule applies to, body tag, and then we have a series of key value pairs, basically, property colon value pairs, and we have to go read and learn what each one of those things does and how we use it. But the web is great for this. You're like, what is the CSS property for transparency? And I'm like, oh, and here's a little tiny sample, and you copy and paste that. We learn by copying and pasting. Or Stack Overflow will tell you, what's the best way to put a 2-pixel border around a button? I mean, like Stack Overflow will have like 5,000 answers for that. So you might want to get yourself a cheat sheet. I don't really memorize CSS well. Maybe that's because I'm a back-end programmer, not a front-end programmer. I know a few things like margin and padding and strong and bold and, well, emphasized and anchor tag and all that stuff. But I have to look stuff up all the time. And so I've gotten better at it because I use CSS more. But things like how padding works and how margin works, that's really something that you probably need a cheat sheet for a while. So we're going to talk about a number of CSS properties, but just understand that this is by no means the end all and be all. And so coming up next, we're going to cover some of these CSS properties.
Hello and welcome to Web Applications for Everybody. We are taking a look today at Cascading style sheets. You can download the source code and unzip it on your computer if you like, or you can browse this code and just play with it in the browser because it's all static content, so it's just as easy to play with it in the browser. And of course, we're going to want to take a look at this in the developer console. It just makes a lot more sense to get into this, and so here we go. We're taking a look at CSS. There's a couple of ways to do this. We can see here. We can see the style attribute, style color equals blue, and there's all kinds of various CSS parameters. Color is the parameter and blue is one of the values, and you got to look all these things up. One of the nice things that we can see is we can see over here as we move between elements in the document object model, we can see what the CSS values are. And so Arial Sans, like for example, this is Cascading. The body on here is Arial or sans serif, and that means an Arial font if we can get it. Sans serif is a fallback font. And so that this H1, this little bit right here, this H1 is being colored. This is ours. Browsers have their own default, so display block, font size 2EM, which is twice as big as the rest of the font, etc., etc. And so this came from the browser, and then this came from the style sheet. So this is cascading, and the bottom ones here are this is the most important one because this is the one we said that's closest, and that's how the cascading works. Yeah, we already saw that. And then the cascading is, again, we take a look at this little guy here, right here, and so the closest one is we want a monospace font family, but the body said the font family is Arial and sans serif, but this one has been overridden, and we can kind of see that, and that's why this particular text is monospace. Another thing we can do is we put border style. Now, when I'm working with this stuff, I tend to remember border a lot because it's a good way for you to mark something out and say, what am I doing here? And we'll see, like when we're moving text around, border, solid border, a red border, and a 5-pixel border. And so that's what we see. And you can also see that there's some extra padding around there as well, or some extra margin. And margin top, that's another one. I'll scroll this up a bit. Margin top throws 5 M's of space above the text, and so this is a normal paragraph. But we got 5 extra M's. Now, what's an M? M is the height of a character in the current font, and so M's is a really convenient measure. There's M's and pixels and and percent. So margin before, that's 1M over here. The paragraph already has an M. Margin before, and then, well, hang on, come down here, we've added the margin top. So this margin top overrode the margin top that was part of the paragraph tag automatically. So that's these style rules. So let's keep on going. While this is technically possible, this would really be overwhelming to put a style on every tag. And so one of the things we tend to do is we want to put style rules that are generic. So we'll say we would like the body tag, and this is a style rule. This is the selector, body, and then font family. And again, font family works as please give me the Arial font, and if that's not available, give me sans serif font. Curly brace, H1 tags. When go through the whole document and paint H1 tags blue, go through the whole document, find every paragraph tag, set the border style to solid, border color to red, 5 pixels. So you see that every paragraph, and we're going to change our anchor tags to have green and have no text decoration because they're defaulted to have underscore, and we're going to make the background color light gray. Why? Just so we see it, so you can see that particular thing up there. And then if you look down into the text here, we have paragraph tags and an anchor tag, and no style equals down here. So what we've done, ignore that little part there, that's what puts this little thing in the corner, so that's not what we're talking about. We put no style tags whatsoever, and we put all the style tags up here. But now we've also done something that all the paragraphs have to have the same style, which sometimes is what you want, and sometimes it's not what you want. Now what happens again now, if you have multiple pages, as we have here, it gets a little tiresome to put this text in every page. And so what's really common instead, so now we have the same basic rough paragraph stuff here, nothing in here. We have a pre-tag, of course. We have a paragraph tag. There's no style equals on these things. But up in the head, we have one line right here that basically says, let's take a look at this style sheet. And if we were to look at the style sheet.css, it is in the same folder, rules.css. It's in the same folder as that HTML file, and it's exactly the stuff we had there. It's just a set of selectors and then a select of key values we want, color blue, border style, border color, etc., etc., etc. And so it really is the same as what we showed before, except now that we have to put this into every file, and you'll see we'll put this now from now on in every one that I'm looking at. And so, but now our problem is that we've done something with this to do all the headers, right? All H1s, all paragraphs, but we need better ways to mark text. And so, and so we have these tags, and these tags that we use just to put handles on. In the old days, like this paragraph tag has this border. See that has the margin up there. I mean, it has the border, but it has this 1M margin. That's that space that you're seeing that makes paragraphs look good. I mean, it's not a bad thing. And so if you look at that, we have all these colors. We've got the strong tag. By default, the thing uses a serif font. I don't like that. So let's get down to here, and this. Well, let's just look at it here. The span tag, inspect element, right there. Okay. So the first thing is the span tag is an inline tag that has no styling. The problem is before CSS, which is a long time ago, all these tags had default styling. But the span tag is an inline tag with absolutely no styling whatsoever. And then the div tag is a block tag that has no styling whatsoever, and it can be nested. So it's kind of like a paragraph tag, but it has no styling whatsoever. Now I've added a 1 pixel style, and you'll see that these div tags don't have any extra space, like the paragraph tags came with space. Now some people would go and turn off the space on a paragraph tag, and there's even CSS files that you can to take all the default styling off tags. But you'll notice these divs don't have any space. They're really kind of a block. When I put these pixel on, you see the border. If you look really close, you'll see that there's a 1 pixel blue line and a 1 pixel orange or sienna line right there. But the divs can be nested, and they don't themselves start. So you'll notice that here they don't start with any kind of formatting that comes from the browser, whereas if we look at paragraphs, there is formatting that comes from the browser. And so the div tag the div tag and span tag are just are ways to put handles around blocks of text or chunks of text and then style those. But then we still have to figure out how to grab our handles and make it so that our styling doesn't just touch one thing. And so here I've got a couple of things. I've got the body tag, and I'm setting font family. You'll see me do this all the time. And now I have a pound sign, and this says go find all the tags named body. This says go find all the tags with a attribute of first, ID equals first, ID equals second, and then class and shout. So if we take a look at the text, there is the notion of an ID tag. Okay, an ID tag that is unique within the document. So we're going to call this div first, we're going to call this div second and this div third, and they correspond to first, second, and third. Okay, and so first is monospace. What is it? First is monospace. Second is green. So everything that's in this block that's second has been green. And then, but you can only have one ID named first. But class you can have all over the place. So we can have we can put the more space class on a couple of different tags. So this tag, more space, all more space does is shove it in from the left and the right, margin left and margin right. So it's kind of pushes this in, and so you can put this on here, you can put it another place, and so the more space pulls in something here. So here's another paragraph that's got more space. That one has more space. This one has more space. See that one? And so you can put more space on as many times as you like. And then, div third. Right. And so the hierarchical section means, in this case, this one's a little bit, and loud is red, so where's loud at? So let's inspect that one. Inspect element. Yeah, so that's the loud is not only red, but it's also forced uppercase, text transformed to uppercase. Shouting and loud, and you can have more than one class on a tag, and then you can be even more precise with your selection. This is basically, this says find a third ID and then only paragraphs within that tag third make their background color yellow. And so that means that background color yellow does not apply to this tag. It doesn't apply to this paragraph, doesn't apply to this paragraph. But when you see div ID third, we have selected this paragraph, and they have a background color of yellow. So continuing on, let's take a look at a simple navigation bar. Now, there's this nav tag that's an HTML5 thing, and if you look at most navigation on pages, let's go to the next one. They're pretty and they got colors and they move around and stuff. But what we want to be careful when we build our HTML for these kinds of things to make them very, very simple. And so what I've got is a navigation is usually, we describe it, we use a nav tag, which is a block tag that says, hey, this is our navigation, useful for screen readers, etc. And then we're going to say we're going to have a list of two links, and so that's what we're doing. Unsigned list, unordered list, and a list element that's just no paragraph here, just an include, just a anchor tag, and we're going to put a class equals back and class equals forward so we can style these two things differently in the future. And so this is what this looks like with no CSS whatsoever. And so this is a nice, elegant, clear HTML. And so if you were just looking at this HTML, like a screen reader might be looking at, you can see what this really intends to mean. Now, then what we do is we add a little bit of HTML to this. And so for now, we're just not going to bother, but in navbar.css, is the HTML or the CSS that makes this pretty. And so there's a whole bunch of stuff, and we'll come back and take a look at that in a second. Okay, and so there's our styled nav bar. So I'll come back in another video and pick up right here.
So now we're going to start showing how we change our HTML so that we can use CSS. So there's a couple of different ways that we can sort of reference CSS inside of our HTML. First, we can apply CSS to any HTML tag using a style attribute. We can also take a style sheet right in the head of our document or a completely separate file. The third one is really the most common. Okay, we take a look at this. We can take this paragraph tag, so this is a paragraph tag, and we can put a border around it, a red border and some border width, etc. And so we see this style tag here. The style tag says, for this tag and this tag only, I want to make these, set these parameters. So border style solid, border color red, border width 5 pixels, and that leads to this particular thing. Now, we ought to talk a little bit about the C in cascading style sheets. So there is style that is inherited, right? So the body style says we're going to do font family Arial sans serif. And so that means from here down, it's font family Arial sans serif. This paragraph did not override this font family. So I could override it. I could change the font here to be like a fixed width font or something. But because I didn't override the font family, that means that the font family here is Arial. Because the default is like serif font Times New Roman look, and I do not like that, so I make font family Arial everywhere. But this is inherited, so that's the cascading part. It's sort of, you can think of it as whatever we apply, the closest one applies. And because we didn't change font family here, then we take the ones that enclose it. So this paragraph tag is enclosed in that body tag, and so the style comes into that particular thing. But the key there here is that style equals is an attribute that sets CSS on a particular tag and no further. So this next paragraph does not have it, and the one before doesn't have it. In the same example, this paragraph that's font family monospace, the Arial would be inherited, but now we've overridden it, and so this is Arial, 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 but we chose to override the Arial in that particular paragraph. Okay, so that's kind of cascading, but it's all using the style equals. And you'll get into interesting arguments whether or not you should use the style equals a lot or a little. You just got to be careful. The most important thing is to not end up in a situation where you're using it too much and saying the same thing over and over again. Okay, and so you just, sometimes though, you just like say, you know, I want it red, and I don't want to get too fancy about it. I just want it red, end of story. So you can also put the style rules in a header. And so here's the head. Remember the HTML pages have a head and then a body. Head is metadata. One of the things, in addition to like title, you can put in is a style tag. And then in the style tag, you can just put CSS rules. So you've kind of switched from HTML to CSS right in the same document, right? So this is very same document. And so these just basically say, you know, go find the body, paint that with this rule. Find the header 1 tag, paint it with that rule. And so if you look, there'll be no style tags, style attributes down here, because we just know that we can make the header 1, all the header 1s in the document be blue with that one rule. And so we just hoist these things out from the tags up into a general thing. This is generally much better, right? If you want to make your header 1s be blue, you don't want to say style color blue over and over and over again. That's what I mean by don't repeat yourself, right? That's what I mean by don't repeat yourself. So you can put the style rules right in the header of the document. Probably an even better way to do this, because you don't want your documents to get too big, and especially if you have like a caching server, okay, that's too complex, is to put a link and then have style sheet and then have the file in another, just a file of CSS rules. So instead of putting them right here in the document, you put them in a separate file, and then your document is kind of smaller. And the fact that you're going to be putting these in probably many different pages, right? So over and over and over again. So why not put the CSS in a separate file and pull it in every time you need it? And the same CSS rules, if we take a look at it, it's going to do the exact same thing, right? It's going to do the exact same thing. In there is a rule to make the header 1 blue. It's the same rules that we had here, except that those rules are not in the background document. Instead, they're in a separate document. Okay? And so here we have the stuff, right? And we pull this style sheet in. I mean, this literally is it. But somehow this header has inherited rules that come out of here, right? So the header is blue. So we have some other stuff, you know, links. We can, oh, that's just telling us what we got to do, et cetera, et cetera. So the header blue comes out of rules.css. This is what the rules look like, but they're the exact same rules that we had in that previous example. So the span and the div tags are two tags that we added to HTML at the same time that CSS was kind of like becoming the norm. And so all the tags in HTML, paragraph tag, li tag, have what's called sort of predefined formatting rules. So if you just make a paragraph tag with you just say paragraph and paragraph, it has some rules about like spacing and stuff. And so there's all these rules. And so what we needed was a set of tags that did not have any default rules or default formatting so that we could sort of just add via CSS. So the span tag is an inline tag, and it's a way for us to grab a bit of text, span, end span, and style it. But there was no default formatting for span. So you can say, if you just put span around something, span XYZ/span, that did nothing, right? It doesn't change it. Whatever the formatting was as it came into here, same formatting here, et cetera, et cetera. The only time you do something is if you add a style to that span, right? So the span is a way to grab text and then paint it with some different set of CSS rules. So span is an inline tag, which means it doesn't even break justification, right? So it's just an inline tag like bold or italics or strong or emphasize. The div tag is a tag that is a block tag. And the difference between an inline tag and a block tag is that the inline tag does not break justification, but the div tag does break justification. Now you might think, well, the p tag and the div tag are very similar. The big difference is the div tag has no default styling. And the p tag has default styling, mostly space. It has a little padding that makes it so the paragraphs don't stick out. If you put two divs together and you go div, 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 and you put no padding in or no spacing in, they're going to kind of touch each other because they're going to be really close together. And you're like, oh, the paragraph tag has built-in formatting, but the div tag has no built-in formatting. And so you can kind of see this. I put sort of 1 pixel, and this is a common thing to do in CSS. I put 1 pixel borders around each one of these things. So you can sort of see the end of one div and the beginning of the other div. And the answer is there is no space in between. Whereas a paragraph tag, look, see this paragraph tag? We didn't do anything, but the paragraph tag just kind of added that stuff right there, right? And so you see the paragraph start and stop, but there's a little bit of blank space that comes after the paragraph tag. So paragraphs have a default styling, and divs do not have a default styling. Also, you can nest div tags, right? You can nest div tags, and you're not really supposed to nest paragraph tags. I'm sure most browsers wouldn't care too much, but basically the div tag is designed to be nestable, right? And you'll notice that by adding this 1 pixel border, I do change the spacing, but you can see even in the horizontal, there's 0 space in between these things. They're just like right next to each other. And again, all this is emphasizing is that the div and the span start with no formatting except the div does break. The div breaks horizontal layout. It breaks the justification, but the span does not break justification, right? It just keeps on going. Doesn't break justification. But other than that, there's no padding, there's no color, there's no nothing. So the next thing to talk about is classes and IDs. And so the idea is that we never want to repeat ourselves. And so we have created this, part of CSS is the creation of this class attribute. And the class attribute itself does nothing. It just marks a set of distinguished tags. So you say class equals more space, right? Or class equals shout loud, or ID equals third. So ID, so the difference between class and ID is you can use a class on more than one tag in a document, and we'll see later. ID is another one of these CSS attributes that we can use, but you can only have one ID per document. One tag with an ID attribute of third, right? ID attribute of second, ID attribute of first. but we can't have two of them have first, right? The IDs have got to be unique across the whole document, but classes do not have to be unique. And also, just here, this little bit of class right here, you can have more than one class. This is not a class called shout loud. This is a class of shout and loud, and it means apply the rules for shout class and loud class to this particular tag. And so if we take a look at this, well, we say body, that's a normal tag. Pound sign first, that means ID. So pound sign says, go find the thing with ID of first, right here, and paint that with monospace. We'll see this in a second. Second, we're going to make everything in the second div, which is here, we're going to paint that all green. See, that's how I think of these, is like, and then go find all of the things with the more space class, and then have a left margin 20 pixels and a right margin 20 pixels. And you go find all of them, left, right. And so shout is going to transform it to uppercase. Loud is going to transform it to red. You could have shout by itself. You know, shout and loud are sort of independently applied, so this is going to be both uppercase and loud. And then you can even have cascading that says that within a tag that has the ID of third, paragraph tags are going to have a background color of red. So let's go find where that one's at. So ID tag of third right here, ID tag of third. So that is, I guess we're not seeing the slash div there, but then a paragraph tag. This paragraph is to be painted with a background color of yellow. So you can see this is like grab, do, grab, do, grab, do. And we're just able to do this. Not that any of this makes any sense, it's just an example. So let's take a look at how that really looks, right? Within the ID of third, div of third, all the paragraph tags have a yellow background. And so that was like I spray painted this yellow background on that. Away you go, right? And so like the more space guys, look at the more space, right? The more space applied to these two paragraphs, and they sort of shoved in both on this side and this side because I did a margin left and a margin right to shove those both in. So the div of second, which is a whole bunch of stuff from here to here, the div of second, all of that, it's actually all this. So basically we spray painted all from here to here green, but then we overrode that by a more local CSS rule. This one is closer than this one. So because we're in second, we're supposed to be green, but because of shout and loud, we're supposed to be red. And so this is red. So red won here. If you didn't have this, this would be green, but you have this thing that's closer. The closer it is to the tag, the more power that it has, and that's how it overrides. Okay? So up next, we're going to talk about colors and images and fonts. And again, there's so much to learn, but these are sort of the basics that I want you to know. So now we're going to just talk a bit more about how we do images, colors, and fonts, and then we'll sort of wrap up CSS. And so, I don't know, when I fell in love with HTML, I didn't fall in love with the web right away. I didn't think it was all that great. It was just a way to click things differently. We had other things like Gopher that allowed us to click stuff. But when we saw inline images and the ability to wrap text around images, that rocked my world. And part of the web that was so successful had to do with vanity to some degree, where you could make a page that is you. And there is a page of me, which makes me very, very happy. Because, you know, I'm so vain, I probably think this page is about me. And so one of the features that I love the most is this wrapping. So I love how it does auto. So as you move things back and forth, it auto lays out. And I think that's really cool. I know some people want to lay out pixel perfect, but I love the notion of larger and smaller screens, responsive, adaptive. I think that's essential. We can argue about that later, but what I love is the ability to float an image to the right and then have the wrapping happen around it, okay? And so here we go. Let's show you how to do this, right? And so we'll talk about the nav bar later, but for here, what we have is this image. And so you can see that this image in the layout comes right before the header 1. So the image would normally be right there, basically. But then what we do is we say, with the style, we say float right. And that says hoist it out of the normal flow and then float it to the right margin and then use it as a justification boundary. And so that pulls it over here. And so that's why this sort of comes up here. There's no image anymore. And now this lays out here. Now the other thing that I've got is a margin of 1em. And so that gives me the margin of 1em, gives me a little space right here. So one of the things you do in CSS is you talk about sizes, and you've got pixels and sizes, and the em is actually a really useful size. And so what the em is the width of an em in the current font size. And these fonts can go up and down as you zoom your page in and out. And so what it really says is I would like space that's equal to the width of an em. So you kind of see that this is an em of space this way and an em width. Actually, sort of the em is sideways here. An em with the vertical space. And so it means that if you change this and zoom it in and out, this space will change correspondingly. So that's one kind of way to say one letter's width that is taken from the size of the surrounding text. So I think that's really cool. I mean, pixels were dangerous and font sizes were dangerous, but these ems are a great relative size. So float right pulls the image, shoves it over, changes the thing. Now, if this was long enough, you would see that eventually it would start wrapping here. But you can also force it to clear the float. And there's an attribute on any tag you want, but I use a break tag, which is, break tag is like, go back to that new beginning there. Clear equals all says, whatever that float was, if we haven't already sort of gone beyond it, the next thing, this next paragraph here, has to start at the left margin, even if it creates a little bit of white space. So that's how that white space got created here. The hanging indent was effectively cleared, and so this line here had to be forced back to the left margin because of the break clear equals all. And so that's a floating image, which I think is really nice, and I love it because I can resize this, and it just resizes automatically. And if you resize it really bad, it'll actually pop it up so that this picture is on top. And I think it's important to do those kinds of things because, increasingly we have narrower and narrower ways to view these things. And so just imagining that everything is really big and broad, it's not always that way that we're using a super large screen monitor. It's great when you can use them, but it's nice to have a website that responds to changing widths quite naturally. So colors. So colors are important. There is a color attribute. There's a background color attribute. And so they have a number of built-in colors. These aren't necessarily the most beautiful color, but I love to use them to do things like, I'm trying to say like, what happened? How come that little tag is not working or that CSS rule is not working? I'll say like BG color red, and then poof, it goes red. I'm like, oh, I hit the wrong one or something. And so these colors aren't really great for graphic designers, but they're great for developers who just want to like have something stand out so you know what you're doing, right? And so these colors are like aqua, black, blue, fuchsia, etc., and they're the default ones that every browser supports. Like I said, they're not really officially gorgeous. Now, there's also a way for any place that's saying color to have an advanced color. And you see the advanced color by this pound sign. And so what this really means, it's a hexadecimal. Hexadecimal, you can go look that up. It's base 16. All it is a number system that has 0 through 9, and then A, B, C, D, E, F. So F is actually equivalent to 16, and so this is like the number 16, except it's only one column. So hex is a way to sort of in a more dense way represent numbers, but that doesn't matter. FF is the biggest number, and 0, so 0 through F. There are 2 red numbers, and these are 16 times 16, so this is really 0 through 256. Each one of these is somewhere between 0 and 256. So the red is 0 through 256, the green is 0 through 256, and the blue is 0 through 256. And in a sense, what we're capturing in this little thing is like what these sliders, where you're dragging back and forth. 255, not 256, 0, 255, right? And so that's all you're doing. And then you're changing this color by combining the red, green, and blue to the level that you want to combine them together. And so there's also a set of colors that are just 3, where you say #245. This is the red. It's like 224455. And so that sort of reduces the color space. And so you can have 3 hex digit colors, which is red, green, blue, but it just is sort of duplicates those things. and it's a way to use fewer colors. In the early days, we used to worry about web pages that used too many different colors because the computers couldn't represent as many colors, but that's probably 15 years ago since that actually was a problem. Fonts. The default font in 1990 was Times Roman, partly because I think when Tim and Robert were inventing the whole thing, they thought of this as a highly respectable thing and were writing documentation like journal articles because it was physics. I mean, they were trying to represent physics documentation. So they just picked Times New Roman, or maybe that was the default of whatever next computer they happen to be using. I don't know how. I just know that I hate Times New Roman. And so the first thing I do is switch to some kind of a sans serif font because I think that just looks more modern, unless I'm writing a journal article or a New York Times article. That's where Times New Roman comes from, I think. And so I'm always changing my fonts. And so the font family is one of the first things I always do in any CSS. And so font family, and there's a whole other things like font size. And so you look at font families, and it's kind of a little bit different because, like if you look at margin, it's a width, it's really easy. But in a font, you have a list. And what happens is your list is sort of your preference in priority order as the graphic designer. And you basically say, if this is Trebuchet MS, I think that's a Microsoft font. And then Helvetica might be a Mac font. And Arial, I think, might be a Microsoft font. So you're trying to hope to find one of these things. And then what's really cool is there is always a fallback. So it says every browser must have a serif font, a sans serif font, monospace, cursive, and fantasy. Cursive and fantasy are kind of stupid because they're kind of not predictable, but these three are super useful. So you can always sort of fall back to some browser-supported sans serif, serif font, or a monospace font, and that's why you see these things at the end, because these are the fallbacks. Font size. You can have relative font sizes. These are a little dicey. You start at medium, you can kind of go down and you can go up. Folks tend to prefer like 12 pixel height, things like that. You can set the font's weight, bold or normal or italics. The reason these two things are separate is because you can do both bold and italics. Some blah, 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 bold. Well, I don't really know how to draw bold and italics, but you get the idea. You can do both in italics, so it's not just one or the other. It's not bold, italics, or normal. It's bold or normal or italics, and so you can apply both of these things. You can do things like cause everything to be underlined. The default, of course, is none. You can have overline or line through, and you see this a lot. People use line through when they're showing that they changed something. Okay. Now, going back to font size, pixels. So it turns out that pixels, it's not like the most popular way to do it, like 12 pixels tall, because we can zoom our screens in and out, especially for accessibility on different devices. And then the 12 pixels would be the same. But what happens is most browsers conveniently ignore the pixels. And if you're zooming it in, it says, 14 pixels, and then it just makes them bigger. Because otherwise, if it really literally took your 14 pixels literally, as you zoomed pages in and out, then that 14 pixels would stay the same, which is really not what you want. So people get sloppy and use 14 pixels. It works. This is kind of zoomable. Font size is kind of a hard thing. Links, again, the whole beginning of this came down to HyperText, right? HTML, HyperText Markup Language. And so we've got some interesting styling that we can do for links. The default was blue and underline anything that was clickable, and purple and underline anything after you got done clicking. And it turns out that if you look at Google searches, they still use this styling because it turns out it's not really good for every page that has every clickable element, but if you're actually making a list of things that are actually clickable, it's not a bad convention, and we just all use it. And so Google searches style this way. But you can in CSS control a lot of how the styling works. So you can basically say every anchor tag is supposed to be bold. If it's a link tag, before you visited it, it's going to be black. After you visited it, it's going to be gray. Hover, that means when you sort of if this is our little area, you come across and it can change color while your mouse is there. And as your mouse leaves, it changes color back. And so you can have a bit of animation. And again, part of this is to attract attention to the clickable places. So you kind of come across, it goes like, ooh, pink, back to blue, right? And so you can do that. In this case, I'm actually changing the background color, changing the font color, and taking away the underline. Active is not so useful. It's after you've clicked on it, while the next, remember request response cycle, you've clicked on it and it's retrieving the next page, but it still is showing the old page. During that brief instant, hopefully brief instant, you can actually change the color of the link while it's reading the next page, which kind of is useful if it was going to take a long time. You could say, oh, it shows like it's kind of a red or something. It says, don't click this because you already clicked it once. But most of the time, the page is gone in a blink of the eye, so you don't really use it. But you can do it. So this is like the state of a link, right? You can style based on the link state. Have I visited it or not? Am I hovering over it? Have I clicked on it? And that you can do. I think you can do this for almost any element, but it doesn't always work the same in different browsers. But the anchor tags, this works really, really well. And so anchor tags are a big part of what we do. Things like Google search results, like I say, make really good use of all of these things to help you, because what search results usually are is a bunch of links that you can click on. You type, web applications for everybody, and then boom, you got a bunch of links, and it helps you find what you're going to do, and really augments the navigation activity in a user-friendly and user-engaging way. So I've got these samples at code.css and web applications for everybody, and they're all really designed so that you can sort of watch them, you can look, you can inspect element, right click, and you can see all the CSSs, et cetera, et cetera, et cetera. And so I'm not going to go through every single one of these in the form of a lecture, but there's a lot of useful stuff here, so I would recommend that you go all the way through this and just kind of get the basics of CSS. So again, I just took you through a very beginning CSS. It's wonderful. I am not a graphic designer, but I so love to use CSS because I just kind of, throw a little padding somewhere, or a color, or move something to the right, or make an image larger or smaller, or put a little border around an image. It's really quite nice, and I can do the stuff that I want to do, and then I can say, as long as I don't get sloppy in my HTML markup, I can just hand it to somebody, and then they can hand it back to me and say, look, I really made your stuff beautiful. And that's really quite cool. And you got to think that this is also not done evolving. We're at a pretty good point with HTML5 and modern CSS, but it's going to keep evolving as mobile and other things happen. And sometimes there are like, oh, you got to use this WebKit or Mozilla options to curve buttons. Now those have become standard, but it's always kind of an evolving thing as we come up with better ways to represent our markup.
So welcome back. Now we're going to take a look at some more examples. We're not going to, the one thing we're not going to look at is exactly how this navigation bar works, at least until a little bit later. So the next thing we're going to take a look at is how fonts work. And there's a couple of ways that you can put fonts into a file. There are default fonts that every browser is required to produce, like serif, sans serif, monospace, cursive, and fantasy. And so you don't exactly know what's going on, but they're often used as fallback fonts. And so you can have those. There are any font that is on the system, like Arial or Helvetica. And so if you're going to use Arial, not all systems have Arial, although most of them do these days. And you have to have more than one font. Now, another thing that's really common these days is to include a font somehow. You find out about a font, and here's a Lotto font, and you go look it up on the web, and you find, oh, include this. And so I included this link because I found this really cool font, Lotto. And this extends the browser. The browser then learns about this font, it downloads the font, caches them, and keeps them in the browser. And then I can make a font that's Lotto, but just in case I'm off the internet, and I can't download this thing, I have sans serif as a fallback for Lotto. So Lotto is a fancy font, etc., etc. So there's Arial and built-in fonts, etc., etc. And so that's how fonts work. Colors, there's a lot of cool stuff about colors. There's a couple different things. We'll ignore the nav for the moment. I'm just using span tags here. There's some default colors in the earliest of browsers. These days we have all these fancy ones, and you can go look these up, and you just Google for HTML colors. And there's a bunch of names, and then they're consistent across browsers. But there's like 12 or so really solid names that are in all browsers since the beginning of time. But more modern browsers have a better palette of colors. Although really good graphic artists want to have much better control of colors. And so this is, the pound sign says that this is a hexadecimal number, and it's got 2 digits. Hex means they go all the way up to F. So F is an A through F are numbers. 8B is the red level, 45 is the green level, and 13 is the blue level. And so this is a brownish color. And then there's what's called web safe colors, where you just have, this ends up being 88, 44, 11. But it sort of reduces the number of potential colors if you were mixing colors from various sources. And then in HTML5, you can see this color picker. When you have a form, which we'll talk about in a bit, it's a color form for modern browsers. And then you can pop up with this button, a color picker, and I've got a little thing to print out what the color would be. And so it just, when I pick the green, it basically puts 00FF, that's red, green, and blue. It puts that into this thing, which then the program could use. Could read this, or JavaScript could read it, or server code could read it. But right now we're just kind of playing with the picker, and we pick a different color. And so that magenta is all the red, none of the green, and all of the blue. And orange is all the red, some of the green, and none of the blue. So those are all just really strong colors. And so that's what's called an HTML color picker. Anchor tags. In the old days, anchor tags were kind of funky. They were blue if you hadn't yet visited them, and they were purple if you had visited them. And so this one I've obviously clicked on. And so we have a whole series of styling mechanisms that we can have. If we take a look at these, I have put these all inside of an ID tag of cool. So this is basically saying find the ID tag of cool and then style anchor tags to make them font weight bold. So let's take a look here. So I got one paragraph that has this one here, and then I have a paragraph with an ID tag of cool, and that's basically so I don't have to style. Usually you wouldn't say I'm only styling the anchor tags inside of, if I'm only styling the anchor tags inside a tag that has an ID of cool, but that way I can have the default on this one. That was my way of keeping the default. So normally you would just say A. So A links is red. If it's visited, it's orange, and so this one's been visited, so you don't see the red. It means it's unvisited. Hover, you can change it. So you notice when I hover in, the text decoration goes away, the underscore goes away, and I have a color of text font color of white and a background color of navy. And then there is one last moment. Can I click on this one? Oh, that will click. There's one last moment that's really hard to catch, and that is the moment of active. If the web was slow and you clicked on it, then it would tell the user, in the old days this made more sense, that it would turn red and then blink away. I don't know if we'll even see it. It kind of saw it. You sort of saw it. And so there was a color while you click on it. Yeah, there it was. You might not see it in the screen, but that's what the active means, is you've clicked on it but it hasn't yet been retrieved, and then like a moment later the whole page goes away. Another thing we can do is we can play with images. Okay, and so here is an image. One of the things that's really fun to do with images is float them to the right or float them to the left. And then what happens is that the image, the text is drawn around the image, so it wraps around the image. And you'll notice where I floated this left. Oh, I kind of got rid of everything. I floated it left before the H1, and so what happens is the H1, top of the H1 and the top of the image line up, and then all the text afterwards wraps around it. And so you'll notice that I've got the image first and then the H1 second, and but the float sort of disconnects the image from the normal line of flow, floats it over, and then takes this next thing and the next paragraph and saves the space for the image and shoves the margin over so that it comes over here. Now once you start floating images, you got to learn about this clear equals all, because if we want this next paragraph, like this one, we don't want this paragraph for whatever reason to be on the image. Now if it goes far enough, you see this paragraph here moves back to the left margin, and then this next one starts there. But if the browser is wider and the text is, there's not so much text, we don't want this to be up in here. And so you say BR clear equals all. So between this paragraph and this paragraph, we do BR clear equals all. And you can put images right in the middle of the text like a character. You don't have to have them by themselves. And you can even make an image that's a clickable link. And so you can click on that image. Now, C in CSS stands for Cascading Style Sheets. And so the idea is that the tag that's closest has more precedence than a further away tag, unless you say important. Okay? So here we have some style. Here we have a body tag, border style of dotted, red, and red, a border color that's red and important, and border width that's 5 pixels, background color, which is kind of a grayish, that's that gray, and an extra padding, so we've got put some extra padding all the way around it, and extra margin. And so if we take a look at this, we take a look at this paragraph right here, we see some things, and we take a look at what we've got. So we've inherited this, we got a border style of color, it wants to have a border color of green, but it doesn't because it says the border style is solid. So the border style of solid is down here in the second style tag. So the second style tag has precedence because it's closer to the paragraph. And so we tried to say border color green, but that one was overridden. So otherwise this would have a solid green border, except that this red important is up there, and so that the red important wins. And you can see it really easily here that this was overridden, and this is the one, this border color from the previous one is taking precedence. Okay? And so this is the second one, and it would normally take precedence over this one, except that this important is sort of like it is overriding the one that's closer. So another example of closer is the style tag. Okay, and so here we go. This is border. This is we're putting this. Style attribute. We're saying border style equals dash, border color equals blue, and so the border style equals dash holds on, but our attempt to make the border color blue is overridden again by the red important, right? So important is up above that. Okay, and so this dashed is winning, and this blue is not winning because there is an overriding red above it. There's an overriding red important above it. And so if you want to override an important tag, yay, we override an important tag right here. We basically say I want a border style dashed. Come over here. Border style dashed, and I want the border color to be blue, and this is important. So now this one's closer, and it says important. So among all the important ones, the closest important one wins. So now we see that the border color actually takes here, and we are overriding the far away. This one here from farther away got overridden because of this one. And so you can do that. Now, in general, while I've shown you how important works, you shouldn't do too much with important, because usually you're taking CSSs from other places and you're patching it, and you can end up with really inconsistent looks and feels with important. Usually when you see important, it means kind of something's wrong and you're fighting with a framework or something else. So let's take a look at some blocks. And so let's see, background color, my H1's color blue. And I'm going to put some padding and a margin. And so div P and H1 sort of live in a box. You have sort of like the actual, so let's take a look at, say, this paragraph right here. That's probably the thing to do. This is just a plain old paragraph. Nothing special, right? There we go. That's a paragraph right there. So So let's talk about the padding and the margin, right? So working from the inside out, there is the actual text that is, and it's wrapped. And so if I change the width of this whole block changes, right? It gets taller and narrower. But at some point, the inner part, this inner part right here, is the inner part is however large it becomes, and that in this case it's 318 by 38 pixels, right? And then what happens is we sort of work from the inside out. So I'll go down here and see the box model. So the inside of this, the actual text is 619 pixels by 19 pixels, and then I've asked to add 10 pixels of padding, and that is between this sort of text and the border. And then the border itself has a width, and I specified that border width. Right, I said I want a 5 pixel border width, and so the border width takes up 5 pixels. And then there is, outside of that, there is margin. And so margin is space. Notice that the padding and the text itself has the background of the block, border has its own color, and then the margin has the background of the color of the background document. Okay, so this is the margin here, it's the color of the background document, right? So content, padding, border, margin. And then, but the padding inherits from the text in the box from a background, and the margin inherits from the background document. And you can have different background colors, etc., etc., etc. This is an, oh, by the way, this is an ordered list that we've got going on right here. Okay, so that's CSS boxes. We can change the size of these boxes. It's a little tricky. So and so here we have auto sizing div where we're not mentioning anything about the height. If we take a look at the box model here, we see that this one is simply, you know, the size of the text plus the padding plus the border plus the margin. And that's sort of how that box gets sized. You can say that you want to set the size of the box. Okay, so I'm going to set that to be 3 M's. 3 M's is 3 characters. But if you look, I have too much in here. And so you'll see that even though this box is 3 characters tall, it's 4 lines. And so the 3 would fit, but the 4th one doesn't. And so it just overflows. You can also, so 3 M's, it's good to set sizes in M's when you can, because then if someone makes the screen larger, oops, I didn't mean that. This one, if someone makes this larger or smaller. Now the problem is, well, I don't know about it, if we'd call it a problem, but in the old days, if you set a height in pixels and you zoom the screen, the box where you set height in M's would zoom, and the one that you set in pixels wouldn't. But they decided to make zooming work, otherwise so many people made boxes in pixels that they made it so that the zooming would pretend that pixels are really M's. So it kind of converts pixels to M's, but you're supposed to avoid using pixels when you really mean characters. If you want 3 lines, don't look at your font and say, I'll make this 40 pixels in order to do that. And again, in this box, we still have overflowing text. And so we have a couple things we can do when we want to change the overflow. We can tell a box that we would like the overflow to make a little scroll bar. And so here's that same stuff, and you can see we got a little tiny baby scroll bar, and it didn't sort of blop out of the box, right? And even if the scroll fits, you see you get little scroll bars, but you can't scroll it because there's only 1 line there and it fits in the box. And then another thing that you can do is you can just say chop it off, right? Chop it off. Now, one thing with some JavaScript, you can put a little more here and that expands the box or pops a bilog or whatever, but we're not going to worry about that for now. For now, we're just saying overflow hidden means lay this out as much as you need and then, you know, throw this text away. It's just not there anymore. Like, where did all this text go? But it doesn't show it because we told it to chop it off. Okay, so on to the next one. You can move these things around. This is a little messy. There we go. Let's make this a little different. Okay, so by default, I'll show you the HTML in a second for this, or maybe just do view source. Let's do view source. Okay, so if you just say div div, they just follow after each other. And I've given them border because to make them a little picture, give them some border, some padding, and some margin just so they don't touch each other too much. So by default blocks, just so I got a little border both on all sides and a little bit of space between them and a nice. So they, however big they get, this one gets bigger, and I put a width on them just so that they wouldn't move around, and there's a width on it right there, 10 ems, 10 characters wide. So they just follow each other. And then you can say, okay, this block right here, this number 3 would lay out right here, but I have told the number 3 block, that I want to move relative to where you would normally be 20 pixels to the left and 20 pixels down from the top. And so this block, it lays out exactly as if it belongs right here, and then we shoved it over and moved it down. And it came over top of the number 4 block. And so there you go. And so the text afterwards, this number 4 block, just comes next, and it's basically, it's as if this laid out without the position relative, and then this came afterwards, but then we sort of just shifted it, and that's why this overlaps, because this corner here is where 3 would have finished and with a normal layout. So you got to be careful with relative. I mean, you don't usually want to make it so that they sort of blop on top of each other. Okay, and so now we're in 4, and then we're going to look at 5 and 6. And so 5 is what's called fixed text, and you'll see the 5 comes right here, but because I've got this as position fixed, this is fixed relative to the window. So it's 20 pixels up from the bottom and 30% of the way from the left margin. So you can see that this is 30% of the way from the left margin, and it's the bottom of it is 20 pixels up from the bottom. And you'll see that green box never moves, and that is because the fixed text is relative to the window. And that's how we actually get this little link that never goes away. And so there's a link that never goes away. Absolute text, I don't know why they call it fixed and absolute, but absolute text is a little bit different. It's relative to the parent element. And so in this div right here, the parent element is the body tag. And so when it's saying, I would like this to be 40 pixels from the top and 30 pixels from the 30% of the way from the left, that means it's relative to the body tag. And so the body tag starts up here, and so this has been sized 30% from there and whatever, 40 pixels down. And notice that one goes with the scrolling, right? So that one goes with the scrolling. And you'll also notice that between 4, 5, and 6, it's as if there's nothing here. But if you look at the document, 5 and 6 are sitting there, and that's because they are plucked out of the normal rendering stream, and so they don't take up any space between 4 and 7. So they don't count in sort of the normal layout as the page is being laid out. And so here's number 7, for example. Actually, number 8. So here's number 8, and so this is positioned relative with a left of negative 1,000 pixels. And so in a sense, this stuff right here has been shoved off the screen to the left. And so that's how we often will put text on that nobody sees. Just move it to the left. But it takes up the vertical space anyways because it was just relative. It would have normally laid out here, but the left shoved it over there. And so that's basically some layout. And so now we're going to talk about z-index. Let's take a look at the source code here. And so z-index is the ability to what happens when things overlap, okay? And so this is a div. Number 1 has a z-index of 100. Number 2 has a z-index of negative 100. 0 is sort of the background document. And it works out pretty straightforward. And I'm just moving these so they have to lay on top of each other. And so you see this one here is negative 100, so it's kind of behind everything. This one is positive 100, so it's in front of everything. And this number 3 is, I just put that there to be in the original document with no z-index whatsoever. And so it's behind this thing that has a z-index of 100. Okay? And so that's Z-index. Like this little note way over here by the right margin says, Z-index is kind of tricky. Everyone tries to be on top, and you'll put Z-index of 100, and then you'll find that the navigation put itself as Z-index of 1,000 or something like that, right? And so Z-index is hard to debug and hard to fiddle with, but at least now you know that Z-index is when things look weird and they're overlapping in weird ways, Z-index is what you're taking advantage of. And so now we'll take a look at kind of how this navigation works, okay? And so here's a couple things that the navigation does. The body, of course, is font family Arial sans serif. The navigation bar itself, I guess I'll do a view source on this so we can look at the navigation bar. The navigation bar itself, this block, it's a block tag, right? That has a position of light gray, and I've given it a height of 3em, so it's like 3 lines. And if I zoom this page in and out, right, that gets bigger and smaller. I'll get back to 100%. It's 3 lines tall, and I guess I didn't need to say Arial sans serif. I did that in case someone else wanted to change the body tag, I guess. So then I have I want UL tags within the nav, and that's one of the nice things about this nav being its own tag. I can style just the ULs inside here. Okay, and so what I'm doing here is I'm saying I don't want any little circles, little dots, little bullets. I don't want any of those. I want to take away any padding that it has by default. This is one of those things that this UL inherits. Let's go down here and take a look at this, and you'll see that this UL right here. So what's happening is this is the things that I've said in my CSS, and I'm overriding some default things. It's normally would be display. It's a display block. That's okay. And so I overrode the list type style. And continuing on, the list item inside of nav. That's what it is. Nav and list item. I wanted to make that. So let's inspect this guy right here. Inspect. So if you look here. And I've got a class of back, and so I have this positioned absolute, which is relative to the parent right here, and I have it 20 pixels to the left of that upper left-hand corner, and so that's how this comes over here. And then I have it colored dark blue because it's a nav, an anchor tag within an anchor tag within an li tag within a nav. That's what this is saying. Dark blue text decoration of none, and so that's where I get this color blue and no underlines. And then this is the dot back, and so I use a back class to position this right here, and then I use the forward class to position this relative on the right, 20 pixels from the right, and so that's how I make the navigation bar work. And CSS is really a lot of work. We learn a lot about CSS, and this is just a really short introduction to get you a sense of what the basic mechanics of CSS are. Thanks for watching.
Hello and welcome to our screen recording. In this screen recording we're going to install the MAMP software for the Macintosh. So we're going to download from mamp.org. So I'm going to keep this. I don't quite know why Macintosh is unhappy with that. And so I'm going to go into my downloads folder, and here I have this folder. And it's MAMP Pro 0401. That's because I downloaded it twice. And so I'm just going to click on this. And it opens an installation. And I'm just going to accept all of the defaults here. Okay, so it's been installed, so let's take a look at where it's at. So if I open Finder and I go to my computer and I go into my hard drive, Applications, it's in MAMP. And I can start MAMP up. And this tells me a bunch. PHP info here is really useful because it tells you about the configuration of the system that you've got. I've got version 7 PHP, and it tells me where the configuration is for this. And so I'm going to go take a look at the configuration file, and I'm going to make sure I'm going to do Control F and look for display errors. So this is the problem we have when we're doing development with MAMP, is that display errors is off, okay? And so I want to fix this by editing the initialization file, and you got to go to the right one, Applications MAMP bin PHP, PHP 7.10 PHP INI file. Okay, oh, and by the way, I've got this little MAMP control panel. This is your MAMP control panel. Starts and stop, little green dots means that it's running. So I am going to run the Atom text editor. And I'm going to open a file. And I'm going to go to my Mac. Oh, wrong. My Macintosh, Applications, MAMP, let's see, MAMP bin PHP, MAMP bin PHP, PHP 7.1.0, conf, PHP INI. Yay, I found the file. So I open this up, and it's a nice little text file, and this is the PHP configuration. And I'm going to scroll down here. I'm going to use look for display errors. If you don't do this, there we go. So we're looking for this line that says display errors equals off. It talks about this. Print out errors as part of the output for production websites. Do not do this for production. Sure, but we're doing development on our local hard drive, and so we want to turn this on, because if you don't, you won't always see the errors. I'm going to turn up display startup errors. I'm going to turn those on. And so we want as many errors as we can in development. Of course, if you were running in production, you would turn these differently. And so what I'm going to do then is I am going to then save this file. Command S. I've saved it. Okay, now the thing you've got to do at this point is you've got to stop MAMP and restart it. Stop the servers. Now the servers are stopped, and if I go to refresh this, it'll blow up because it's not there. But when I start these servers, they'll come up, and I'll go to the web start page, and I'll look for PHP info. I can close these tabs now, and I should go down and look for display errors on and on. See, that's the success. That means that you are successful, and that's great. Okay, so let's then also write a simple little page. I just, how do I get rid of, oh, I got to escape, I think. Yeah, there we go. So I'm going to make a little file. Hello from my first web page. Okay, so we're going to find out where this is at, localhost 8088, because this is now a web server running on your local computer. And if you go into your Finder, it is, well, let me start at the top. Where's my computer? Come on, computer. MacBook Pro, hard drive, applications, MAMP, htdocs. That's the folder we want to be in. Okay, that's the one we want to be in. So I'm going to take this file here. I'm going to say save as, and I'm going to go to MAMP, htdocs. I'm going to make a new folder called first. Make a new folder. And then I'm going to save this as index.php. Save. It also nicely highlights it. So now if I hit refresh here, you'll see that I got this folder name first. And if I go into first, the slash, if I don't have anything there, it's as if I typed index.php. Because that's called, for a folder, index.php is the default file that a web server, one of the several default files that the web server looks at to load it. And so that's pretty much it. Away we go. We have successfully installed MAMP and changed the startup variables and written our first little program. Okay, hope it helps.
Hello everybody, welcome to Web Applications for Everybody. Today we're going to show how to install MAMP for Windows. So I'm going to download it here, and I'm on Windows, so it takes me straight to the download. I'm just going to say, I'll go ahead and run. So now it's going to go ahead and run the application. I must say yes. English. Next. I'm not going to install MAMP Pro. That's nice that they give us that checkbox. So you can pay for MAMP Pro. I don't exactly know. I've never used it, so I don't know. Accept the license agreement. Put it in MAMP. Next. Next. Desktop icon. Let's go ahead and run it. Okay, so now we're going to continue. Now we have MAMP. We should also have this on our desktop. So it's coming up. So this is very important. You've got to allow this to happen, because if you don't, well, let's check them both so that MySQL can talk. Now this is HTTPT, and I'm going to say yes to both of those. And that's very, very important. And now that they're up, and so we can open the start page. And there we go. And you can take a look at PHP info. And then you can look at PHP MyAdmin. And literally at this point, if you've got something coming up here in PHP MyAdmin, you have successfully installed MAMP. So congratulations. Hello and welcome to Web Applications for Everybody. Now we're going to install Atom, the text editor. You literally could do any text editor. I use Atom because I like it. It works on Windows, Mac, and Linux the same way. But literally you can use any text editor that you like. Don't use Notepad or Word. Certainly don't use Word. Because if you use Word, it'll mess your files up. Okay? We really need a text editor with syntax highlighting and things like that. So it's finished downloading and it's getting ready to install it. We're going to write right now our first PHP application, so I'm going to go ahead and get Atom started, and I'm going to get MAMP started. So MAMP, I'm going to have to start these servers. I'm going to start the Apache server and our database server MySQL. So we'll get that started. So let's open the start page because there's a lot of good information we can get here. We can find out about our PHP configuration. And my favorite thing to do is to run PHP MyAdmin, because literally if PHP MyAdmin is running and you come up with something that looks like this, you are in really good shape. Everything is running fine. Your database server is running and PHP is running. So I'll get rid of this. So what we're going to do is we're going to write our first application. And so I'll have Adam here. And so I'm going to do File, New File. And I'm going to call this H1 Hello from a web page /H1. And now what I'm going to do is I'm going to save this. File, save. And I'm going to go to a file called /c mamp htdocs. I've pinned it here to make my job a little easier. I found it once, drug it over here and pinned it so I can get right here. Now, this is the web document root for your web server, and you can make folders here. So I'm going to make a new folder. I'm going to call this folder first. Make that folder. And now I'm going to save this file, call it as index.php. Index.php is a special name. It's a file that if you navigate a web browser to the directory, it will generally serve index.php. And now it's syntax highlighted this for us because it's showing this. Now, the way it works is I can go anywhere from localhost on down to the folder that I just made, to the file I just made, index.php. And so you see that c:\mamp htdocs is the top of a folder, web folder structure that's sort of from localhost on down. Okay? And so this is just an HTML page. We've seen it. You know, we can view source. This HTML page came from PHP. Now, so far we haven't actually run any code in this PHP. So let's go ahead and write some code. So, and show you how PHP can run code. So there's a tag called !PHP, and then a tag that's !, and it's already added that for me. And I can run code in here. So I can say something like echo, hi there, \n, semicolon, and I'm going to save this. And I'm going to run this code. Run it again. And so there we go. It says hi there. Let me put a space in here. So this is code. And basically what happens, now let me put a paragraph tag in here. Put a paragraph tag, some HTML, put an end paragraph, something else. And so what happens in PHP is when you drop into the PHP language on the server, it switches from just rendering this HTML to running code, but then in place of this, we get the string hi there. So let me save that and hit refresh again. And so this bit came from the executing code that ran here. And so inside this code, we can put in some logic. So we can say, you know, $x equals 6 times 7 to make a variable, and then we can say echo the answer is, and the double quote was already there, sorry. /n to put a new line in. So I'm going to save that. And now I'm going to hit refresh. Oop. So it looks like it didn't quite work. Oh, I got to concatenate this with a dot. No, this is supposed to be an X. That's why I made a mistake. File, save, refresh. Okay, so you see this came, hi there, all this stuff came from the executing code. So you can think of all this output as the result of executing this code, and anything that is printed out during this code is put out as the web page. And so that's kind of the idea. You put files and folders inside of this htdocs, and then you execute them by running them in a browser. Okay, so we have one last thing we've got to do, and it's a really, really, really important thing. Matter of fact, I make it an assignment. I think it's so important. So we just finished writing our first web application. Now let's go ahead and make a syntax in this application. Make a syntax error. And we're going to make all kinds of mistakes. So I'm missing a semicolon there. So I come up here and I refresh it. And what happens here is we get an error. Now, I just put the error in so you kind of know what the error was. But the question is, what if this was like hundreds of lines of code and you had to figure out what's going on? Okay, so let's take a look. There is a setting. It turns out that printing errors on the screen is great for developers, but it's really bad for production systems. And so they default these systems when they install them to not turning on, not showing errors. So we have to find out how to change the errors. So we're going to go to that start page and then go to PHP info, and we are going to look at the loaded configuration. It's right here. C:\mamp config PHP 7.1.5. You got to remember this perfectly. 7.1.5. Okay? So, let's open that file. File, open file. We're going to go to MAMP. I'm going to keep going back and forth. Is it in configuration? No, I think it's in, I've got to keep going back. Conf PHP 7.1.5. Okay. Conf PHP 7.1.5. This file right here is the file we're going to open. And here we are. Now you're going to search down for a field named display errors. Let's just scroll down here. Display errors. I'll find it. So it's turned off by default because of security. Let's not find that one. Okay, so I think I found it. Okay, display errors off. So we're going to change this to on. And I might as well display startup errors to on too. So there we go. So it's still going to log the errors. We'll talk later about where these logs are at. But now I am going to save this file. So I've changed that. And then I am going to stop the servers. You don't have to stop the servers very often. But in this case, we have to stop the servers because we've changed the basic server configuration. So this will take a moment. So they're stopped. Now let's start them. So they're coming up, the Apache server's up, and the MySQL server's up. And now we can just refresh this page. Okay, so we can go down and we can look at where the display errors are. Okay, display errors on. Startup errors on. That's what we want to see. Okay, now that we've got these, when we hit this, instead of giving us a very nondescript, kind of not very helpful, it's going to say, oh, parse error on line 6, unexpected echo. So now I can go back to my code here, close that, and go like, oh, line 6, it was not expecting echo. So let's put the semicolon back in and save it. Now we can hit refresh, and it works. Okay? So make sure to fix these, and do it early. You will waste hours and hours and hours if you are just getting those 500 errors while you're writing your code. So please do this and do it early just to keep your sanity so that when you make mistakes that you get some feedback as to what went wrong.
Hello and welcome to Web Applications for Everybody. In this we're going to get started. We're going to learn a little bit about how to install XAMPP on Windows. I'm using Windows 10, and so I'm going to go to the Apache Friends website, and let me make this a little bigger. They got a great video here. I won't show it right now. So I'm going to download XAMPP for Windows. So I'm going to click here to make sure the download gets started. Okay, so it's finished downloading and we're going to go ahead and run it. It's in the folder downloads if we wanted to take a look at that. So I've got my download running. Okay, so it says install it. Don't avoid into the program files because the thing to do is install in the default location, which I will show you is /XAMPP. And I don't need a few of these things. I don't need Tomcat, I don't need Perl, I don't need fake sendmail. So I'll do that. I'm going to stick it in that default, which is a little inconvenient, but it's nice because it makes life a little simpler. Okay, so this will take a little while. So now that the installer is finished, I'm actually not going to start the control panel right away because I want to show you how to start it in case you don't do this, although you can just skip ahead and do that. So I'm going to finish the install. So the install is now complete. So I want to show you where it's been installed to. So I'm going to go up to my Windows browser, my local system, go to my C drive, and go into XAMPP. And so I'm in Windows C XAMPP, and this is where it's installed. And if I scroll down here, I can find the XAMPP control panel, and I'll start that. Oops. It's asking me for which language. Now, when this first starts up, it's important if you're being given any security dialogues that you say yes to those security dialogues. It's a little tricky. So this is the control panel. And the things we're doing is the web server, which is Apache and MySQL. So I'm going to start those. Oh, let me do one thing here. I'm going to right click and pin this to the taskbar. So now this will stay down here. Okay. So I'm going to start the Apache web server. Now watch for red mistakes or watch for pop-ups, and it's good. So I got no red errors, and I think it's because I'm running on my administrator account. And I'm going to start the web server for the database server, and that's running, and so that's really good. You may have some other trouble. I clicked the stop by mistake. I got to not hover over them, and then okay. So there we go. I've got to get them both started. Okay, so now that they're both started, I can take a look at the details, and now this is the XAMPP dashboard. It's running on localhost. That means it's running on a web server that's running on my computer. And a couple things that we can do is we can look at the details of our PHP installation. And that's nice to have. We'll look at that in a second. You can also look at PHP MyAdmin, and this is how we talk to our database. And so the fact that this is running and it's successfully connecting and doesn't get error messages, that means we've got a very successful installation. This screen here tests a whole bunch of things. Okay, so one of the things that we need to make sure is look for a variable called display errors. So let's go find that. It's right here, and it's on. If it's off, you have to change the configuration so it's on. So let me show you how you would change it. Even though XAMPP seems to install with this the right way, we'll see in a second. This is something you want off in production and on when you're doing development to keep you from going crazy. So you go to this configuration for Apache and you pick the PHP configuration. And then you scroll down. I'm going to use Control F to find it. Display errors. Find next. And I'll go down here until we find it to be on. Now this is exactly describing what's supposed to be on. For developers, you want this on, and for production, you want it off. If we were going to change this, and there's a display startup errors as well, we would save this. We can save it. We didn't. Oops, come back. We would save this, okay, and then we have to restart our Apache web server. So we'd stop it, and then they would start it back up. And then when we come back to the admin page, and then we go to PHP info, and then we'd look for display errors, and we'd see that it's on. So you shouldn't do development until that's on. Now we didn't really have to change it, but I showed you how to change it if it was wrong. Okay? So I'll close some of these windows. We don't need the web page for downloading anymore. So now we're looking at the dashboard. And so what I want to do is I want to write a very, very simple program. So I'm going to start up my Atom text editor, which I assume you've installed. You can use any text editor you like. I just like Atom because it works the same on Windows, Mac, and Linux. So I'm going to make a new file. And I'm going to put some HTML into it. And now I'm going to save the file, save as. Now I have to put this file in a particular location. On my C drive, under XAMPP, under htdocs. And so this is all the stuff that this local web server, C:\XAMPP, right? C:\XAMPP htdocs. So what I'm going to do is I'm going to make a new folder right here. I'm going to call that folder first. Now you'll be making lots of folders in here. And then I'm going to save this file as index.php. So in the folder first htdocs first index.php, I've got hello world. Now I can go over here to this URL and take off dashboard and type first/index.php. If I get this right, I should see that little file. Okay? And so there we go. Now I have created my first little bit of web code that's coming out through this web server. And so what I want to do now is I want to grab some of the code that's got some PHP in it just to test. Not that it's a big deal. I got a little PHP in this handout. That's the old handout that I'm fixing. Here's this PHP code. I'm going to copy that, and then I'm going to go in here, and I'm going to curve there and go paste that in. Oops, I need to paste. Control A, Control V. There we go. And it knows it's PHP and it's got syntax highlighting. This is flat HTML. This is switching into PHP and doing some computations, doing a printout, and away we go. And so now I'm going to save this with Control S. You'll always know that that when that little blue dot there is, you've got to save it or it won't save correctly. So now I go back to my browser here and I hit refresh and it'll run that code. And so this part was from the HTML. This part is running PHP. It did a calculation, and there is another paragraph. So I hope this has been helpful. To get this installed, you'll be doing a whole bunch with this. You'll be building databases, you'll be writing PHP code, and so we just have to get you going and get you up and running. Cheers.
So welcome to the Introduction to PHP. I always like to put what we're talking about in a historical context, and PHP is a language that owes its inspiration to many different languages. If we go all the way back to the beginning of sort of programming. We had machine code where we built hardware and we programmed it very directly. We had very little memory, so we had to be very careful with our programming. The early days of computing were science calculations, where you're doing weather and you're doing, ballistics calculations and very mathematical things, and languages evolved that were just sort of slightly above the assembly language that made us more productive. In languages like Fortran, 1955, really some of the earliest things that we did. But what happened as we moved from the 50s through the 60s to the 70s, it became increasingly clear that numeric data was not just what we were going to do with computers. And so strings, letters like hello, like the word hello. And so writing programs like text editors and Twitter and stuff like that in a language like Fortran would have just not worked very well. And so we began to see in the early 70s as human interaction mediated by a computer became an important part of what we were going to do, string-oriented languages started to evolve. And there were lots of string-oriented. There are just thousands of different languages. And I remember working through that and like, oh, here's Pascal, that's really cool. Here's Snowball, that's really cool. And Fortran 77 had strings in it. But then what happened was this language C came out. And C was this amazing language. It's crude. Someday I'd love to teach a MOOC on C. It's very crude but very powerful. And it turns out that C is the language that's used to write things like PHP and Python and Perl. The C language gave us the speed of assembly language with portability between different computer systems. But it also did strings pretty well. It doesn't do strings as well as modern languages, but it did strings really well. And so this moment where we sort of transitioned from Fortran to C as sort of the most important language of computing is when humans start to send messages through computers and talk. And so C has sort of created lots of offshoots. And anytime you see a language that has curly braces, then you know some of its inspiration to C. So we see languages like C++, which is an object-oriented version of C, Objective-C, which is another object-oriented version of C, Java, which was kind of this web language that, it was a web kind of version of C. Microsoft C# was really inspired by a combination of C++. And the JavaScript language, which came out in 1995, really took a lot of its inspiration from C and other kind of weird languages of the time because it has a different object-oriented pattern than all these other ones. So Java, C++, and Objective-C have kind of one object-oriented pattern. And JavaScript actually has a very different one. We'll talk about that later. So there's all these kind of the kind of nerdy languages. At the same time that we were building and innovating in nerdy languages, we were building languages not so much for end users, but for like system administrators, people who didn't see themselves as professional programmers. And these languages were very much inspired by C and written in C. So Perl, which is a report generator that was started in 87, Python, which started in 1991, which now has become a super popular one. I teach a popular MOOC on Python as well. They were written in C, and so they took their inspiration from C. And so while Python doesn't have curly braces and Perl doesn't have curly braces, they have things like stir functions, etc., that sort of inspire themselves from C, but they were written in C. And so sort of Python and Perl inherited a lot of what they basically do at low levels in terms of functions that they do from C. So PHP, the language we're talking about today, is also a derivative of C. And actually it has a lot of inspiration from C because it has curly braces, it has some of the same stir functions, stir blah blah blah. Those came from C and were sort of adapted to work in PHP. And so sort of below this line, one of the focuses was simplicity, ease of use. Because this is sort of the pro computer scientist. If you're a computer scientist, and this is sort of like building this and building games and doing data analysis, sort of non-computer science stuff. And so that's why if you look at computer science curriculums, they're all up here. Eventually, like I said, someday I want to teach a C class because I think that even if you're not a computer scientist, I think there's a lot to learn to go kind of back to the origins. So what I'd like to do is I'd teach this class. I don't think I'm ever going to teach a Pro class. And I would teach both of these classes because I want you to be able to see, even if you're not a computer scientist, I kind of want to see the whole history of how your language came to be. And so with that, up next we're going to talk about PHP.
So on we go about the PHP language. Like I said, it comes from the C language. You see curly braces. We're also going to learn JavaScript, and that has curly braces. No significant white space. Again, that's all from C. There's some things where PHP is inspired by Perl. Dollar signs for variables, which is one of the things that people find annoying about it, and associative arrays, which people love. And the idea is that PHP is a language. While you can use it for things other than HTML, it really is intended to be an HTML templating language, and it really exists to serve web applications. And that's one of the reasons that I really like it. One of the things about PHP is it's a productivity tool. It's not a tool that's really designed as a teacher. So if you take a Python class, Python blows up all the time. PHP doesn't blow up. It figures if you typed it, you probably meant for it to happen. And so PHP is trying as hard as it can to just interpret what you're saying and just do what you want. And the idea is you're supposed to be able to write code fast. You know what you want to do. Sometimes errors are silent. So you're supposed to be a responsible programmer. And so you may find this responsibility on your part as like, oh wow, why don't you stop me from making mistakes? But that's not necessarily the philosophy of PHP. So as I said, PHP is like an extension of HTML. So we create files that end in .php, and in that they start, the first line is HTML, and so this is just HTML, and at some point you switch into PHP with a special kind of tag. And it turns out there are a couple things. This less than question mark is something that was built into HTML for various programming languages, kind of like escape to the server side. So the browser is interpreting this, and then the server is running this code as it's producing the response cycle, request response cycle. And so this, you switch, and now you're in the PHP language. This code emits output. So the output to this code, like an echo statement, which is a print statement, that actually becomes part of the page. And then it runs code. We're going to answer 6 times 7. You'll notice semicolons, down statements, another echo statement, some more output, some more output. So what happens is what the browser sees is not this code at all, but instead the output that's produced by that code. And now the question mark less than finishes that, and now we're back into HTML. And so if we run this, we're going to see this HTML, the results of this PHP execution, not the code itself, and then that HTML. And so that's what it looks like. Okay, and so here it is. The answer is 42. We can't really tell the difference between just looking at the HTML. This came from the static HTML part. This came from the paragraph tag, came from the template, and all this text came from this code running, and then another paragraph came from that. So you switch back and forth. And just because I showed only one, you can have a long file. You can switch in and out of HTML and PHP as much as you like. Sometimes we'll switch in and out of HTML and PHP in a single line. We'll just kind of like right here in between Dr. Chuck, we'll do less than question mark PHP, some stuff, question mark less than, and we can do it right in the middle of a line. It doesn't have to be a whole block of text. It can be right in the middle of the line, and then the output of this is stuck into the HTML right at that point. Just for completeness, PHP is really designed as a web language, and that's why I like it. I've also seen people who only know PHP and have done things that are command line with PHP. You can open files, you can read them. PHP is good at parsing strings, but I would say that Python is probably a better use of command line if you're going to write command line applications. I saw somebody over their shoulder. I'm like, really? You know that? So I didn't realize it, but you can. But I don't recommend it. So up next, we're going to talk about the basic syntax of PHP. So an important part of any programming language is the keywords. And they're reserved words, keywords. These are the words that you can't use for any other thing, meaning if you say the word class or clone or do or else, PHP is going to say, I know what you mean by that. That has a very specific meaning to me, and I'm going to ignore. You might treat that as a variable, et cetera, et cetera, et cetera, but that is reserved for PHP, and so you don't get to do what you want with that. It just means that you have to avoid these. Most of these, like case maybe, or as, class, and some of these you might mistakenly use as a variable name, so just avoid these, and sometimes you'll get a syntax error, so these are just the basic things.
Probably one of the weirdest things when I go back and forth between PHP and another language, and I love programming in multiple languages, is the fact that in PHP, all variables start with a $sign. And that's weird. It's kind of a throwback to Perl, followed by a letter or underscore. So after the $sign, it's the same rules as to most variables, letters, numbers, and underscores after starting with a letter or an underscore. We tend to not use underscores unless it's sort of something internal so that we don't collide. You know, if I'm building a library and I have a variable, I might stick an underscore in the front of it that I don't want anyone else to see. Not that they can't see it, it's just that you hope that there's no collisions. And so the weirdest thing about this is that if you leave the $sign off, it may or may not be a syntax error. And so you got to discipline yourself. When I'm coming from like JavaScript or another language, I will start typing it and leave the $sign off, and then I cause myself bugs. There's a little bit of weirdness when you leave the $sign off, because there's a syntax where you can have something like x with no $sign, and it's a predefined constant that it assumes to be 0. This may give you a non-fatal error, or it may just silently turn that into 0. It's not going to turn into 2, right? It's not x equals 2. That's not 2 there. That's a non-existent predefined constant that might turn into 0 and give you a non-fatal error. On the other hand, if you put it on the left side of the assignment statement, it's going to actually give you a parse error. So all you mean is just put the $signs in, but PHP is a little weird when you make syntax errors. Sometimes earlier versions of PHP would do things like this is an array that is a key value array. It maps x to value hello, and you could put x in square brackets to kind of look that thing up. But PHP in early versions allowed that without the quotes. JavaScript kind of has a similar kind of idea there, that you can do it with or without quotes. And so it would sort of stick quotes in here. These days, it'll stick those quotes in there, and it'll give you a non-fatal error. So again, this is just kind of letting you know that sometimes if you don't use $signs, it has a weird behavior. So strings are a little bit different than in other programming languages, and part of why I focus so much on differences is that I assume at this point you already know one programming language. Hopefully, it's Python. And so I like you am going back and forth between programming languages: Python, JavaScript, PHP, etc. And so I'm trying to highlight the things that are different. So strings in PHP are awesome. I actually like them. I wish other languages would do the kind of things that PHP does, but they don't, which sometimes gets me in trouble when I go from PHP to another language. So you can use single quotes or double quotes, and they function a little bit differently. Backslash is used as the escape character. That really is kind of a C-inspired idea. Strings can span multiple lines. They can just go, and they can go round, round, round. You can start one and then stop it. I love that. I absolutely love that. And double-quoted strings, variables are expanded, and variables have $signs in them. This is kind of one of the weird things about why there's $signs in variables. And a thing that I absolutely love, but unfortunately it's not the same in any other language, is dot is concatenation, which I think is awesome, and plus is a mathematical operator, where in most languages, even though I love PHP, most languages, plus is the concatenation operator for strings. So we'll talk about that in a little bit. So here is the use of a double-quoted string. So double quotes and single quotes are different. So double quotes I think of double quotes in PHP as smart strings. You can do more things in them. So for example, a new line works in a double-quoted PHP string. You can have embedded new lines. You start the string here, and it comes all the way down to here, and there is a /n here and a /n that PHP automatically adds. I think that's super natural, very natural. I wish more languages did it. Other languages, you have to work a lot harder to have a multi-line string, and so this is quite natural. You can have a new line in the middle of a string, and so this will, the new line will cause the text to go back to the beginning of the next line. And here's kind of the weird thing that you learn to love after a while. It's both wonderful and dangerous, so you got to be careful about it. If inside of a double-quoted string you see a variable, $expand, it actually puts the 12 in there. So it wipes this out and reads the 12 that's in expand and puts the 12 in there. That's cool. It's also dangerous. So we'll learn about when you don't use this. You certainly don't use this when you're producing SQL statements. But actually, if you know what you're doing and you're careful about it, this is really a way to write really nicely, easy to read code that makes a lot of sense. So single quotes I think of as sort of not such smart strings. And so single quotes, start and stop strings. You can also have embedded new lines. So this one starts here and stops there, and there's new lines, /n. You can put double quotes in a single quoted string just as a normal thing. If you want to put a single quote in, you have to backslash it to escape it. And this is something I don't like. This is probably my least favorite feature of single quoted strings, and that is new lines do not, \n doesn't work inside of a single quoted string. I have to sort of, I'll sometimes do something where I do a single quoted string and I'll concatenate it with a double quoted string just so I can put a new line in. You know, it's like, why do I have to do that? Sad face. But just remember, that wasn't my idea, but if you put new lines in a single quoted string, a \n in a single quoted string, it doesn't expand. And the whole trick of $ don't expand. And that actually is good. I mean, I like that. So you know when you're using a single quoted string, $ are not going to expand. You know when you're going to use a double quoted string, $ variables are going to expand. Comments in PHP are truly awesome. You can use comment style that came from C++, which is // to the end of the line. You can use the comment style from Perl and shell scripting, which is # to the end of the line. And you can use the comment style from the C line, which is start of comment, which is 2 characters, that goes all the way to the end comment. And so this is really nice. We use this for documenting code. You know, so if you write little API documentation at the beginning of some code that you're writing, that's really nice. This is C++, this is the C language, and this is like Perl and shell language comments. So they just made it, hey, why not take all the existing comment styles on the planet and use them all, which is really quite nice. Because again, I go back and forth between PHP and lots of other languages, and so there we go. The output, there's more than one way to do it. Echo is a language construct, so you can say like echo $x, or it can be treated like a function, echo a new line. You can have more than one parameter, $x, comma, and it does not add a space here. There is no, it just concatenates these things together. And then there's a print statement. It's actually a function that happens to not require the parentheses if you don't have the parentheses. The difference between print, they do the exact same thing. The difference is echo can have more than one and print can only have one parameter. For whatever reason, I tend to use echo all the time and not print. I think echo came from the bash shell and then print came from Perl, I think. It certainly looks like it also came from Python. Yeah, it could be from Python. Perl and Python use print, I think. So the PHP philosophy is like, hey, if you want to do it, you can do it. We'll let you kind of pretend you're in more than one language. So up next, we'll talk about operators and expressions. So an important part of any programming language is how it handles expressions. Those are things that are kind of on the right-hand side of an assignment statement or all over the place, right? You know, if you have pluses and minuses. It works very much the same as all other languages, using plus, minus, /, asterisk. Actually, this whole convention, this thing came from Fortran. That's how old that is. That's from 1955. Right? That's 1955 is when we had these, when they decided multiplication was asterisk, probably even before that. And we still use it to this day. So that every time you type in asterisk when you want to do multiplication, think that's from 1955. And so the expressions are on the simplest expression sort of here we have on the right-hand side. The interesting thing about PHP is that it has something that's actually rather rare, although JavaScript is kind of another language that has very aggressive type conversion, in that it doesn't want to blow up. It wants to convert it. And so if it looks at this string 15 plus 27, they're like, what is going on here? Now, one of two things could happen. It could treat that as a string and end up with 1527 and concatenate those two things together. That's not what it does. It actually converts this to an integer and then adds them together and gives us 42. And so there's a lot of implicit type conversion. This plus is a numeric, and so it's going to try to convert its operands to be numbers. And so that's how we end up with 42. So the values can be strings and numbers. We can use function calls. And there's this order of evaluation that is the same for all programming languages. And they can also produce operations. So some operators of note. If you're coming from Python, some of these have Python equivalents, some of them don't. We'll talk about some of these. There is an increment operator that just says add 1 to this variable, subtract 1 to the variable. Concatenation, that's quite special. Equality and not equal, these are both common across all C languages. This also came from C. Identity, this is equal in value with type conversion. And this is equal in without type conversion. So the triple equals and the triple not equals, no type conversion. So in false is equal to 0, but false is not triple equal 0, because these are different types. False and 0 are different types. Here it's going to convert that to a 0, then that's going to become true. Here it's not going to convert that to 0. The ternary operator, we'll talk about that. This is also kind of a classic 1972 C idea. And then the side effect. And then there's other things that come from, these are also come from C that are very bit-oriented operators, and that's the 0s and the 1s. And they're anding and oring and shifting these things around. These usually have no use unless you're doing something like a compression or encryption or something like that. So if you see these, you're not going to tend to use these operators. Okay, so let's look at them. So increment and decrement, this plus plus is a side effect. So if we have $x and it has a 12 in it, so we come in here, and again, like any right-hand side, it's evaluating this right-hand side. So it has to first resolve this x, so it has to go retrieve the x. So it pulls the 12 out and makes it part of this expression, but then, as a side effect, and the plus plus is after the x, it turns this to 13. Now the 12 still exists, so it's 15 plus 12, and so we end up with 27. Okay? But x has become 13 in this next statement, because as a side effect of reading and adding 1, that's what we got. You can also say plus plus $x, and the only thing that does is it adds the 1 before it copies the versions of it copies the value into the expression. So in that case, this would be 28. X would still be 13. Now, most civilized people tend not to use that unless there'll be places I'll tell you to use it, and in general, I tend not to use it at all. And so we tend to do things like add 1 to it explicitly. So we say x equals 12. So we have this x, and there's a 12 in here. We copy the 12 into this 15 plus x, so y is 27. And then in this next statement, we then add 1 to x. And so we add a statement here, but we're making it a little clearer as to what's going on. Some people like to show off and write as dense a code as possible. I tend to avoid that. The period character, like I said, is a string operator. So it's not just the fact that it concatenates strings. It will also convert its operands to strings. Now, it does not add a space. It's just a pure concatenation. So if I want hello space world, then I have to add that hello. And so I can echo hello world with no new line, but then I concatenate that variable with concatenated with a new line. So I get my new line here with hello world. So one of the things about PHP is the operators have attitude in that they are expecting and or converting based on the type. So strings are, dot is a string operator, plus is a mathematical operator. So that actually is in some ways a little more predictable than some languages. Like JavaScript has this kind of stuff, but you can't always predict what it's doing because the operators are more object-oriented. Okay, so this is the ternary operator. The ternary operator comes from the C programming language, and it comes from a time when we wanted to make things very succinct. And so the ternary operator is basically an if, then, else in a single line. So we have an assignment statement here, and there are 3 parts. It's called ternary because there's 3 parts. The first part is a question that evaluates to true or false. The second part is the result of the expression, because this is kind of an expression. You could put parentheses around it right there. This is the value of the expression if this is true, and this is the value of the expression if it's false. So the way I think about this is I think about this as you got these 2 values kind of in flight that are going to go into this variable message, and then we pick the one. So in this case, www is greater than 100, so it's a true. So we pick the one that's true, and then that one goes in. Okay, so they kind of both end up in flight, basically. It's like this is an assignment statement, and one of these 2 things is going to get in, and it turns out this is the one that gets in. Okay, and so that's why large comes out. And so we can do things like take the divide dub by 2, take the remainder, and ask if it's 0. That would mean that it's either an even number or an odd number. And in this case, this turns out to be false because it's 123. And so odd gets put over here, and so away we go. This is sort of an example of type conversion. We take dub, get the remainder after dividing by 2. And in this case, that's going to be 1 because it's 123. And that's going to turn into true. So 1 becomes true. And so odd gets copied into message. I flipped the order of the even and the odd because if the result is a 1, that's true, which is odd. And if the result is 0, then that's false. And then you get even. So that's kind of a ternary operator. I wish I didn't have to teach that to you, but we tend to use it a lot for certain things like checking to see if a key is in an array. And so there's a bunch of syntax that we do, and so we use it over and over and over again, so I have to teach it to you. I'd rather not teach it to you, but we just kind of, if we didn't do that, we'd have way too many if-then-elses in certain very specific situations. These are like idiomatic situations where, oh, you look at it and go like, that's what he's doing. I understand what that is. It's really an idiom, and he used the ternary operator, so I'll forgive him. But you don't want to overuse any of these fancy operators. Side effect operators, you can use these things. So count plus equals 1 is the same as saying $count equals $count plus 1. This is just a contraction of this expression. And it's this. I would never use this. I would not use that code right there. But I do use it here in constructing strings because you tend to. There's code places where you start a string, add something to it, add something to it, add something to it. So one way to do it is here you start a string and then you want to add a blank to it. So you say out equals out dot that's adding a space to the end. And you're going to do this over and over. You're going to say that over and over and over. So we contract this to be out dot equals world, and that concatenates world to the end of it, and that concatenates a new line. And so that prints out this, including a new line to go down there. So this is a way, usually this is a silly example, but we use this to grow strings. Start a string, add a little bit more to it, add a little bit more to it, add a little bit more to it, add a little bit, and we use dot equals to kind of add to the end of the string. And that I tend to use. I tend to like that. I tend to use that. Conversion and casting. There's a lot of aggressive type conversion that happens, as I mentioned. You can also explicitly force it when you want to. It's actually something used more rarely in PHP than other programming languages. So let's take a look at some of the crazy things that are going to happen here. So we have some numbers. Division. This division, even though these two things are integers, the division produces a floating point number, which is actually a sane idea. Divisions of integers that produce non-floating point numbers, like Python 2, for example, are not so logical. This one's kind of weird. This a plus operator is a numeric operator. 36.25 is a floating point number. True is true, but then it gets converted to 1 to be numeric, and 100 is a 100 string, and that becomes a number 100. So this is going to be 137.25. And indeed it is. And that is not a syntax error. And you're going to look at PHP and you're like, that's bad. But you get used to it and you say, I guess I don't mind that. That's a powerful capability as long as you use it wisely. This, of course, is not wise. I'm just showing you what's possible. All right, so that's a bad line of code, but there you go. So here we're going to do concatenation with D. Concatenate it. That's a string operation, so this is a number, but that it forces it to string automatically. You could put parentheses string, that's a type that says convert that non-string variable into a string. Away you go. That's not too useful because the dots would have converted it to a string anyways. But you can take something like 9.9 and convert it to an integer. So that turns this to 9 minus 1 and gives us 8. So that's really a truncating conversion to integer. And again, here we have a string added to a number, but remember that this is a numeric operator, which means that it's going to force its operands to become numeric. So it turns out that what it does is it doesn't blow up. Again, you might like it, you might not like it, but it turns that to 0. And so Sam plus 25 is the number 25. Sam concatenated with 25, that's a string operator. So that says, oh, I can convert this 25 to a string, and so you end up with Sam 25. And it works out. Plus is a number. Dot are strings. And so that part is pretty consistent. It's like, if there's pluses, we're going to force them to numbers one way or another, including craziness, like the string Sam turning into a 0. And so but the dot is for strings. And so I actually wish more programming languages thought that way. Programming language like Python tends to want to blow up, right? And so in PHP, we can add the string 100 plus 25 numeric, so that's 125. We can concatenate 125, and that gets 100 concatenated with 25. And we can add Sam to 25, and we get 25 because Sam becomes 0. So in Python, we have to be explicit about this. We have to say int 100, and then this converts it, and then adds it, and we get our 125. Or if we want to concatenate, so we're using the same operator in Python to do the concatenation, but we do have to convert the 25 to a string, so we can concatenate that. And if we foolishly try to convert Sam into an integer, we get a traceback. And so this kind of tells you the philosophy of PHP in that it lets you do things in PHP that in Python are going to blow up. And in a way, this is one of the reasons that I like Python as a beginning language, because it sort of keeps you on a very tight leash. You have to be very precise in what you're trying to do. If you try to do something silly, it's going to stop you. So you can say, wait a sec, what did I do? Why did I do that? Oh, maybe I did, this is silly. But what if that was a variable and you're like, oh, that was a string. I forgot that I put Sam in there sometimes. And so it's helpful because this, while it can be frustrating to get a trace back, this can also inform you on what you've done wrong. Whereas PHP, right? Again, responsible. It'll do what you say, even if what you say isn't the most logical thing. It'll do something. Casting. So true becomes 1. I mentioned that. One of the most frustrating things that happens to me as a programmer is false becomes nothing. So if I take this dot, again, as a string operation, so it's forcing false to become a string. When it forces true to become a string, true becomes 1, so x1y. False is nothing. So if you try to print false out with an echo statement, it's going to not print anything, and that has driven me crazy on more than one occasion because I'm like, echo with this variable x, and there's nothing. And I'm like, it didn't get to that line. Oh, wait a sec. After 20 minutes, that was a false, and that's why I'm not seeing anything. So false doesn't print out well. So the equality operator, as I mentioned earlier, is aggressive type conversion operator where it tries to match the type conversions. So here's some silly things that in many languages would blow up, but in PHP are totally cool. So 123 is equal to the string 123. Well, that's because it's trying to convert them, and so it does, and it finds that they're equal. Here we've seen this. That just turns into 123, so that's going to work. Here, this is a little trickier. It's like, oh, false can become an integer 0, and this becomes an integer 0, so yay, they're completely cool. And this one here is really crazy. 5 less than 6 is true, which becomes a 1, and then the string 2 minus the string 1, that turns into an integer 2 because minus isn't an arithmetic operator, so that's 2 minus 1, which becomes 1, and look at that, 1 and 1 are equal. So that is like literally the craziest line of code to not the craziest line of code, but it's a very crazy line of code to not make a syntax error. I'm not saying you should do that. I'm just saying that's the aggression that all these operators in PHP tend to have. Sometimes this equal sign aggression, we want to stop it, and so we just say triple equals. And so this basically becomes true with no conversion, and it's the same as true, and so they're still equal, but if this was like a 1, that would be false because the triple equals suppresses type conversion. Triple equals compared to Python is like is and is not. Triple equals. Pretty much identical concepts. Okay, so one of the things that happens is that the thing that gets you in trouble is anything that's numeric, false becomes 0. So anything in numeric, false becomes 0, and there's also null becomes 0. Okay, automatically if it's in a numeric calculation. And so there are times where a function, in particular the string position, so the way string position works is it's looking for like one string. So if I'm looking for ABC, and then I have this needle, and it's a quote A, it returns the position, which is position 0. If it's a B, it would return 1. The problem is if it returns 0, that means that it found it, and what it returns is it returns false if it didn't find it. So you have to be careful to know whether you found it at the beginning or you didn't find it at all. And so you read the documentation, and it's warning you to use, even in the documentation, it's warning you to use the triple equals operator. So that's how important the triple equals operator is in PHP. And here's some simple examples of the stir post function. So here's this hello world. We're looking for the position of the WO, which is 0, 1, 2, 3, 4, 5, 6. So that'll give us a 6. We're looking for the string HE, and that will be right there in position 0. And then we ask where the position ZZ is. And this is going to give us back a false. And we're concatenating that, and you'll notice nothing prints out. Again, this is where I go crazy when I try to print falses out, and they don't show up. And this is the mistake that you can make. You can say if the position of the HE is false, well, this is going to find it. You think you're asking whether you found it or not, and this is going to be converted to 0 because of the aggressive conversion of the equal sign, and so this is going to print out incorrectly. Now, if we're looking for ZZ, this one's going to work okay because this is going to give us a false, and there's, when you do type conversion, they still match, which is what you would expect. But this is where on stir pose, you have to use triple equals, because if this returns a 0 and it is not equal to false, 0 is not equal to false because triple equals suppresses type conversion, right? And the same is true here. So all that says is read the documentation. Print doesn't show the false. Print R, which allows you to print even more detail. They never show out. They don't show up at all. So there's lots of ways to try to print false, and there's only one way that you can actually show them, and that's the var dump. So up next, we're going to talk a little bit about control structures, if, then, else, and things like that. So now we're going to talk a little bit about control structures. The if or if then else is kind of the first one we take a look at. There's a whole series of logical operators. We talked a little bit about the equals, the not equals, less than, greater than or equal, less than or equal, greater than or equal. These are pretty obvious, and if you know other programming languages, they make sense. The ones that are kind of new, unless you've known C-based programming languages before, double ampersand is and, a double vertical bar is or, an exclamation point is not. Exclamation is like not, but it comes in the beginning, so it'd be like not something something something, and then so we put that at the beginning. So exclamation point is not. We use curly braces to set out the beginning and end of things. So here's a simple if then else. We have some variable. We have, as most ifs, you have parentheses that are required here. This evaluates eventually to a true or a false. If this is not a Boolean operator and the double equals is a Boolean operator, this could evaluate to non-zero and 0. And non-zero becomes true and 0 becomes false. So this could be a mathematical calculation. So if I just put if $ants, which is 42, that would then become true, right? Because this is non-zero. If this somehow evaluated to 0, then it would become false. So then this evaluates to true or false. In this case, it's true. And then there's a curly brace and a curly brace, and that's the block of text. Then there could be many lines in here. There's only one line. And this is the true block, and this is the false block, like most if then else's. The first if part is the true part, and the second part is the false part. And then you have, at the end, you have else, which starts a new block, and then you have an open curly brace and a closed curly brace. So this prints out, this comes and runs, this becomes true, so it runs this block of code and then skips to the end and then never runs this block of code, so out comes hello world. Whitespace doesn't matter. That's a nature of a C-based programming language. We put whitespace in. We are very good at putting whitespace in because we just don't want to be crazy. So this is all pretty. It's got indenting. You can argue all day long about what the best indenting is. This has all a big mess. It's all concatenated together. Could be one long line. PHP loves this stuff, but humans hate this stuff, right? So we're very careful to be stylistically pretty. Some languages like Python demand indentation. PHP does not, but we do anyways. Just so you know, it's not essential. If you want to start a fight among C-style programmers, ask them if you like the old or the new style of indentation. The old original style from 1970s, which I still use because I was around back then, is the curly brace comes up and then the closed brace lines up with the if. Then you pull all the else up onto the same line and then the second closed brace lines up. This is my favorite. But others say, you should have this open brace and closed brace on their own lines and they should line up. The else should be its own thing. And so I don't like this, but I understand that this is an artistic choice when you're looking at code. What you should probably do is just follow the pattern. You should learn to read both of the sort of variants and then follow the pattern of the code that you're in. It's not worth arguing. And the other great argument is whether or not this is a tab or 4 spaces. That's another great argument to have that can divide and anger programmers quite badly. A multi-branch if. This is an if, else, 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 else. And like in most languages, a multi-branch if is the way it works is it's evaluating until it finds a true. And then when it finds a true, it's done. So it checks them in order. If this is true, then it runs the first one. And if this is false, then it skips and checks. So it doesn't even do the second check. It's not like it does all the checks first. It checks the first one. If it's true, it's completely done. Then if that one is false, then it even checks the second one. And if that one's true, then it does that one and it's done. And if this is false and this is false, then it'll run that. And you can have as many as you want in there. Curly braces are not required if it's a single line, right? If it's just going to be a single line, some people will sort of pull this up on the end of the if because white space doesn't matter. And so this is a completely legit thing. It's equivalent to this. I would never write this code. I sometimes will do it with one if and a real tiny bit of code up here. I'll put it up there and add a semicolon because then it's really obvious. But as soon as it gets this complex, I'm going to be putting curly braces, and I'm actually not even going to do. Actually, that's a sad face. I'm not even going to like this because if it's this complex, I'm going to put these on separate lines and indent them, etc. Because part of the job is to write code that other people can see, but you are not required, and you can do it. For looping strategies, there's a while loop, which is a zero-trip loop, meaning that its functions the first time in is like an if statement. So it's an if statement, but the difference with it is it just keeps going and checks at the top. So it's a top tested loop or a zero-trip loop. So in this case, fuel is 10. This starts here acting kind of like an if. If fuel is greater than 1, true, so then run this code. So then it prints vroom, but the difference is it goes back up, and fuel is still greater than 1, so it says vroom, 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 vroom. This is an infinite loop, and it's not a good thing to do because we did not create an iteration variable. We have this iteration variable. We didn't change it inside the loop. That's the way you get an infinite loop. So here is a better version of that loop. So fuel starts as 10. If fuel is greater than 1, do it. The answer is yes. So it runs the vroom vroom. Then it subtracts 1 and goes up, and fuel is 9, 8, 7, 6, 5, 4, 3, and it'll run the 2. Then I'll subtract it. It'll be 1. And at that point, when fuel is 1, it's no longer greater than 1. So then it's going to go up. So this is going to run 10 times. And we have a real iteration variable, and we are also responsible, we the programmer are responsible for managing the iteration variable when we're using a while loop. There's a one-trip loop called a do. It starts with a do statement. I rarely write these, very rarely. Whiles tend to be how we think about code. It's a one trip, which means it's going to run this code before it asks the question whether it's a good idea to keep running it. But sometimes you want a one-trip loop. And so it's going to run once, and then it's going to do whatever it does, and then plus plus count. That's going to add 1 to count automatically. So there's one of those plus plus operators that adds 1 to count, and then it adds 1 to count, and then after the addition is done, that's what participates in the less than or equal to 5. So this is going to run a few times, and then it's going to finally, because we are adding 1 to count right here, that's adding 1 to count, so we do have a well-managed iteration variable, and then we end up running this thing 5 times. 1, 2, 3, 4, 5. Again, I tend to not write these. But back in the day, I mean a long time ago, 1970s, this was just there for completeness. Now we use this a lot, and you might as well go ahead and learn this because every C-based language has this counted for. Java, C++, JavaScript, Objective-C, they all have it. So this is a counted for loop, which is not like a go all through all things in an array, which we'll talk about that in a second. What this is a counted loop. So this has a bit of code that runs before the loop starts. That initializes the iteration variable generally. We have a test to decide whether or not we're done with the loop. And so the loop continues as long as this remains true. It is a top tested, which means if it's immediately false, this loop it'll skip right past it. So it sort of functions like an if statement in that result, meaning if this becomes false before the loop is run even once, the loop will not run once. So it's a zero trip, top tested loop. And then we have a count plus plus, and this is really common to increment, that's count equals count plus 1, at the end of the loop. So it's kind of like down here before the loop comes up. This code here runs at the bottom of the loop. So this just is now a counted loop for I equals 1 to 6, 1, 2, 3, 4, 5, 6, right? So that's a counted loop. So this becomes kind of like an idiom. How you do counted loops in all C-based, all languages that are C-based. That's a counted loop. Like all C-based languages, the notion of break and the notion of continue are in the language. So the break is the simplest one. If while this loop is running, if this code executes, it basically takes this entire loop and gets rid of it, and it just gets out of the loop. It escapes the loop. So you can have this could be hundreds of lines of code. As soon as you hit a break, it knows which loop it's in, and it starts executing at the line after the end of the loop. Okay? And so that's what the break is. The continue is another executable line of statement. Instead of going to the line after the loop, it goes to the top of the loop. So continue says, oh, we're done. Don't run these lines down here. We're going to go back to the top of the loop, and we're going to run. The key thing is it sort of runs through this bit right here. So it does do the increment, this third thing, and then it starts the thing up. So you need to increment your iteration variable, otherwise your loop could become an infinite loop. So that's how continue works. And again, all C-based languages, C invented this idea of break and continue. Not everyone loves them as much as I do, but it's something that I use and something you will probably use. And then you'll meet someone who's a purist and they'll say, you should never have to write a continue. And I'm like, yeah, then you have too many if statements. Okay, so that was roaring through some of the unique language features of PHP. I didn't just try to teach you PHP because I assume at this point that you already know a programming language. Because if you don't know a programming language, you should go learn something like Python, because it's way easier to learn programming in Python than it is to start with PHP as your very first language. So hope this has been helpful. Up next, we're going to talk about arrays.
Right, so it started in 1993 when I saw the Mosaic web browser. That was when I got really interested in the web. I'd been doing Gopher and IRC and other internet-related things before then, but with Mosaic, I could suddenly explain what I was doing to my mother. So I knew this thing was going to be very, very interesting. I was living in Mountain View, California, but I moved back to Toronto to do consulting. And I ended up consulting for a number of companies, and I wrote the same code over and over, basically CGI script written in C. And I wrote similar code to handle forms and host data and filtering and all the sort of common web things you end up having to write in C if you're writing raw C CGI programs. So that was getting tedious. I'm not very interested in programming. It's kind of tedious and boring. So if I could reduce the amount of time I had to spend programming and maximize the output and get to the solution quicker, that was my goal with PHP. I put together all my common stuff into a C library, hacked it into the NCSA web server, and then added a little templating system on top of that to let me easily call into it. And that was the first version of PHP. It was a productivity tool for myself, so I could very quickly go to a new client and whip up a new web application for him and tie them to their database or whatever they needed. And every client had slightly different requirements, so I kept extending my tool. Then other people started asking me about this stuff. They asked me how I built these things, and I said, well, I'm using this little tool I built. And they asked if they could have it. I said, sure, why not? I mean, that's not what I'm selling. I'm selling my services of solving problems. The tool itself is irrelevant, really. It's just my hammer. Anybody can use my hammer, I don't care. And then they started sending me patches, which I thought was really, really cool. And they found bugs in my stuff that I hadn't found yet, and which meant I could also go into clients and say, hey, here we go, here's a new version that fixes this, this, and this. And they thought I was being extremely productive, writing all this code and fixing all these things so fast. So that's when open source really hit me. This was in 1994, 95, before the term open source existed. But it really caught on with me that I got together with a group of my peers, other people interested in the web and solving the web problem from all around the world. We all had similar problems, we faced similar issues, and collaboratively we could build a tool that solved this problem. And that was really how PHP got off the ground. I learned a bit along the way that in order for this to grow, I had to give up control of PHP. I had to let other people have some control. I couldn't rewrite everybody's patches, both because I'm pretty lazy and it's a lot of work, but also to give people some ownership in the project. And once they have some ownership, once they have full control over their part of it, then they become much more invested in it, and they become passionate, and it becomes theirs, not just them contributing to my project, it becomes our project. And that really changed the nature of PHP. And that happened around 1997 or so, where I really delegated it out and gave people full access to the CBS repository that I was using to develop this stuff in. And it grew like crazy after that, both because the web grew and PHP was sort of in the right time, the right place, but also because it was very, very easy to get in and get started contributing to PHP and using PHP as well. Obviously has a very low barrier of entry. So both on the using PHP side and also contributing to PHP side, I try to keep the barrier of entry really low. It does not take much, even today, to get a CBS account in the PHP project. Source revision control is a wonderful thing. It doesn't really matter how bad the initial patch is from some contributor. We can always fix it. I'd much rather welcome new contributors and guide them along and get them to be productive and useful than yell at them for having a bad initial patch.
You know, from the outside, you look like a well-oiled machine. You know, it's a well-oiled machine that accomplishes things, you know, more effectively than a commercial organization. But at the same time, it's sort of it's a band of brothers to some degree.
We have close to 1,400 people with CBS accounts, which means those people can all commit to some part of the repository, either PHP, Pear, Peckle, the documentation tree, anywhere in there. Now, they're not all active, obviously. We probably have maybe slightly over half the people have committed something in the last year and a half. There's no management of these people, really. They sort of self-organize into smaller groups. It's impossible to manage 1,400 people, obviously, especially when they're volunteers and they're not actually going to show up to a meeting or to read their email or whatever. But they self-organize around what they're interested in. So we have documentation teams for the various languages. There's a big French documentation team that just worry about the French translation of the documentation. There's a Japanese translation team, big group of core documenters, and those guys organize themselves. There's no big chief of this whole thing. I don't tell people what to do. I can't. They're not going to listen to me. Why would they listen to me? Right? They do what they're interested in. That's the only way volunteers work. Then there's the Peckle guys that build Peckle extensions. Generally, that's sort of where we test out new extensions and bring in certain ones. Like in PHP 5.1, we brought in the JSON extension, which started its life in Peckle. Next, maybe OAuth or some of the others that are big right now. So that's sort of how new features and new things eventually creep in. They live outside of the core tree and they get enough penetration there, enough people install them. We see Linux distros pulling them in their core version of PHP, they pull in some of these things. So we sort of look at what's happening out there and that happens. But there's no real management of that either. And it's a meritocracy. I mean, code speaks. if you write a patch or you write a piece of code to implement a feature, that says a lot. If someone wants to disagree with that way of doing things, if they can offer an alternate implementation, that's a really good argument. If all they do is whine about it, that's a really bad argument, and chances are that the implementation will win, even though it may not be the best way of doing things. There's code, it sort of works, that's what we go with, and that's always been the default. It doesn't always lead to consistency, but it does lead to getting the features and actually being able to do something, being able to connect to this type of database, even though it may not be the best way of doing it. At least it gets you there, and that's always been what PHP is about, is solving the problem. We'd rather have an ugly feature than not having the feature at all.
So now let's talk about one of the most popular features of PHP, arrays. PHP arrays are just plain awesome. They are inspired by Perl. They're called associative arrays. Perl had associative arrays, and what happens is part of what programmers have to do is you have to write algorithms, which is code and steps that you write through, and then the data. And so you solve problems with a combination of the logic that you use and the data that you create. Data structures are how you shape the data. And in a language like C, they had this thing called, structs, which are shaped data items. In C++, you have objects, which are shaped data items. Java has an object, which is a shaped data items, and a data item that has a shape. Those are all really complex ways to, with lots of syntax, to say, oh, this person has a first name and a last name and a phone number. And arrays, associative arrays, are key-value pairs, so you say, you know, this person has a first name and a last name and a phone number, and you're done. And so they're just a way for programmers, without learning a bunch of extra syntax, to create data structures where they hardly even know it. And so that's what Python dictionaries are very popular, one of the most popular features in Python. Java has things like hash maps. Windows has things called property bags. They're all a version of an associative array or a key value pair. PHP arrays are probably my absolute favorite. When I move from PHP to Python, I'm like, oh, dang it, I want these things to stay in order. So PHP arrays are just my favorite associated arrays. In PHP, they can either be like a list, a linear list indexed by numbers, or they can be key value pairs like first name Chuck, last name Severance, phone number blah. And they have two-dimensional arrays, but they're really just arrays within arrays of arrays, basically. We'll talk a little bit about that, but not too much. So you can make an array that is a linear list of things. So here we're going to make an array. So this is sort of a constructor that says, make me an array that has two things in it. And like most civilized languages, the first element is in sub-zero. So we use the sub operator or index operator or item operator. So we say, give me the sub 1, which is actually the second one. And so we print out there. So we make an array, and then we reference an item within that array. Unless we tell it otherwise, it just puts these things in at 0 and 1. The thing that people really love, though, is when you do key value. And so this is the syntax. Let's make an array. And I read this as maps to. So this key of name maps to the value of Chuck. So this is the key and the value. The key, of course, maps to web applications for everybody. And then you can use the index operator again to go look up the piece under the key course, and out comes web applications for everybody. I love this. I love it. I love it. Sorry. I'm like a fan of key value arrays because, like I said, it allows us to build data structures without thinking too much about it. Although later when I do object oriented, I'm like, see, you don't want to get so complex with your data structures using arrays, but that's okay. So there's a couple of ways to print these things out because we start building shapes. So I mean shapes of data and conventions. You're the one as a programmer, you decide to call it name or course or whatever, but after a while you make these shapes, and this is a super simple one. So you want a way to print this stuff out. Print R, and I'm going to put a pre-tag out so that the new lines don't get all messed up because that's HTML for a pre-tag.
so that I see that actually the way it prints out, so it doesn't do line wrapping on all this stuff. So print R goes through this array and prints the key and the value, key value, and goes through it. You'll notice that the order is the same both when I put it in and when I take it out. That's one thing that I like. The R in print R, I think, stands for recursive, which means you have an array within an array within an array. It'll kind of go through that, and they'll indent even further and further and further. This is very simple, but you can print out much more complex structures. And you do end up with very complex structures. Sometimes you have a linear array with integer keys inside of a key value array, especially when you start talking with APIs and JSON and stuff like that. So you want to print it R. Another thing that is even more verbose and detailed because it talks more about the type is a thing called var dump. Var dump is, I think of it as lower level. It's less pretty, but it's more explicit. And what this says is this $stuff is a 2-item array, and the first item is name maps to a 5-character string of the value of Chuck. Course map is a first key that maps to a 5-character string SI664. So it's just a little more verbose. And I tend to use var dump when I'm really digging through something because printr makes it prettier, but sometimes you lose some detail. The one thing I love about var dump is that you can actually print false. You can actually print false because var dump is printing both the type and the value, right? So here I have false is in thing. I print out 1. I use print R, and it's absolutely nothing. And this is like, I'm so mad because I look at this and I say the code didn't run. But it did. This code did run. So when you print false, it doesn't show up. Have I told you that before? Again, that's because I am really usually angry after like 20 minutes of wasted time because I keep printing stuff out and I can't see it. But then I realize I should have watched my own lecture and used var dump because var dump says it's a false and it's Boolean. There's a reason it does it this way, I'm sure, but it's not very convenient for debug printing. Now, you can construct an array a couple different ways. You can start with an empty array and append stuff to the end. So this is make me an array, and then this is go to the end and add 1, an item, and then it just adds these in integer positions, so 0 and 1, so it's a linear list. You can do the same thing with key values. You just put the index operator on the left-hand side of the assignment statement, make an array, stick Chuck under the key name, stick WA for E under the course, order, smiley face. Stays in order. Okay, looping. So this is looping through a key value array. And so it's this looping construct that has 2 iteration variables. For each, syntactically different. The array is the first parameter, and then as is a keyword. And then you can have 2 iteration variables, one for the key and one for the value. And so I read this as for each stuff as key maps to value. That's what you put right there. It's not a less than or a greater than or equal. It's a map to. That's like, I think of that as an arrow, right? And I think that's exactly what the design of the language was. So this loop is going to run, and K is going to go through the keys, V is going to go through the value, and then the next time through the loop, they're going to both simultaneously advance. And so it's I think this is really, really pretty syntax. I think that's really nice syntax, and I like it. I like being able to loop through arrays. If you have a linear array, you can get at the key and the value. In this case, the key is 0 and 1, because that's how this works. This is the 0 position, that's the 1 position. You can also, on a linear array, you got to be careful that it's a well-formed linear array, you can use a counted loop, right? So count is a function that tells you how many things there are. So in this case, that's going to be 2, because there's 2 things in there. So I'm going to have an iteration variable for I equals 0, I less than count. So that means it's going to be 0 and 1. Sub 2 wouldn't work because this is an array sub 0 and an array sub 1 there. So then I'm going to add 1. So this is a counted loop that's going to run twice. It's a little uglier syntax-wise. For this particular thing, I would have used the for each instead. But you can do counted loops. Sometimes you actually need a counted loop because you need the variable I for some reason or another. And so then you just kind of dereference stuff sub I, which is the 0 and the 1, and then the loop prints all the stuff out. So that's a counted loop that's going to iterate through an array. Just talk briefly about 2-dimensional arrays. They're not really 2-dimensional arrays. they are nested arrays. They are recursively nested arrays. So you can put an array within an array, right? And so this is outer array. So this is the outer array, and this outer array has three things: the first one, the second one, and the third one. And this paper maps to an array. See the comma? The comma is part of the outer array. So there are three things in the outer array. So you can think of this as product subpens. Product subpens is going into this outer array and grabbing this thing. And then submarker is within this array, grabbing submarker and looking up markers. So that pulls out markers. So it's not really two-dimensional arrays, it's array within arrays. And you won't build this structure often if you're going to get data from a database maybe, or you're going to get data off the web or something, read some JSON and parse it or something. You'll get this, and then you'll just have to figure out how to dig into it, how to go in and dig through this whole thing. And so that's arrays within arrays. That it's kind of like two-dimensional arrays. So up next, we're going to talk about how there is a set of functions that help us build arrays and search them and do various things. So now we're going to talk about array functions. PHP started out as a non-object-oriented programming language, so it tends to have a bunch of functions that are named in a way to group them together. So if we take a look at some of the array functions, we'll see that they sort of have array underscore, and that's just a way in the global namespace. You'll see that string functions have string underscore, and so that's a way to do it. And we do a lot of manipulation of arrays through functions where we pass the array in as a parameter, and that's because these are not object-oriented. We'll talk about OO later, but these arrays are kind of from PHP 1, 2, 3, 4. PHP 5 is where object-oriented came in, and so these are kind of antiques within PHP. So we have a lot of things. But at the same time, there's a lot of really powerful things because, like I said, programmers build data structures and then they like take this array and then merge it with this array, or this array, compute the differences between these things, etc. Find the position of this key inside of an array. So there's a lot of things because that becomes the way that you express your program and allows your programs to be relatively small because you have these these operations on arrays. So here's a couple of that we'll talk about. You can ask if a key exists in an array. This is kind of a cleaner way to do it, but the way everybody does it is this isSet function, array sub key. And for those of you who know other programming languages, this makes me quizzical how this actually works inside of PHP. Because if you say array sub key and a key doesn't exist, $array, sub quote x quote, and x is not there, this becomes a non-fatal error. So what we always ask is when you use one of those two things to see if the key is in there. And we tend to use this one all the time because it's more succinct, but that doesn't cause a non-fatal error. Neither of these cause a non-fatal error. If you just access a non-existent key, it does cause a non-fatal error. We already saw the count, which tells you how many things are in there. One of the things that's really cool about PHP is that you can have variables that are what's called mixed type. They might be a string or they might be an array of strings. And you can write a function that will take an array of strings or a string, but you have to know if it's an array or not. So this is a logical test. Is that an array or not? Sorting, awesome, because arrays maintain the order that you put them in. So there's a couple ways to sort, which we'll talk about. And then you can even sort of randomly shuffle them, make an array of playing cards, and then just shuffle them. And it randomly shuffles them. It gives you a different order. Okay, so let's ask a few questions. Just because of the fact that you can't try to dereference an array, $ZA sub x, in this case, will blow up because x isn't there, right? And so I got name and course in there, and so I have to somehow ask, does the key exist? Does the course key exist in the ZA array? True or false? And in a sane world, we would do that, but we do that way too often because we don't have like a get operation the way we do in Python. And actually, this gets different in PHP 7. And so you're probably using PHP 7, and there's a cleaner way to do this in PHP 7. But the compatible way of doing this with PHP 5 and earlier is to use the ternary operator. And so this is the one place that, even though the ternary operator is a little crazy, remember ternary operator, which is a question and the true part and the false part. And so this basically is an expression. You could put parentheses around it right there. This is going to ask is set, which is going to return us a true or a false. In this case, it's going to return true because name is in the array. And so it's going to print the true part. So it's going to say name is set. So that prints that out. Now if we do it again, this is going to ask is set z a adder, and that is going to be false. And so it's going to pick the false side, and so it's going to take and print out adders not set. And so again, this is the ternary operator question mark colon that basically is going to take the true or the false depending on the evaluation. So it turns out this we do all the time. And I apologize. You'll see this in my code for the rest of this class all the time. Someday we will use PHP 7. PHP 7 has a more elegant way of doing this with what's called the null coalescing operator. It really is an operator that sort of also suppresses that non-fatal error. And so the null coalescing operator is the double question mark. This is a PHP 7 only. So you probably are installing PHP for the first time, and so you'll have PHP 7, so you don't have to use this ternary operator. You can achieve the same thing by saying username get is an array we'll talk about in a second, but it is just an array. Give me what's in the key user, or nobody if it's empty. So it's really a, this comes across or that comes across, and this is kind of like a default. I like this. I wish it was in there all along. Smiley face. I like that. I wish it was in there all along. Okay. And so that's the null coalescing operator. So this is a lot prettier. We can make this array with two things. If it's greater than 7, we can say if it's there, put the not found in. If it's not there, put the not found in. In this case, the name is going to go. In this case, not found is going to go. And then, the equivalent is this is going to be true or false, and then the true part happens and the false part happens. This works in PHP 7 as well, and so this is why you'll see my sample code, at least for the next couple of years until we're at PHP 8 or 9. I don't like to write code that can't go back to PHP 5. PHP 6 never happened. PHP 6 is the release that didn't exist, so there was 5, and then 6, and no one liked 6, and so they got rid of it and made it 7. So the release right before 7 is PHP 5. Someday we'll have 8 and 9, and then everyone will be upgraded. I'm really conservative, so I still use this, but you can use this because you're starting on PHP 7. But when you go to work, you'll probably be in PHP 5, okay? So, or they'll tell you got to stay compatible. So I want you to know both of them, but I know that the future is bright, and I don't have to use the ternary operator ever again, which will make me very happy. We've already talked about count. Just tells you how many things are in an array. Is it true or false? Yes, it is an array. Very useful. Mostly useful if you're building functions and taking mixed parameters. And you'll see when you look at the PHP function specifications, they'll say that first parameter is mixed, which means it could be an array, it could be a string, could be something. And it's really easy to write code that accepts strings or arrays of strings, which is quite nice. So let's talk about sorting. So the funny thing is probably the worst sort that you have in all of PHP is the one named sort, because it doesn't sort key value arrays very well. It does sort numeric arrays well, so it redoes the arrays based on the values, not the keys, but it throws away the keys. So this resorted them, so it sorted the things into the right order, but then it wiped these things out. If you're sorting in a linear array, this is fine. But if you're sorting a key value array, it is not a very fine thing to do. And so you can do what's called a K-sort, which is respecting sort by the keys, course, name, topic. Or you can do a sort, which sorts by the values but keeps the keys in place. Probably this is, well, it depends what you're trying to do, but this probably is the A sort is probably what you want to do. Although when I'm printing stuff out, I tend to like doing a K sort so that I can see the keys. So if I'm looking, sometimes there's 40 things in here, so you want to find the things. So I tend to sort by keys just because I'm like, oh, is age in there or whatever it's looking for. And so K sort and A sort. I don't know why this is A sort. I would call this V sort because it's like keys and values. Why didn't they call it V sort? I don't know. Don't need to change that. I can complain about a lot of stuff, but I won't complain about that. A sort is awesome. Oh, that might be it. A stands for awesome. It's the awesome sort. There's the sort that messes up the keys, and then awesome sort that doesn't mess up the keys, and then K sort that sorts by keys. Maybe that's what's going on here. Who knows? Someone can tell me in the comments that that's what's going on. So another thing that we do in many programming languages is string processing. And so there is this capability in PHP called explode. What it takes as its first parameter is the split, the character to split on, the string to do the splitting, and then you get back an array. So it just goes chop, 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 chop. And so then I get back in temp, I get an array that is each word of that in an array. So you can say, oh, this is the 0, 1, 2, 3, 4, 5. So the fifth word, sub 5, is 7. Very nice. You can make this be a comma, you can make it be a colon, semicolon, whatever it is that you're trying to split on. And so that's a great way to parse data. So up next, we're going to connect how arrays work with the request response cycle. So now we're going to connect two of my favorite things about PHP. We're going to connect the request response cycle and PHP arrays. So let's take a look. Remember our happy little request response cycle that I love so much? And that as you're sitting out here, you click on a link, the browser sends a request with HTTP, Apache, our web server, retrieves it. It says, oh, this is some PHP code, so I'm going to start this thing up, start your code up. And if on the end of your URL there are these parameters like $x equals 2, actually these values and then ampersand y equals 1, these two values get parsed and put automatically into a global array that I've already mentioned called $_get. So this is a variable that is defined before the first line of your code executes. And so if you want to see what this value is, you can say $_get sub quote x quote. So you don't have to write any of this parsing code. PHP understands the request response cycle with these get parameters, parses the get parameters, and puts them into array $_get. And then you just write your code, and then of course you send back HTML, which goes back and parses in the DOM, and then you get to see your next page. Okay? So we look at data that's coming from the browser often in the form of what are called superglobal arrays. And so here we can take just a quick print. This is a PHP file. You can run it right here with X and Y. And so it'll come in. Remember that PHP files are HTML until we tell them otherwise. We're going to run a pre-tag just so we don't get new lines, because there's new lines here. If you don't have a pre-tag, it's going to wrap it all up so it'll be one long line. I sometimes don't put the pre-tag out because I can read it, but it's a lot easier to read if you do put a pre-tag out. So I'm going to print this $get. So this is the first line of code. $get came from these two parameters. So these two parameters are parsed and placed in the $get under X and Y. And that just saves you, because it turns out it's not as simple as it looks. You're going to be splitting and doing some other splitting and then convert these things because there's actually weird characters that can go in here, etc., etc., etc. You know, that's not your problem. That's PHP's problem. It parses all these things and puts them in an array. End of story. I'm going to print it out with print R, and we'll print it out again with var dump, just because var dump is a little more explicit. But basically, these things go into this array, and you just access that array, and those are the get parameters. Because this is an HTTP get, because I hit enter here, HTTP get. So it's the parameters after the question mark. So this question mark, the question mark here, and then key value, and then ampersand next key value, ampersand next key value, etc., etc., etc. So you can add these to the end of a URL and pass them right into the get array, and PHP does that. It's called a superglobal because it exists in the main code and in any function within all of PHP. So that sort of zooms us through the fun stuff that we can do with PHP arrays. And so we'll see you in the next lecture.
Hello, and welcome to another recording for Web Applications for Everybody. In this application, I'm going to talk to you about how to use ngrok to turn in your assignment for one of the auto-graded assignments. Now the idea is you're talking to the auto-grader, and it's going to talk to this website, and you've built your code, and so you built your code on your computer. Your computer is here, so it's on localhost something something something. You know, so you can say $guess equals 12, right? So there you go. So your guess is too low. But the problem is that you can't take this URL localhost, you can't take that URL, and you can't put it into here. Oops, I messed up. Gotta copy that again. Copy. Paste. So this server, web applications, is going to call localhost. The problem is that localhost doesn't work. Okay, localhost on your computer is in effect firewalled from the rest of the world. So this is not going to work. This is going to blow up, blah 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 blah, and so it's blowing up terribly. Okay, and so the problem is that you need to have a real address for this code right here, and that's where ngrok comes in. So we're going to go to ngrok, ngrok.com. Now ngrok is free. And basically the idea is that this code's running on your laptop, and your laptop is normally blocked from the world coming in. Your laptop doesn't have a real address, a real domain address, and ngrok makes it temporarily so that your code can be viewed. It doesn't move it, it just makes it so it can be viewed. Okay, and so we're going to install this software on your laptop so that my server can run and talk to yours just temporarily, and then you'll shut that off. So let's go ahead and download this. I'm going to download the Windows version of ngrok. I'm going to have to go ahead and open that. So now I've got ngrok, and I'm going to put this on my desktop so I can use it from the command line. And then close this window, and then close this window. Okay, so I'm going to use this in the command line, so I'm going to type command. You can actually put this in any folder that you want. I'm just putting it in my desktop. So here I am in my desktop, and if I do a dir, you'll see that ngrok is here. So if I say ngrok http 80, and 80 is the port that you're currently running on. 80 is the default port for a web server. So ngrok will start up, and then ngrok will assign us a temporary address. And so I'm going to grab this temporary address and then copy it, and then I'm going to go over here and I'm going to go to that address. Okay. And so this is the same as what's on my computer. So if I take this URL, PHP solutions, right here, and I copy that and I add it to the end of ngrok, see, it is going to go with a real address now. So what's happened is ngrok has temporarily given you an address, and so now I can take this URL and copy this and go into my autograder and put it in, and now it will run it. And you can see while it's running it that, I made that a little too small. You can see while it's running it, there we go. Well, you can see while it's running it, these request response cycles that are going back and forth. Okay? And so that's one of the cool things about ngrok. I can rerun that, and you'll see these things go brrrr as my server talks to your application. See? It's doing stuff. Now, I mean, it doesn't have certain things, it's got the guess wrong, etc., etc. So this version isn't the right thing. But the idea is that you can take something on your local host and then you can export it and get a temporary domain name for the code running on your laptop, and then you can hand that in. And then once you're done with that, once you're all completed, you just come in here and you deconnect yourself back off the internet. So now nothing can talk to you. And so you had this temporary opening for ngrok, and now you just shut it down. Now you'll note, I hit up arrow here and run it again, that every time you connect with ngrok, it will give you a different address. So this one I had 2A89 something, now it's 80. So, and I'll type Control-C because I don't really want to do it. It gives you a different address every time. So you'll get used to this. It will be not too tricky after a while. It'll make a lot more sense to you, okay? Hope this has helped. Cheers. Hello and welcome to Web Applications for Everybody. Today we're going to learn a little bit about ngrok. Ngrok is a way that we can get our assignments auto-graded, and perhaps you are in the lesson where we're doing this grading of the guessing game, right? We're grading the guessing game. And we have to put some code here, and the problem here is that we have to have this code running on our laptop because this server is on the real internet and it can't talk to your laptop. And so what I've got is I've got some code running here, and it's in my applications mamp htdocs ASSN subguess subbroken.php. And so I'm running mamp, so that code right there is the same as what I'm seeing here. And so if I type guess, I can say guess equals 42. Well, or I get missing guess parameter, and our guess equals 42. Yay, I'm right. Okay, so the problem is if I just take this URL and I put it in the guessing game, if I put it in the autograder, this autograder is running out there in the internet somewhere, and it can't connect to localhost because your localhost is not also on the internet. So we have to find a way. So this is going to blow up really badly, and this shows you something about the test. When things blow up, sort of look from the bottom up and look for toggle. And this, it looks icky. You have to read it. This looks like it might be like a bug, but it's not. It is a, it can't connect to port 808088, connection refused, this URL. So don't just assume that the autograder is blown up. Sometimes the autograder gets an error and it shows you what it is, and it tried to retrieve your file and it couldn't. So something went wrong. Okay, so that's the problem. We've got to get to the point where we can't use this localhost URL. But as I've said, there is this wonderful piece of software called ngrok. And what ngrok does basically is makes it so that anyone on the real internet can talk to your laptop. So over here is where the server is. This is where your mamp is. This is you and your, right? So you're running mamp over here. Right, mamp over there, and this is the autograder right here. The autograder cannot talk to your localhost. It can't do that. That doesn't work. But you can run a piece of software that effectively exports your localhost to this place called ngrok.com, and then the autograder can talk to that. And I'm going to show you how to do that. Now, to get this to work, you've got to download some software. So let's do that. Let's go to download. Now it's different from Mac and different from Windows, so I'm going to download it. And it's a pretty small piece of code, and I'm going to put this in. It's going to be in my downloads folder. Where's the downloads folder? There's the downloads folder, and it's a zip file. There might be different install processes for Windows, but you'll get to the point where you have this ngrok running. Okay, so we have this running on localhost, and we've downloaded ngrok. So what I've got to do is I've got to start a terminal window, or command prompt if you're on Windows, and I have to get myself in that terminal window. I have got to go into that downloads folder. And in Macintosh, it's user downloads, and I do an ls-l, and I can see that this ngrok is here. And this was the zip file, and I can start it by saying /ngrok. It's important that I don't have to run ngrok in the same as where my code's at, because ngrok is basically forwarding port 808088 48s to the web. So I'm just going to say /ngrok HTTP. We're going to fake the HTTP protocol and localhost the 8888 port on this localhost. And if all goes well, ngrok is going to wake up, and then it's going to tell you an address. Now the key to this is that this address is only going to work while this ngrok program is running. A program is running now and forwarding all these connections. So the thing to do, and you'll get a different one of these every time. And so if I go here and I go to ngrok.io, you will see exactly what happens if you go to localhost 8088. See? All that stuff. And my assignments are sitting here in assignments. I can go to assignments, and I can go into the guest folder, and now I'm here. Except this URL is a real URL. This is a URL that can run anywhere on the internet. This URL can only run on a browser that's running on my computer sitting at my local host. So now I can use this guest.php and I can turn this into the autograder. So I got to go back and I got to launch the autograder and give it this URL. So now I'm going to say run this. This is a real URL anywhere on the internet, including where this autograder is running from, because this autograder is really running somewhere on the internet. So what happens is when I hit evaluate, we'll go back to, when I hit evaluate, this is going to connect to ngrok, and ngrok is going to send data to your computer, and the request response cycle is going to come back. Now, interestingly, if you watch, you can see this happen here. And so you've seen I've already done some GET requests, and there's actually a little monitor guy that I can put up over here, 127.0. That's another word for localhost. And this is actually allows me to inspect the data that's going back and forth here. So my autograder talks to ngrok, ngrok talks to your computer in a reverse way, and you're watching this data that's going back and forth, and that's what's going on here and here. Okay, so both of these are talking. So I'll just leave this, let's make this a little more narrow now so you can kind of, let's put this maybe way over here so you can see it. Oops, made it too small. No, it's not looking good. Okay. Okay, we'll watch it over here. So now I am back where I'm going to do my evaluation. You can watch action happening over here. Now, one of the things about this assignment, depending on who you are, it gives you a different number. And so that's why you've got to change this code. So I'm supposed to make 37 be my correct answer to get full credit. So I'm going to evaluate it. And you can see it's talking. See, it went talking. Didn't find Chuck Severance in the title tag. Guess is too high. Now, the key is you're like, oh, what's wrong? Look at the toggle. Okay, so it's like, did not find Chuck Severance in the title tag. Well, oh, that's because it's Charles Severance. Okay. Looking for your guess is too high. It says your guess is too low. You see, it's always trying to tell you as much as it can. I'm not trying to make this tricky. Okay? And so the problem here is this code that I've got, that's guess code, has got 42 as the right answer. So I can fix my program by making 37 be the right answer. 37, save. Now I can rerun the test and I should pass that stuff. And these errors went away, but Chuck Severance is still not in the title tag, so I changed that. Chuck Severance. And I rerun the test. And I got passed. Okay, so there we go. Everything is good. I don't know what that internal error is. That's probably because I'm an instructor. Yeah, but so there you go. So that's the basic idea of how you run ngrok. And the way you finish this, when you're all done with this, is you just hit Control-C. So remember this, AFA 30 something. Okay, so I'm going to hit Control-C. And now this URL ceases to work. Right, this one will blow up because I'm not there on the other side, so it doesn't find it. If I run ngrok again, I start the tunnel back up, but you will notice I will get a different number, 5EB something. So this address no longer works, but this one does. So you can start and stop ngrok as many times as you want, but you sort of have to realize that every time you start and stop it, you're going to get a new address. Now you can actually pay money to them to get more permanent addresses, etc., etc. But as long as you know how to switch back and forth and get the right address, it should not be difficult whatsoever. Okay? And so there we go. I hope this has helped you understand how to use ngrok so that you can do the send your assignments from your laptop's web server all the way to the autograder on the internet.
So now we're going to talk about writing functions and how we can break functionality into multiple files. So we need to learn about functions partly because we're going to write them, but mostly because we're going to use them. And PHP is a less object-oriented programming language than some are, and so we use functions all the time. But we write our own functions as well, and we're going to cover both of those things. A lot of times, initial programming tells you you're supposed to write functions for everything. I'm not such a fan of writing functions until you feel the need. A function is a great way to see this work that you're going to do over and over and maybe change a little tiny thing. That's when it's time to do a function. When you're saying, I'm doing this same thing over and over and over. Don't repeat yourself. You make it work once, sometimes with parameters, and then do that over and over again. Now, I find that I actually have an offline documentation viewer for PHP because I don't memorize all the functions, and there are so many functions. So for example, I never know what the replace function is for PHP. I know that I got a string and I got to replace something in it. So I'm like, what is that replace function again? So I type that into Google over and over and over. Google is my best friend when I'm coding in PHP. Now, once I've been in PHP for a day or two, then I kind of remember the main things. But the documentation that they have online for PHP is outstanding and very good at getting you what you need. The other thing that's really cool is if you scroll down on these pages, you'll often find sample code that the users have provided. And so the PHP documentation is great. But you can also download, in case you're on an airplane or don't have a good network connection, you can download a PHP documentation viewer. And so that's quite useful. So here's a couple of samples of functions that we're going to use. These are string functions. Strings are not object-oriented in PHP, and so we sort of follow the pattern of passing a function in and getting a function back. And so this is the stir rev. And PHP is pretty good at prefixing all these with str as a way to tell you that they're about strings. So this is reversing. Why you need reversing, I don't really use it. But there you go. It's very exciting because it reverses the thing. Stir repeat. Why we want to do this, I don't know, but we're passing in a string and saying repeat it twice. I put a space here, so it's hip. Translating something to uppercase, that I do all the time. Hooray. And stirlen, which is how long the string is. So that's just an example of some of the string functions that you might use. To define your own function, we use the keyword function, followed by the name of the function, followed by optional parameters, followed by a curly brace. And of course, there can be further indenting and further curly braces that are going on here. And then this is the body of the function. And like in all function situations, this code is not executing, it's being remembered and effectively expanding the language with a new keyword. So it copies all this into greet somewhere, and that's kind of like a variable name, as it were. And then you can call it. So this function is defined once and then invoked twice. So it runs it, goes up and runs it, comes back down, runs it again, so it runs twice. Run. So there's no output from this because that's the definition of it. You can choose function names. They don't start with a $sign. You can start it with the underscore. Again, we tend to reserve underscore for sort of library-like things. We tend to avoid underscores in our main code. You can start with a letter underscore, letters and numbers, so it's pretty much the same. Avoid built-in function names. The case does matter, but I think it's a mistake to treat the function called, zap and zap differently. So don't take advantage of that, but it does matter. Why, I don't know. Return values, much like C-based languages, use the return keyword. And so it basically says if this function gets called in the evaluation of an expression, so in this case it's concatenating whatever the function greeting returns with the string Glenn. And so it comes in, it returns it, and so this expression here becomes the residual value that is in that expression. So it just means that once greeting runs, hello is here, and then this concatenation runs, and then that goes hello Glenn. And then it runs again, greeting returns, and it's hello Sally. So the concatenation thing is hello Sally. You can also pass parameters in. Parameters have the $sign. The function name doesn't have a $sign, but the parameters do. And like all parameters and functions, the normal thing is that they are sort of temporary copy of the incoming, and that $lang only exists while the function is running. And so in this case, we're going to do this concatenation of howdy ES to Glenn. So howdy starts running. So ES is somewhere out here, and lang points to ES. Then this code starts. And so now that
instance, that execution of the function, we're going to see Spanish return hola, then it's going to be done, and then the next time, right, it runs it again, and in this case, FR is out here, and Lang points to FR, and it runs again. That's false, but this is true, so it returns bonjour, and so we get the residual value here, goes back here, and we concatenate that, bonjour Sally. Okay, so this variable is effectively an alias. Another really elegant bit of PHP that I really like is the concept of optional arguments. And if you put an assignment statement here in the function definition, this becomes the default value. So in this case, if you don't specify it, then it assumes ES as the value for Lang. If you specify it, then it points to FR and runs again. So that's a default. I think it's as beautiful and elegant a syntax for defining the default of an argument as any programming language. This is emphasizing the fact that sort of this variable alias only lives inside the function, and it's an alias of the original value. So we have val equals 10, and so there's $val out here in the outside world, and it has a 10 in it. Okay, and then we pass val into the function. So the interesting thing is the way this really sort of works is it kind of makes a copy of the 10 over here, and then it points alias to it, meaning alias is not pointing at that 10, it's pointing at that copy. So now I can actually change it. So I say alias equals alias times 2, so that puts a 20 in, and that puts a 20 in here. So there's a 20 in this little place, but there's no 20 here. This is separate, so it kind of keeps it separate. It really isolates, firewalls, stovepipes. It keeps this function from messing with things outside of itself, including its arguments, its parameters. So this is called copy. So the parameters are copied rather than actually referenced. Okay, so in this case, if we have val equals 10, we pass it in, and we see this dval, which is the return variable. So dval is 20, but the original variable came back out of that, which is unchanged. Call by value. Now, lots of programming languages that you use are call by value, although some programming languages kind of like, if it's an array, it's called by reference, and if it's a scalar, it's called by value. But PHP gives us a call by reference capability to say that we don't want this parameter to be an alias. We want it to point to the original. And we do that by simply adding a little ampersand. So the function, in effect, declares its intent to be able to modify that. There's nothing we change in the calling sequence. So what happens here is there's a $val out here, and then we stick a 10 in it, and then we call it triple, and then this says instead of making a copy, real thing is a second alias to that variable. So when I am going to multiply it by 3, 10 times 3 is 30, and I put 30 in the real thing, I'm really changing this variable. This variable is outside the scope of this function. So we sort of have a wall around the function. Oops, but there's a little tiny break in the wall, a little tiny doorway in the wall, and we're going out and changing this variable. We can't like sneak into other things, but we can touch the actual contents of the value. So that's called call by reference, because this actually refers to the original variable. Rather than the previous example, it's call by value, which means we're getting a copy and we're getting the value in the variable. We're not getting a reference to the variable itself. And so when we come back, we're printing out the 30 because it's been tripled. Call by reference. That's a kind of a more advanced concept. A lot of languages don't even have that. The ampersand came from C. That's how C used to do it. The C syntax for call by reference is a little bit different because you don't have variables that start with $. And actually how you use it inside the functional delivery. But this is not a C class, it's a PHP class. Now the reason this is important is as you read documentation, you can read through the documentation and you find if you see this ampersand, you're like, oh, that's interesting. That means this ampersand means it's going to change the array. And the interesting thing is if you pass an array in to a function, the default is to call by value. And actually that's different than a lot of languages, meaning it's a copy. But if you say ampersand, then it's an actually call by reference, and you can decide that this function inside this sort function is going to do something to the array. In some languages, you actually return the new array in this, you're going to sort it right there. And so it just is a reference. And so you've got to be able to read when you see that ampersand is like beep, 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 beep. They're going to change that. When you pass an array in, it's going to take and change it. So just you need to know what that ampersand is just so you can read the documentation. So up next, we're going to talk about variable scope. We've been talked about things that can be inside the function and then outside the function. And that's what we're going to talk about next. So now we're going to talk about variable scope. And what is variable scope? Well, we have code that's in a function, right? Variables inside the function. And this basically, whatever we do is not supposed to affect the outside world. And we talked about call by value, where you pass a copy in. And then we have call by reference, which is like there's this little tiny doorway to one thing out here that you can mess with through the little doorway. So that's what scope is. Scope is we're going to hide stuff or we're going to let this like leak out, right? But in general, what it really means is the things inside of a function do not leak out. There's no mixing. You can choose the variable names the same, and there's no mixing, right? And so in this case, we have this function. The normal case is it's fully isolated, right? We're not even passing a parameter in here. So this val is not really the same as this val. There is a val out here, and inside here, there's also a val. These are not the same thing. They're not the same thing. This one is living inside it. It's namespaced. It's the val within the function trizap is the way to think about this. And this is the val that is in the global context. It's the global, this is a big script, the outer val, and then the inner val. So we make a wall, big wall. Nobody sneaks through the wall. And of course, oh yeah, super globals, right? $get sneaks through the wall. If it's the $get or $post or $session, which we will learn about later, they're called super globals. But let's ignore that for the moment. And of course, once I draw you a picture of a wall that cannot be penetrated, now I say, oh, here's how you get out. So how to escape the wall. So the way you escape the wall is using global. Global says, open a door and go find me outside, making, if necessary, that variable name val. So out here we got this val 10. We stick 10 in. We say global. So now val is really just an alias to that val. The name's got to be the same because it's matching based on the name. Go find me the variable name val outside of me, right? Go to the global one. And now if I set it to 100, it's 100. Come back, print out 100 because it pulls this out. Okay? Really simple. Break the little wall. The wall is really solid except for this one doorway that we put in, and poof, we sneak out. Now, be careful. Last thing you want to do is a lot of global variables, especially with funky names, especially a variable named val or a $I variable, because you might be in a loop on the outside and I might be going up and you global I and you can blow the loop up. You can mess it up. You can mess up code that you're supposed to be serving as a function, and yet you mess it up because you're messing with the variables that the outer code is using. So this is supposed to be very rarely done, right? And so if I create a global variable, that I tend to avoid it at all costs. You know, if you can pass it in by a parameter, passing it back by return value, these are like the two happiest things, and they make every programmer happy. If you can make a function that takes in copy by value parameters and passes a return value, that's like a pure function that has no side effects. You can see, read about. So if you have a no side effects function, that's like ideal. That everything inside the function, the contract with the outside world is in goes the parameters, but you can't change them, and out go the return. Nice. Passing a variable by reference, well, that's okay. But, you know, if you can avoid that, this is the best. These two things are ideal. Passing a reference is okay. In PHP, it's okay, more okay than other languages. And so global variables are like your last resort. Like, I got to have a global variable. And then what I suggest, and what most people do, is use long names, because you don't want to inadvertently collide with somebody that just happens to be using your code. Now, maybe you're communicating and you're saying, hey, I'll set this global variable when my function's all done, and you can grab it. And so these are example variables that I've created for the code that does your autograders. Last OAuth body base string. Sometimes I make them really long with camel case. Sometimes I like them really long with uppercase snake case.
Camel case is the first word is capitalized. Snake case is this, where it all stays lowercase. In this case, this is uppercase snake case. But I use these long names with nice, unique prefixes because hopefully it also emphasizes to me that I'm not supposed to use them, and it reduces the chance of collision because there is only one namespace for global variables. Another thing interesting about PHP is that PHP evolves over time. And I mentioned, PHP 1, 2, 3, 4, 5, 7, remember 6 doesn't exist. There's a lot that's changed over the years. Like object-oriented came in 5 and null coalescing came in 7. And so there are things that only exist in later versions of PHP. If you want to write code that runs on these earlier versions, you have to come up with something that deals with that. If function exists, array combine, this returns a true false. You pass a string with the name of the function and you can ask. And it allows your code to evolve and cope with different environments. And sometimes you don't have everything installed of PHP, and so you can check to see if your particular instance of PHP has a function that is an optional thing. So there's core stuff and optional things. If you've installed one of our MAMP or XAMPP distributions, you'll find that you get a lot of the optional stuff. And so you don't worry so much about this, although you'll move into production and be like, oh, where did all these things go? And they're like, well, we didn't put those things in. So you have to find ways to work around. So function exists is a way for you to write code that's smart enough to declare. Now, sometimes what you'd say is like if array combine doesn't exist in the version, you can actually go to Stack Overflow and say, could you give me a pure PHP implementation of array combine? So the thing you'll do is you'll check to see if array combine doesn't exist in your PHP. And if it does, you'll actually put function that says in this not exist, right? You'd actually define the function here. So that's a way. You can't define the function if it's already there, and that would cause an error. So you just say, if this function is not already here, then add this function, which is a way for you to be backwards compatible or sometimes forwards compatible. Sometimes they take things out, and then you can say, oh, wow, it doesn't exist, so I'm going to write this, or I'm going to set a variable so I do it differently, etc. And one of the things that they're very good and very consistent about in the PHP documentation is telling you which versions this PHP works in. So this array keys exists was clearly introduced in PHP 4.0.7. So it's there, and then PHP 5 and PHP 7. Remember, 6 is the magical release that doesn't exist for PHP. And so you want to use this, you can check to see if it doesn't exist, and if not, you could write your own little simple version of it. And you can probably say, Stack Overflow, array, give me a pure PHP version of array key exists for earlier than PHP 4. Now, PHP 4 is pretty darn old, so you're probably not going to run into PHP 4. But you will run into, for some time, even though PHP 7's been out for a while and it's awesome, you will still run into PHP 5 systems for a very, very long time. Now, one of the things that I mentioned is that PHP is like super configurable and has lots of capabilities that can be optionally plugged in. And sometimes you actually have to figure out what is in your PHP installation. Call the system administrator, say, hey, what's going on? But it turns out PHP has a really cool built-in way to dump this stuff for you. So you write one file. I often call this file info.php, and you put the exact 3 lines in it. And this is a function that's built into PHP that dumps the configuration of a particular. So you could run this on your laptop, you could run this on your server, you could run it somewhere else, and you can figure out what version it is, how it's configured, where it stores its log files, etc., etc., etc. And we will be looking at this. If you're using MAMP or XAMPP, there's usually a button called PHP Info that just shows you this stuff, which is quite nice because it's important to figure out what's in there because there's lots of things that are plugged in. This is why I recommend XAMPP and MAMP because they put a ton of stuff into them so you can, you don't have to go oh, I'm missing something. So that's nice because they choose all that stuff. And so this is what the output of that looks like, and it's page upon page of configuration dump of where this is at, what the configuration setting is, what's been compiled into PHP, because it's so darn flexible. So next we're going to talk about how you take an application, the web pages, and move them into multiple files for common elements that occur on many pages. So now we're going to talk about modularity in a different way. So we've been talking about functions, which is a way for you to rewrite code and use it over and over again. Now we're going to talk about modularity from a perspective of files. Everything we talked about up to now is like one PHP file. But you can have functionality that might be across multiple files that you want to include over and over. And so there is a capability, include and require. Include looks for a file, and if it's there, it pulls it in, and if it's not, it's non-fatal. Require looks for a file, pulls it in, and if it's not there, it is fatal. I tend to use require almost always. And so there are things that you're going to require like that actually are navigation stuff, but then there's kind of library code where you might be actually in multiple files. You want to require some functions that are not actually markup, and you want to do that over and over again. There's this thing called require once, which is really cool because you can be requiring a file that requires a file that requires this file that requires this utility code, and then require a different file and requires the same utility code. And as long as it's the same thing, it says, you know what, I've already got that. I don't have to do it. Otherwise, you'd have to put all this if code in, and we were doing that. So require once is something PHP gives to you that says, no matter how many things we go and how many times we ask for this file, once it's been required, we're only going to do it once. Don't require it again, which is really super nice. Okay, so if we take a look at one of the common uses of require, the common uses of require is to have sort of repeating elements on page after page. So here I have a website, and this menu shows up both places. It shows up both on the main page and on the install.php page. And I want this menu, and I get tired because this is the index.php file. This is the install.php. But I need the same darn menu on both of them, right? So how do we do that? So what we do is we basically use this require to do this over and over. So this is the index.php code, and it starts in PHP, and it says, okay, let's require this top bit, and then require nav, and the top is the non-printing stuff like the title and the head and all that stuff, and then nav is this little navigation bar. And so there are two files, top.php and nav.php, and then I have the body of it, which is right from here to here, and then I include a footer. In this case, the footer, I have this automatic Google translation thing that I put in my little web page, which translates this page into various, it uses Google's automated translation, translates that page into a various languages, so we can sort of see how that works. And so this is something I want to do on every page, and so I have foot.php. So there are three files, top.php, nav.php, and foot.php, that then I can put different content. So this is the unique content, and so if we take a look at a different page, this page here, which is install.php, has the same top part of the two requires and the same bottom part, so that this stuff is the same, and then this stuff is the same. And then in the body part, I have this div, which is from here to there. This happens to be an iframe that's pulling in a different file, yada yada, so that comes in. So it allows you to have these consistent elements over and over again that put markup and repeat in. So that's a way to break things into more than one file and to not repeat yourself. Don't repeat yourself. That's what you want. Modularity is really just the idea of capturing something once and reusing it over and over. So in this series of lectures, we talked about modularity in general. We talked about using functions that exist, like the string functions or the array functions, making new functions, how to pass by value and pass by reference, and that's kind of a unique thing to PHP, and how we include and require files, and then the idea of writing code that works on various versions, given that PHP unabashedly makes changes that are not present in all versions, either adding or removing functionality as the PHP version kind of increases. So I hope that's been useful to you, and we'll see you in the next lecture. So now we're going to talk about forms. If you recall, our previous lecture was functions, and that's because forms follow functions in my syllabus. Get it? Forms follow functions. So at the end, we talked the arrays. We talked about the superglobal variables, and part of the goal is you're going to process HTML requests, and PHP is designed for that purpose. It's not a general purpose programming language. It's a programming language for web applications. And we use these arrays, $_get, $post, etc. So that's how these things work. So just to review, if we put parameters on the end of a URL, $x = 2, ampersand y = 4. The question mark is for the first one and ampersand is for the following one. These are parsed and placed into an array inside your application called get. And so you don't have to do anything. PHP magically does this before your program starts up, right? So you click a button or you type that URL into your browser, it gets sent using HTTP. Apache and PHP parse that and set this global variable and then start your program up, the very first line of code. So this variable exists and it's called a super global inside of PHP, and then it's in your main code and any functions that you have within your main code. And so that's the basic idea of taking data from the outside world, key value data from the outside world, using the HTTP protocol and getting it into you. Now, there is a more convenient way to enter data in, and that's what we're talking about now, and that is using forms. And I'll be honest, I'll just sort of step back in time a little bit. This would have to be like mid-1994. And there was a time in 93 that there was this thing called Gopher, and Gopher was sort of more impressive to most of us than the web was. And the web was like, eh. And so I'm like, the web, that's just another version of Gopher it's not any different. And the first time that I knew that the web was cooler than Gopher was when I saw my first form. And I'm like, oh, wait a second. Now we can actually type data and hit the submit button. And the first form I saw was from FedEx.com. And it was pretty much as simple as this. And it just said, enter the tracking number. You clicked a button, then it went into the tracking database and showed the tracking information. Early days of the web, really simple user interface, but I'm like, mind blown. And of course, you don't care. The web's here. Forms are a thing we do. We log in with them. We search with them. We do all kinds of things with them. And so this is the basic mechanism of creating a screen that's not just a screen for you to read, but a screen for you to put things in and then submit that data. And this is sort of the simplest version of that thing we've got. So just HTML, it's not PHP yet. So we have a paragraph tag and then we have a form tag that says these things are grouped together. And so these are submitted together as a group. You have a series of input tags, ... And you have some text, like input guess is just some text. And they say, oh, this draw a little fill in the blank, and you can set how long it is, et cetera, put a previous version in there if you want. And you are giving a name, which is the name that is going to be used to submit this to the server. And then you have a button that basically takes this entire form, and if there are more things in here, and you hit the submit button, and it gathers up all the data from all these things, and then sends it to the server using a GET request. In this case, we'll show how a POST request works in a second. And so, we type all this stuff in. We have the form. We type in the 12, then we hit the submit button, and then that paste sends in that key value pair, which it pulls from this name guess and this number 12. And so then that sends that in. And of course, when this code runs, $_get sub quote guess quote is where that data ends up. And so the user doesn't have to type input on that form. Okay, and so that's the idea, is you're constructing with the form a set of data that you would like to be submitted along with the URL. And so if we write a little bit of code here, we would basically have a paragraph tag and then a pre-tag, and then we print out the $get, right? And so the first time this runs, $get will be empty. It's there, but it'll have nothing in it. And then when you actually send it the second time, when you type your 12 and then submit, it'll run it. And then the second time, $get will have a 12 in it. So the first time through, it doesn't have any data, meaning there's nothing on here. And then you hit the 12 and hit submit. And the second time through, you're going to see data. So inside of your PHP code, this is in the server now, inside your PHP code, you know whether or not there was a parameter there, whether or not that's got some input data. So next we'll talk a little bit more about how we can use other kinds of things that we do with forms and different ways of submitting that data to the server. So we just talked about how the GET request sends data in. Now we're going to talk about the POST request. And we'll draw our forms a little differently, but ultimately it's a different form of the HTTP request. The data comes in via POST. It doesn't come in on the URL, and we'll talk all about that. So now we're going to show how we get POST data in. So the simplest thing is you tell the form tag, please, when I hit the submit button, send this data into POST via POST. And we'll talk about what that means kind of in a low-level technical bit. and it just comes in the post array instead of the get array. So in this case, the get is empty. There are no parameters. That's the nice thing about post, is there's no parameters. Your URLs don't look ugly. The data comes in, and it magically comes in this post array, not the get array. So that's how we do it. It's important to know when to use get and know when to use post. When you do get, the parameters are posted on the URL, and the users see them. The nice thing is if you want them to bookmark those parameters, they can, because the thing that gets bookmarked when you drag a URL on your browser is the whole URL, including the parameters. The post, you don't see the parameters, and so that sometimes that's exactly what you want, but they're actually sent, they're just not sent on the URL. So if we were to look at the request response cycle, this is HTTP, right? We're looking at where the browser's talking to the server. So in the browser, remember if we went to port 80 and we sent this get command, this is sort of an abbreviated version of it. So when you're doing a get sending data, it says get form1.php and then send this get parameter. And then there's some things, and then you put the blank line, and then it sends it. If you're sending a post request, it's a different HTTP verb. These things are called verbs. There's a get verb, there's a post verb, there's a put, there's a delete, and there's a head, and there's other ones. So the post verb says we're going to send data differently, and we don't put the parameters here. We still are sending a key of guess with 42, and there's some data, and we say this is a particular kind of data. It says this is URL encoding the data, and then it has a blank line, and then it actually sends it down here. And this is why on a post you don't see it. It's part of the connection. This is a connection to the server. Send a blank line, send the data, and then that gets copied into the $_post array. Okay, so that's the $post array. So again, what we just were watching is what's coming across here. It's doing a post. Apache sees the post, it pulls the data out and sticks it into the $post array for us, and then our code, the first line of our code, starts up. Now, you can choose whether or not to do get or post, and as a developer, you're responsible for choosing the right thing. So first off, post is to be used when you're creating or modifying data. Get is to be used if you're searching. So for example, if you were like selling something online and you had a catalog and you typed in a part number and you hit search, it would be in your best interest to use get. And that's because if they bookmark the part, you'd actually have the part number right there in the URL. If, on the other hand, you're taking money out of a bank and you're saying, I'd like to take $100 out, and you hit the button, the last thing you want is that $100, withdraw $100 to be right on the URL, because then if they bookmark that, every time they hit it, they're going to withdraw $100. So that's why we use post when data is being changed. Also, web spiders will follow get URLs, but not generally post URLs. And so web spiders know that if you type stuff into a form that says it's going to post and you hit the submit, something might happen. So the last thing you would like to do is you like to have a blog and you have a delete button, and that's a get request. And then the web search engine goes through and tries to read all your blog posts and ends up deleting them by mistake. The nerd word that we use for this is that get URLs are idempotent, meaning that you're supposed to, you hit the same URL, you should get the same thing back. The example of in a catalog, a part number equals, you should get the same part number. Now, maybe there's less in inventory. It doesn't have to be identical page. It just means the same thing, right? So part number is, this is our skateboard, and there's 4 in stock, and then you hit refresh, it should be the same skateboard, but there might be 40 in stock, right? So that's what it means by the same thing. It's not identical HTML, it's the same thing. Another reason why you might want to use post is there is a length limit that's unknown on get parameters. Different browser, depending on your browser, depending on your web server. It's not exactly a number, it's not exactly known, and it's not exactly the same, but there is a limit, and so you just don't want to run into it. And so we tend to like the URLs themselves to not get very long. If you're going to send a paragraph text, it would be really bad to send that on a get request, right? But a few parameters, you don't have to worry like if you have X and Y and something else and part number or whatever, but you just don't want it too big. So up next, we're going to talk a little bit about how we can create different input pipes in the form. So now let's just briefly talk about some input types. I'll give you another video that sort of goes through this in a view source and plays with it in a browser. And so this is just kind of an outline of the kind of types you're going to look at. And often there's lots and lots of good online documentation, like how to do a text area give me a sample select. And so I tend to just go to the web and say, oh, how does the password field? So this is more of an outline than sort of instruction on how to do this. The web itself is the outline. So here is a couple of fields, right? So text field is the basic field, right? We have a box and we can type stuff in. A password field is effectively exactly the same as a text field. It sends the data in plain text between the browser and the server. That is plain text. It shows this asterisk so someone can't shoulder surf. They, of course, can watch you type, but they can't see your password on the screen. It just hides it visually. Nothing else is hidden. The other thing we're kind of seeing here is how each form field has a different name. And these are the names when we're going to package this data up and send it to the server. Account equals, PW equals, and the nick equals. So the name is what we're going to show in the $get array or the $post array, and so that's the key value. You'll also see an ID tag on these things. An ID tag, this is a CSS/HTML thing. So in this case, I am connecting this input tag with this label, mostly to improve accessibility. But that is an HTML thing, so that's not, here's the browser, and then here's the server. The name affects the browser to server connection, but the ID is just all here in the browser. This ID and the 4, that's all here in the browser. Size is in the browser. That's all just size is telling how long to make this little box, right? And so that's all browser stuff. That's HTML and CSS stuff. But the name equals is part of the request response cycle and how that data is passed in, represented, parsed, and then presented to you inside of your PHP code. The name is the key thing. Some people use the ID and the name to be the exact same thing, which is perfectly okay, but they have two very different and distinct functions. A radio button. This is something that people like. A radio button is a button that if you push one, the other one turns off. And you can have many of these, as many as you want, and as soon as you push one, you push this one turns off. And you don't have to have them right next to each other, although sane usability basically says you should. And the way you do this is you say type equals radio, and then you give them the same name and a value. So what this now says is when is going to be equal to AM or PM, depending on which of these two things is checked. And so you see this, right? In this case, we checked PM, hit the submit button, and so it looked and figured which one it was, and then it pulled the value out of that one to drive to the PM and then the when. So key value pair. And so literally, I could stick another one of these, way down here and another one up here. As long as I named them when, then pushing this one would turn all 4 of these on and off. And so you associate them not by having them near each other, you associate them by having the same name. So that's a radio button. Pretty good user experience as long as you got the right number of things, and it's the kind of thing that you want. Checkboxes. When you have a list of things, key to checkboxes is they can all be on or off. And so you give them different names. So class 1, class 2, class 3. And then, that's what this checkbox is, class 1, class 2, and class 3. And if I check 1 and then hit submit button, you put a value for each one, right? So class 1 equals SI502. So class 1 drives into the post array, and the SI502 tells me which of those things was checked. If you don't put it, it assumes value equals on. So by default, that's the default. So if I check the third one and hit submit, I would get on. Select dropdown. We use these all the time. They're really cool, especially because we can read like what brand of car or whatever from a database and fill this stuff up, and it's really nice. It saves us a lot of pre-typing, although later we'll find out how to pre-type stuff and put that in a form field, text field, so you can type something in a prefix, but that's way later in the class. For now, we're keeping it simple. And so this is one field, not 6 fields. And so you put the text of please select. And if I just submitted the button right now, it would actually send soda equals 0, which is exactly what it shows right here. Okay, soda equals 0 because that's the one that was selected. Okay, but if you pick and you switch down and you pick Mountain Dew, then it will send soda equals 3. And so that's what it's doing. There is one name and multiple values. And based on the gesture that the user is picking, that's going to do it. And if you give it this top one,
your code will be like, hey, you were supposed to select one. So you'll know that 0. You write these 0, 1, 2. It doesn't have to be numbers. It could be Fred, Sam, Sally, whatever. You pick them, and then you make sense of them inside your program. And so inside your program, if you got the one that said 0, you might say, hey, you didn't select a soda, and then go back to the screen with an error message and ask for the soda again. You can have a default that's something other than the first one. And again, this value is just a thing you're choosing, right? Chips, peanuts, cookies in that case. It's just a string. It's not always a number. A lot of people do use a number because it's just a way for us to keep things sane in our minds, but it's just a string. So we got a name, which is going to give us our key. Snack gives us our key, right? And then based on whichever one this is, selected, if you don't have this one is selected by default, but if you say selected, you only want to do it on one of them. And then that says it'll start at peanuts. So if you pop it up, there'll be some things above it and some things below it. You can switch, but if you hit submit, you're going to get peanuts because that's the value. The value decides that. The name value pairs. Name value pairs. Okay, the text area is like a blog comment or a blog post or whatever, and there's actual little JavaScript, which we'll talk about later, that makes these things where it puts bold tags and fancy stuff, and you can see these text areas sometimes with toolbars. That's all JavaScript that's augmenting the text area. The fundamental thing that's in HTML for blocks of text is our text area. Now, the text area is intended for longer chunks of text, and so it has a little different pattern. Everything we've seen up till now has value equals. That sort of determines the thing that's going, but that's not how it works in text area. Text area and /text area surround a bit of text. There's things like rows and columns and name. Name is how it's going to be submitted to the server. Whatever you type in here is going to be submitted in the server. The previous data, you can put the old data in here. I love building websites in MySQL. Then you come in, you type anything you want. You hit the submit button, and then this is all bundled up and sent in under the key about in your post data. Okay? So that's a little different. Everything else we've done, the thing that gets sent is part of the value attribute, right? The value attribute, value peanuts. But in this one, it's not the value attribute. It's the stuff in between. So this is a multiple select checkbox. And most people just say, never, ever do this. Build some other user interface. I just include it for completeness. So it's a type, a multiple select, and the key that you're going to send in is actually an array. That's what this little thing is saying. It's array. And then you have a set of options, values, and with enough gestures, you can check more than one. And then when you check more than one, you get an array of the checked things. So code itself inside of post, remember we talked about how you build simple data structures by putting arrays within inside of arrays. So this is an outer array with a key of code and do post, and the data under code is itself an array, which is a 2-item array with item 0 with CSS and HTML because we've checked those two, and then we hit submit, and that's what comes into our server. But no. Most UI people will tell you just don't do that, and I have to agree totally with that. Another thing that we see is the submit button. Submit button itself can have a name and a value. Name and value. Now the value is weird in that the value also shows the text, and that's completely different than everything else, meaning that when I said option value equals 0 in the previous thing, you never saw the 0 as the user. This actually you see as the user, which to me is kind of ugh. I mean, it's just value should not be that. It should be the value should be the thing that gets sent to the server. The name, of course, is the thing that gets sent to the server. The value is the thing that gets sent to the server. But the value also is the thing that you see, and that's the part that I don't like about this. But hey, what I think about it, this is like 25 years old, so we're not going to argue about it anymore. I just think it's tacky. So what happens is when I'm writing code, I sort of don't think about this. I use the existence of the key using isSet. Remember isSet. So I can say if the do post is set, then I know that this button got submitted. And if I have multiple buttons, I can determine which of them is by giving each of the buttons a different name rather than having the buttons have the same name and different values, the value I just used for the visible part of that. And another thing that you're going to see is how we're going to actually override the behavior of a button and do something with it that's kind of more like an anchor tag. And so you'll see this. And so it's a button. Value is escaped. It tells what text it is. And onClick is a bit of JavaScript. And we'll talk more about this when we get to JavaScript. OnClick is a bit of JavaScript code. And for now, you'll just see me use this in lots of my examples, so I want to explain it. What we're saying is location.href. And what that really is doing is if this is your browser and you got this location bar that's http what this is saying to the browser in JavaScript, because remember JavaScript can modify the document object model, it actually is putting this string right here into that as if you typed it and then hitting the enter for you. Location href equals says put that in the browser and then go to that page. So it causes a GET request to go to that page. And this return false, which you'll see in a lot of these little onClick guys, what the return false says is don't actually submit the form because this is a button and it might submit the form. And what I've really done here is I have made an anchor tag that looks like a button. Now, those of you who are CSS experts will say you should have done that with CSS. And the answer is, yeah, I probably should have. And if I'm using Bootstrap or another CSS framework, I would do that. But this is kind of the old school, low CSS way to accomplish that. So the next thing we'll talk about is HTML5 input types. So now let's just briefly talk about some input types. I'll give you another video that sort of goes through this in a view source and plays with it in a browser. And so this is just kind of an outline of the kind of types you're going to look at. And often there's lots and lots of good online documentation, like how to do a text area. Give me a sample select. And so I tend to just go to the web and say, oh, how does the password field? So this is more of an outline than sort of instruction on how to do this. The web itself is the outline. So here is a couple of fields, right? So text field is the basic field, right? We have a box and we can type stuff in. A password field is effectively exactly the same as a text field. It sends the data in plain text between the browser and the server. That is plain text. It shows this asterisk so someone can't shoulder surf. They, of course, can watch you type, but they can't see your password on the screen. It just hides it visually. Nothing else is hidden. The other thing we're kind of seeing here is how each form field has a different name. And these are the names when we're going to package this data up and send it to the server. Account equals, PW equals, and the nick equals. So the name is what we're going to show in the $get array or the $post array. And so that's the key value. You'll also see an ID tag on these things. An ID tag, this is a CSS/HTML thing. So in this case, I am connecting this input tag with this label, mostly to improve accessibility. But that is an HTML thing. So that's not, here's the browser, and then here's the server. The name affects the browser to server connection, but the ID is just all here in the browser. This ID and the 4, that's all here in the browser. Size is in the browser. That's all just size is telling how long to make this little box, right? And so that's all browser stuff. That's HTML and CSS stuff. But the name equals is part of the request response cycle and how that data is passed in, represented, parsed, and then presented to you inside of your PHP code. The name is the key thing. Some people use the ID and the name to be the exact same thing, which is perfectly okay, but they have two very different and distinct functions. A radio button. This is something that people like. A radio button is a button that if you push one, the other one turns off. And you can have many of these, as many as you want, and as soon as you push one, you push this one turns off. And you don't have to have them right next to each other, although sane usability basically says you should. And the way you do this is you say type equals radio, and then you give them the same name and a value. So what this now says is when is going to be equal to AM or PM, depending on which of these two things is checked. And so you see this, right? In this case, we checked PM, hit the submit button, and so it looked and figured which one it was, and then it pulled the value out of that one to drive to the PM and then the when. So key value pair. And so literally, I could stick another one of these, way down here and another one up here. As long as I named them when, then pushing this one would turn all 4 of these on and off. And so you associate them not by having them near each other, you associate them by having the same name. So that's a radio button. Pretty good user experience as long as you got the right number of things, and it's the kind of thing that you want. Checkboxes, when you have a list of things. Key to checkboxes is they can all be on or off. And so you give them different names. So class 1, class 2, class 3. And then, that's what this checkbox is, class 1, class 2, and class 3. And if I check 1 and then hit submit button, you put a value for each one, right? So class 1 equals SI502. So class 1 drives into the post array, and the SI502 tells me which of those things was checked. If you don't put it, it assumes value equals on. So by default, that's the default. So if I check the third one and hit submit, I would get on. Select dropdown. We use these all the time. They're really cool, especially because we can read like what brand of car or whatever from a database and fill this stuff up, and it's really nice. It saves us a lot of pre-typing. Although later we'll find out how to pre-type stuff and put that in a form field, text field, so you can type something in a prefix, but that's way later in the class. For now, we're keeping it simple. And so this is one field, not 6 fields. And so you put the text of please select. And if I just submitted the button right now, it would actually send soda equals 0, which is exactly what it shows right here. Okay, soda equals 0 because that's the one that was selected. Okay, but if you pick and you switch down and you pick Mountain Dew, then it will send soda equals 3. And so that's what it's doing. There is one name and multiple values. And based on the gesture that the user is picking, that's going to do it. And if you give it this top one, your code will be like, hey, you were supposed to select one. So you'll know that 0. You write these 0, 1, 2. It doesn't have to be numbers. It could be Fred, Sam, Sally, whatever. You pick them, and then you make sense of them inside your program. And so inside your program, if you got the one that said 0, you might say, hey, you didn't select a soda, and then go back to the screen with an error message and ask for the soda again. You can have a default that's something other than the first one. And again, this value is just a thing you're choosing, right? Chips, peanuts, cookies in that case. It's just a string. It's not always a number. A lot of people do use a number because it's just a way for us to keep things sane in our minds, but it's just a string. So we got a name, which is going to give us our key. Snack gives us our key, right? And then based on whichever one this is, selected, if you don't have this one is selected by default, but if you say selected, you only want to do it on one of them, and then that says it'll start at peanut. So if you pop it up, there'll be some things above it and some things below it. You can switch, but if you hit submit, you're going to get peanuts because that's the value. The value decides that. The name value pairs. Okay, the text area is like a blog comment or a blog post or whatever, and there's actual little JavaScript, which we'll talk about later, that makes these things where it puts bold tags and fancy stuff, and you can see these text areas sometimes with toolbars. That's all JavaScript. That's augmenting the text area. The fundamental thing that's in HTML for blocks of text is our text area. Now, the text area is intended for longer chunks of text, and so it has a little different pattern. Everything we've seen up till now has value equals. That sort of determines the thing that's going, but that's not how it works in text area. Text area and /text area surround a bit of text. There's things like rows and columns and name. Name is how it's going to be submitted to the server. Whatever you type in here is going to be submitted in the server. The previous data, you can put the old data in here. I love building websites in MySQL. Then you come in, you type anything you want. You hit the submit button, and then this is all bundled up and sent in under the key about in your post data. Okay? So that's a little different. Everything else we've done, the thing that gets sent is part of the value attribute, right? The value attribute, value peanuts. But in this one, it's not the value attribute. It's the stuff in between. So this is a multiple select checkbox. And most people just say, never ever do this. Build some other user interface. I just include it for completeness. So it's a type, a multiple select, and the key that you're going to send in is actually an array. That's what this little thing is saying. It's array. And then you have a set of options, values, and with enough gestures you can check more than one. And then when you check more than one, you get an array of the checked things. So code itself inside of post, remember we talked about how you build simple data structures by putting arrays within inside of arrays. So this is an outer array with a key of code and do post, and the data under code is itself an array, which is a 2-item array with item 0 is CSS and HTML because we've checked those two, and then we hit submit, and that's what comes into our server. But no. Most UI people will tell you just don't do that, and I have to agree totally with that. Another thing that we see is the submit button. Submit button itself can have a name and a value. Name and value. Now the value is weird in that the value also shows the text, and that's completely different than everything else, meaning that when I said option value equals 0 in the previous thing, you never saw the 0 as the user. This actually you see as the user, which to me is kind of ugh. I mean, it's just value should not be that. It should be the value should be the thing that gets sent to the server. The name, of course, is the thing that gets sent to the server. The value is the thing that gets sent to the server. But the value also is the thing that you see, and that's the part that I don't like about this. But hey, what I think about it, this is like 25 years old, so we're not going to argue about it anymore. I just think it's tacky. So what happens is when I'm writing code, I sort of don't think about this. I use the existence of the key using isSet. Remember isSet. So I can say if the do post is set, then I know that this button got submitted. And if I have multiple buttons, I can determine which of them is by giving each of the buttons a different name rather than having the buttons have the same name and different values. The value I just use for the visible part of that. And another thing that you're going to see is how we're going to actually override the behavior of a button and do something with it that's kind of more like an anchor tag. And so you'll see this. And so it's a button. Value is escaped. It tells what text it is. And onClick is a bit of JavaScript. And we'll talk more about this when we get to JavaScript. OnClick is a bit of JavaScript code. And for now, you'll just see me use this in lots of my examples, so I want to explain it. What we're saying is location.href. And what that really is doing is if this is your browser and you got this location bar that's http what this is saying to the browser in JavaScript, because remember JavaScript can modify the document object model, it actually is putting this string right here into that as if you typed it and then hinting the enter for you. Location href equals says put that in the browser and then go to that page. So it causes a GET request to go to that page. And this return false, which you'll see in a lot of these little onClick guys, what the return false says is don't actually submit the form because this is a button and it might submit the form. And what I've really done here is I have made an anchor tag that looks like a button. Now, those of you who are CSS experts will say you should have done that with CSS. And the answer is, yeah, I probably should have. And if I'm using Bootstrap or another CSS framework, I would do that. But this is kind of the old school, low CSS way to accomplish that. So the next thing we'll talk about is HTML5 input types.
Hello, everybody, and welcome to Web Applications for Everybody. I'm going through some of the sample code in the forms section of the course. Right now, I'm just going to go through a few of the extra form fields. And literally this page is not the greatest. You can Google all these form types, away you go. So here's the code we're looking at. We have your basic text, and you notice I'm using this label for pattern over and over and over again just because I'm trying to make my markup semantic. You notice I'm not perfect at that. The next type that we're going to talk about is the password, blah, and then the password is, super secret, the most common password. And so password is just like a text field, except that it doesn't show it while you're typing. Now, if I'm going to submit this as a post variable,
look, the secret just goes in plain text. It goes into the PHP in plain text. If I was to do a view developer console and watch the network, what was that? Credit card. So if I type in the password for secret and I press submit and I look at the post that just happened, it sent the password across the network in plain text. So password is really only there for you to keep people from shoulder surfing as you're typing the password. Okay, so nickname is another text. Okay, this is a radio button. And so type equals radio. And radio button is like a station selector on a car radio. And the idea is that no matter how many of these things there are, one can be turned on at the same time. And you do this by naming it type equals radio, but then grouping them by having the same name. Remember, name is what's sent to the server, key value. And then different values. So value equals AM is what's going to be sent to the server. If this one is checked, value equals PM is sent to the server if this one is checked. And then there's an optional attribute that just says checked, which indicates when this first is refreshed that PM is going to be the default one that's checked. So if I hit AM and press submit, then you can see when equals AM. And so it really picked among the things when equals AM from the source code. Okay, so that's that one. Checkboxes. Checkboxes are independent, so you can have any combination of checkboxes that you want. All of them, none of them, whatever. So they each have a different and distinct name and a different and distinct value. If the value is not given, then on. The string on is what's sent. So I'm going to see all three of these, class 1, class 2, and class 3, are going to be checked from that checkbox. Okay? And on is because I didn't specify a value, but most of the time we're just doing an is set to see if this key is set in the $post as compared to looking at the actual value, but it depends. Okay, so the next two examples are drop downs, and again I got a label, and I have the name of the data that's going to be submitted, and then option, and those options effectively in order pick these things. And then when we hit submit, 3, if I pick Mountain Dew, then 3 is going to be sent. In this next one, all we're doing is we're picking a selected one so that it's not the top one, right? Peanuts, I can change it to chips or cookies if I want to. And then in this one, snack equals chips is what's going to be sent. In this one, soda equals 3 is what's going to be sent. So let's go ahead and submit that. And so soda's 3 and snack equals chips. And so that's how the drop down works. Text areas. Text areas are cool in that they don't have a value equals like most. You just put the existing text that you want in between text area and /text area. Name is how it's going to be sent. You can put like blanks in here, blah, blah, blank, blah, blank, 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 blah, 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 blah. Okay? And now if I hit submit, you'll see all this is bundled up into a single value, right? So this is the about, and it's a string. It has new lines and all the spaces and whatever, and that's why you can write little paragraphs in here. Now there's all kind of plugins that will turn this into something that turns into bold, because I could say, and I'm not filtering this very well, so it's going to look bad. And so I submit some HTML, and look at that. It's bold. Now the danger is I could submit some JavaScript and ugly stuff. And so there's another filtering anytime. I'm clearly not filtering this stuff when I'm just using printr. And so, this is a dangerous page because HTML could come out. The last thing is something that you pretty much, second to last thing is a multiple select. And so this is sort of like the option value, except you've said it's multiple. And it actually sends an array of codes because they can all be turned on at the same time. This is generally a hard way to do user interface. And let's see if I can get it. Option doesn't work. I can never remember. Not control doesn't work. Command works. So now I've got 2 of them done. This is a terrible user because no one, including myself, knows how to use it. but when you send it, you get an array that tells you which of the things were checked based on this thing. And then the last little trick that we'll show, we got a submit button, and in this case we got a name and a value. So the value in submit buttons is a little bit weird in that it both changes the text on the button and it sets what is sent. Most people just name their buttons different names. So this name equals due post, and check to see the existence of the button in the post data to figure out which of more than one button, if there are more than one button, rather than looking at the value, because the value is often translated. If you have a multilingual application, submit would not be the text that was here. So checking for the text is a little problematic. And then we have one more little trick, and that is how to turn a button into an anchor tag. And that is, you say input type equals button, on click is a bit of JavaScript, and then you simply say switch this browser to this particular URL, and then don't submit the form. That's what return false is, and you'll just see we will use this for escape or cancel or done or all kinds of things to get out of a form without actually submitting the form. So if I click this, it's going to take me back to web applications for everybody. So that was a really quick zoom through the sample form code, and I hope that it was helpful to you.
So HTML over the years has had multiple versions, the original 1.0, and HTML5 is the latest one, and it's actually well established. And so we tend to use HTML5. HTML5 introduced some new input types, and if you go to super old browsers, they're not going to support these. And they all sort of fall back to being type equals text. And so there's lots of good examples. I'm just going to show you a little bit about them just to kind of get you started. And so these are new input types. Type equals color. Right? And so if you didn't have a browser, this would just be a text box here. And you could put in, this is a hex number, but this is like a little bit of a UI thing that the browser provides. The browser provides that if it provides it. So it's not something you have written. It's not something CSS does. It's not something JavaScript does. You could write your own JavaScript color picker, but this is a color picker built into the browser. So if you're on a Mac, this will look different than if you're on Windows or on Linux, because whatever you said is make a color picker that's native to the system that's on this. And so you click it, and if you're on Apple, it'll look just like the color picker that you use in PowerPoint or whatever. And so you pick a color, it shows a little square, you pick it, and then it sends this string back, which is the hex value, and puts that in and sends that in when you post. Okay? Similarly, a date. And again, you got to remember these things all fall back to text. So date says make a date picker that makes sense within the context of that operating system. And it sends back a string based on whatever date you picked that's in kind of like this year, month, day. But it's this, you didn't write that code, and it's consistent with what the operating system does for dates, which is kind of nice. Email is really just like a text field, except that it has a validation. Number also is a text field that has validation in these little arrows that go up and down, and you can give it a range. Now, and the same thing is for URL. URL is another field that basically you're saying I'm expecting this to be a URL. These three are all validated in the browser. The way this works is when you press the submit button, before the form is submitted, it checks this, this, and this to see if the format's right. If the format's wrong, it puts up a little message that you don't control and says, I didn't submit your form. So it doesn't actually go to the browser. In the request response cycle, it stops before it sends the data and makes you finish this. And so it'll block you from sending the data until you meet the criterion, says that email is in the right format, numbers are the right format, URLs in the right format. But you inside the server, still there's ways for people to bypass this stuff, so you got to be careful so that there's no guarantee that just because you ask it to be a number doesn't mean you can assume it's a number in the server. So the server does to protect itself from bad data, which we're going to talk about in a little bit. And then the last thing to talk about is the fact that if there is something that it doesn't recognize, so flying saucer is not a type that's in HTML5. Maybe it will be in HTML6, but it's not. It's just like, oh, okay, whatever.
I don't know what that is, so I'm going to give you a basic text field. So yes is going to come in with the name saucer. And so that's the sort of the safety net when they put these things in, that they all on a browser that came before HTML5. And there's code that you can drop in that sort of shims these things in and with JavaScript. But basically, these are just one form of an option that you have to affect your user experience. So up next, we're going to talk about data coming into the server and validating that data and how we might handle that data. So now I want to talk about how you think about data when you receive it from the server. So up to now, we've been talking about how you make a form in HTML. We've talked about how that comes in $_post. Now we're going to start talking about what you do with $_post. And the first thing we're going to talk about is persisting form data from one screen to another. And we do this so much, it's done so commonly and so often that we just assume it magically happens, but it doesn't. It turns out that we as the developer have to work pretty hard to make that happen, right? And so you type something like 20, you hit submit, and if you don't persist it, this comes back blank, right? So we just sent the data and there was a 20, but where'd it go? And what we want as users is to see the 20 in case there was a mistake, right? See the old value. So we have to specifically copy the old value from one request to another request on down, if that's what we want. And we turn out we want that a lot. And so the idea that we're going to take the post data and generate a form that has the post data in it, that turns out to be a real common problem and turns out one of the most common sources of security errors. And so think about it this way, right? This script we've got is going to be run as a GET request when we first go to the URL, and then we type something in, hit submit, then it comes into this same script again as a POST request. And so we have to use isSet to say, is this a POST request with guess as a value, or is this a GET request? And we'll just have to show the form. So on the first one, we show the form. On the second one, we want to show the form with the previous guess already persisted from the previous request. Okay? So what I'm going to do is I'm going to use the ternary operator. I don't like it, but I use it mostly only in this exact form. If there is a guess value in post, stick it in old guess. Otherwise, put a blank in old guess. So old guess is this variable that will fall through into this templating code. Now the rest of this is just a form, post, yada, 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 except right here. We say value equals. So value equals is a way for us to put an old value into the form as we're displaying the screen. So we're writing back the form, and if we put value equals in the form and put something in it, then that's going to show up 42 in that little screen box. So that's how we put something in by generating HTML with value equals. Now, this is also the moment where I'm showing you this little syntax of shortcutting. So normally I would say double quote, PHP, echo, old guess, semicolon, less than, question mark, right? That says switch into PHP. This says run the echo command. Semicolon is the end of command. And this says switch back to HTML. That's what that does. And if I put double quotes around it, like here, then the HTML will just be like quote 42 quote, right? That's what we're going to see. Now, all those spaces don't matter because that's just code running. This is such a common thing that they actually have a shortcut for it, which is less than question mark equals. So less than question mark PHP is the long form, and less than question mark equals is the short form. And what it is just a short syntax to do exactly this thing, and that is to echo the value of a parameter. So what this says right here is print old guess right here, and we're done. So we use this short form a lot, especially when we're doing stuff like this, where we're mixing HTML and we switch into PHP just to get a value out, and then we're back to HTML. Okay? So, if we do that, that means that we're going to see that old value. But it turns out that that code that I just wrote for you, this code right here, is like the worst possible code you could ever write in an application because of the problem of what we call HTML entities or HTML injection. And the problem becomes is if a user is particularly smart, they can type something into the form field that is going to become valid HTML. Okay? And so they know that you're going to say value equals, quote, whatever, quote. But what if I stick something in there that itself is a quote? And then I put my own code in here. And so what I've typed carefully here is double quote, end, bold, die, die, die. And when I hit submit, I don't see the old guess anymore. I see bold, die, 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 right? And so this is called HTML injection, where what's happened is the user was capable of typing something at the prompt that sort of took over the page. Now, usually they're doing something much more evil than just putting out the words die, die, die. They're doing things like taking your credit card number. They're taking things like if you're the teacher logged into a system and they go change their grade, they cause you to execute code in your browser that goes and change their grade. So this is HTML injection, and the whole idea is you're breaking the HTML and putting code in that the bad person wants to put in on your computer. So let's take a look at what happens there, right? So you type this thing, and so this bit right here is exactly what the user typed, okay? And so they typed single, double quote, blah, 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 blah. But the problem is when the browser parses it, it doesn't really know what came from the code and what didn't come from the code. And so that's how it sees it. And so this is just an HTML text, and this is a bold tag, and then this little quote here, this crap shows up right down here, right? See that crap showing up? But that's broken HTML ultimately. Actually, not broken HTML, because you can put a double quote and a slash less than inside of it. But the user has sort of permuted or messed up the page. And again, usually they put something bad in here, something really bad that is going to do something to your system or do something to the server, et cetera, et cetera, et cetera. But that's the key. The HTML injection is when they put some highly crafted character in that is designed in a form field. And because it's so easy to write code like this, right? It's so easy to write code like this that we end up in trouble. As software developers, we have to have a little warning message go off anytime we are producing HTML output with data that originally came from the user. So $old guess is not just any old variable, it is a variable that came from user input. So the danger is when you're printing out user input, you have to make sure that you do it in a very clean way. Now, thankfully, there is a real easy way to fix this. After all of my fuss, there is this function called HTML entities. And what HTML entities does is if we go all the way back to the very beginning when I talked about HTML, I told you that if you're in HTML and you want to represent a less than, you say ampersand LT semicolon. If you want to represent a ampersand, you go ampersand AMP semicolon. And if you want to represent a double quote, which is the one that's causing my problem right here, you say ampersand QUOT or something like that. These things are called HTML entities. These little alternate representations of these characters are HTML entities. So there is a function inside of PHP that just takes that data and converts anything that can be represented as an HTML entity and prints it out as an HTML entity. And so that's what this does. We're running old guess through the HTML entities function, and then we're printing that out between the double quotes. So let's take a look at what comes out at that point. This is what comes out at that point, right? We see value equals, and now these are quote, greater than, less than, B, greater than, less than, greater than. So that's what they typed, but now it's been converted by HTML entities to be HTML entities. And so what happens is when your browser parses this, it sees that is the beginning of the value and that is the end of the value, because in there are no double quotes. There is a double quote, but it's not represented in that string as a double quote. And so the browser knows that. Oh yeah, and so it puts the double quote right back in. So you can submit the double quote, you can submit as crazy a stuff as you want, and away you go. Now, if you're using the autograders for this course, this is a thing that I check over and over and over again because it's the way that a lot of people make mistakes in building web apps, that they open themselves up to what's called HTML injection. And you just have to keep in mind which, and I'll remind you this like 8 million times over the rest of the next few lectures, just so you know things coming from the user are dangerous and we have to escape them. That's called escaping. Okay? So now we've talked about ways to take data and then put it back in a safe manner using HTML entities. And now we'll talk about checking the data when it comes into the server before you do something with it.
Hello and welcome to Web Applications for Everybody. Today we're playing with a bit of the code, sample code from the course, doing some of the form code. So let's take a look at the forms. Form1.php. The idea of a form tag in HTML is to describe some input that allows the user to type in or interact with and then submit data back to the screen. So you have to think that at least the way this works is it comes through with a GET request and prints this out, and then when we hit this submit button, it goes to a new request response cycle. So there's the source, and let's go into developer console so you can watch what's going on. Take a look at the network. Okay, so when I hit enter and do the original GET request, so there's the GET request, or forms.php, form1.php, and it just runs this code. And there's no PHP in here, but it's HTML, and so it just prints that out. And then basically the form describes a bit of text area that says, oh, we're going to put an input area, type equals text, and then this name equals guest tells the browser how to submit this data that we're going to enter to the server. And ID equals guest. The fact that I use the same one doesn't matter. I'm using the ID, has to do with marking this label, has to do with semantically marking up your code for accessibility. And that is that we can look, when we're visually looking at this, we can know that, oh yeah, this seems to be associated with that. But for a screen reader, they want a more accurate and clear association. So this ID, that's really just for CSS. Name equals guest, name equals on input tags are the things that are sent to the server. So input type equals submit. Shows a submit button, and type equals text gives us a little spot. So if we say 12 and then we press submit, it is going to do another request response cycle, right? And going to run this code again, except at this time it's going to add this parameter question mark guess equals 12. And so that's how that works. And now inside of our PHP code, we are going to want to be able to take a look at that. And PHP has some magical variables that are super global called $_get. And what $_get does, let's take a look at form2.php. Well, I'll just leave the guess equals 12 on. What $get does is $get takes and PHP parses these key value pairs and the query string after the question mark, and then gives us things in here. And if I put like ampersand x equals 42, then it would give me guess equals 12 and x equals 42. And so then this allows us inside of our PHP code to sort of detect the time when it's coming in with just no parameters versus parameters are being sent. And so there's no parameters, and we're printing out an empty array. And we, as the developer, are giving our user an easy way to send us data, and it just concatenated on. And so that's form2.php. Form3.php says there are two ways to send this data. One way is as parameters, but this gets kind of ugly, and there are reasons not to do it, and you're not supposed to modify data. Now, guessing in a guessing game is probably okay to use as a get, but all we have to do to switch to sending the post instead of get is to say method equals post. So the form is exactly the same, constructed in exactly the same way, and we have get parameters, and $_post is a new thing. I'll take off this guess equals 12 and switch to form3.php. And so that's a get request. So if I take a look here, that was a get request. So if I come here and I hit the enter key, that forces a get request to that URL. Hitting refresh doesn't, as we'll soon see, doesn't always force a refresh. If the last operation was a post, it does the post. If the last operation was a get. But in this particular bit of code here, view page source, in this particular bit of code, we have told it that we want to send it the data that's entered by the user, like our 123, is sent via post. And so you'll see that if we look at what's gone on here, it sent a post to this URL, and if you cruise down, the data was actually sent as part of what's called form data in a format called URL encoded. And we could look at more detail, but the first thing you'll notice is it's not on the URL as a question mark, as a query parameter, and that's because it's actually sent as part of the connection. The connection connects to wa4e.com on port 80, sends post to that URL, and then it sends these request headers. These are actually part of what is sent, and then a blank line, and then form data is sent. The response headers are what come back.
to our application after in the request response cycle. And basically, just like with get, $post is created for us before the first line of our program, and it just handles this stuff, and it's all magic. You make a form, and then when the post happens, $_post has key value pairs that are properly set for us. Okay? So let's take a look at form.for.php. The one thing that you'll notice here is my previous guess was 123, but it didn't show up here. It's so often that forms put their old data there. 125, submit. Where'd the 125 go? We kind of expect that the 125 is going to be there, but it's not. And it turns out that we have to just explicitly put it there. And so it's so common that developers grab this post data as it comes in and echo it back right there so you can actually modify it. So if your guess was something, long and you wanted to change it, right? It's not there. I wish it were changed. And so in Form 4, we show how to solve that problem. So let's go to Form 4 and view the source of Form 4, which of course is also over here. And so what we're going to do is we know this code is going to run once to do the get, and that just is drawing the form. That's when I hit this enter key, and it draws it, and it sends a get, right? When I hit the button, because method equals post, it's going to send us a post request, and the key is I just have this input tag, and I add value equals, and then this little bit of stuff. And this is a contraction for PHP to print out this variable. And the variable is, if there is data in post sub guess, I'm going to take that data. Otherwise, it's a blank. And so if I do a view source here, in this value here, there is no data because that was a get request. The post is not set. But when I do when I send a post like hello, this is not a number, and hit submit, well, it comes back. And so if I now do a view source on this page, you will see that my PHP code particularly put this in right here, using this little bit right here to say, oh, generate the HTML, but replace this little variable old guess and whatever's in old guess, which came in post sub guess. Okay? Now, the nice thing is now I can fix this. I go, oh, I typed that wrong, and now it works. And so the idea of is a post still, but the idea that this stuff is persistent is not something the browser does for you automatically. Sometimes the browser does auto fill in, which is TAC E, of certain fields. It does auto fill in of those fields, but in my browser they're yellow, which is different than the server restoring the data. Okay? So, that's cool, that's easy. But in doing this, we just violated the first and most fundamental rule of PHP application security. And the first and most fundamental rule of PHP security, and you can go and Google like cross-site scripting and learn more about this. Cross-site scripting, oh, blah, blah, blah. It's XSS injecting, blah, blah, blah. Go ahead and read all that, okay? And it's nasty. And how did we just allow the user into our backyard? Well, the problem is this post sub guess right here is data that came from the user. Whatever I typed here shows up here. And so if I am clever, I can actually make old guess contain sort of a snippet of valid HTML. So what I'm going to do is I'm going to make my old guess start with a double quote. And I'm going to say double quote slash, and that's going to end the input tag. And then I'm going to start another input tag, type equals submit value equals monster. But notice that I only have the opening quote and not the close quote. Let's put a BR tag in here, or not, an HR tag. So there's an HR tag as well. And so when I submit this, you're going to see what happens. So now I have this monster button. And the monster button is something that I created. And I could do something evil with this little monster button. Now, how did that happen? Well, let's take a look at the view source of this. And you can see with syntax coloring. Now, this part here came out of my PHP, and this part here came out of my PHP. But all this stuff all that stuff there came from me typing. But the browser, when it sees this, it's like, oh no, that's not good. And so then the browser sees that as an input tag. It sees that as an HR tag. Even though this came from me, sees this as an input tag, and this is the input tag, even though this last part of the input tag came from the PHP. It doesn't know the difference. It just can't tell. Okay? And so that's really bad, because this could do something like take your bank account cookies and send them to my evil server if I was super clever and did this. So this is called cross-site scripting, which means that I have typed something into your application. Hopefully I get someone else to stumble into my typed-in stuff, so you're viewing somebody else's information. And then in that information, it is stealing something from you. So that's really bad. So this is like terrible, terrible PHP. Good news, not hard to fix. Let's take a look at form 5.php. There's this function called HTML entities, and as long as you print out HTML entities of that value instead of the value directly, then you're generally safe. And that has to do with this. So let's go to form 5.php, and let's type that same thing here. Got it here. Okay, we're going to type this same thing, and we're going to submit it. And it's going to be like, okay, and now if I do a view page source, it'll be far more clear as to what is going on. So this part came from my PHP, this part came from my PHP, this part came from the user. But what HTML entities did is it saw dangerous characters like double quote, greater than, less than, single quote, that's double quote, and it turned them into these things called HTML entities. And HTML entities are a sort of ampersand form of those characters. But now, even though the browser knows that's a quote, and it shows it as a quote right here, it does not then allow this user to escape and start entering HTML into my background document. You can actually note that this kind of messed up because my debug output messed up, right? Because my pre-tag is still printing that value out without filtering it. So be careful, because I fixed this error, this error right here, but I didn't fix that error right there. Okay, so just rule number one is if this data came eventually, or at any point came from the user, just wrap it in HTML entities. You can wrap things in HTML entities that didn't come from the user. It doesn't harm it. It's harmless, but always for user data, wrap it. I tend not to wrap everything in HTML entities so that I can kind of mentally know where I was getting user data. So that is a zip through some of the forms sample code for web applications for everybody. We'll talk about some of these others in an upcoming video. So again, I hope this was helpful.
Now we're going to talk about in-server data validation, that moment where you are receiving the data. Okay, and so we talked about HTML5, and that HTML5, when you're typing something in that's not a URL, that's actually just an interaction between the user and the browser and the document object model. But then when the data finally comes in, we have to protect ourselves. So the post data comes in, and we're sitting here at the beginning of this. The post data is sitting there, and now we have to ask ourselves, is the data good? Is the data right? Is it dangerous? We talked about HTML entities, and that's when you're echoing it back out. You want to make sure that you put ampersand LT semicolon. We just sort of talked about it going out. Now we're talking about inside the server, high up in your script, deciding whether the data looks good or not before you're going to do it. Because ultimately we're going to store it in a database, and so we might want to go back and send a message back and say, that wasn't very good. I don't like what you did there. Please send it in. The email is required, or the URL is required, or you need at least 5 characters for your password, or who knows what it is. But it's a set of questions that basically you're going to ask before you trust the data, and then maybe go back and complain to the user. So this is code that you write at the top of your program. And there's a couple of different functions that we tend to use. Things like we might want to ensure that a variable came in on the post data is non-empty. is there one or more characters in there? Is numeric looks at the actual characters themselves and says, is this a number? So Fred is not a number. Because part of it is PHP converts things so easily. So Fred converts to a 0. So you can't check to see if it's a number by just checking it. You can say if it's equal to 0, Fred is equal to 0. You say, hey, give me a true false as to whether this is numeric. You can do something like stir pose, like you can do a simple email thing where you say if there is an @ sign somewhere in it. So if you don't have an @ sign, this will be false. And if you do have an @ sign, it'll be true. And there's other more complex ways to do this. This is a function that's built in called filter var, which is specifically designed to check things. And so you can go look at the documentation for filter var and see a whole series of more sophisticated emails, more sophisticated filters that can give you true or falses as to whether or not your data looks good. And so if we take this guessing game, and the whole idea of this guessing game is you just put your guess on the end of it, and we want to actually defend against really bad guesses, right? And so here's an example of this, right? So we're taking a look at this bit of data that's coming in. Here's our code. We can check to see, is there a parameter at all? And if there's no parameter, we can say, oh, you don't have a parameter. And then I'm going to have a series of else ifs. And I kind of have constructed this in a way that I'm checking the most obvious and broadest thing. First, I want to check if it's there. Once I know it's there, I can say, is it less than 1? So they might just say guess equals with absolutely nothing. If the length of that is less than 1, I'm just going to say your guess is too short. If it's not numeric, I'm going to say your guess is not a number. Now, I know that it's a number, and I know that it's not empty, and now I'm doing the actual sort of game logic of saying if it's less than 42, now implicitly there's a number conversion going on because this is a string and that's a number, but it just works. It converts it to a number and then checks, and then I can see if it's above 42. Otherwise, it says you're right if you say guess equals 42. So these are just examples of the kinds of things that you can ask about a parameter. Is it there? How long is it? Is it a number? Etc., etc., etc. So the next thing I want to talk about is the basic idea of how you structure your applications in the file, about handling input data and producing the next output, updating the database, etc. A concept called model view controller.
Okay, so welcome again to Web Applications for Everybody. We're doing a bit of code walkthrough. Right now we're on talking about the forms topic. And so what I want to talk about is this model view controller pattern, but I'm start with some code that sort of I've used before, this guess code, guess.php, where we're supposed to play a guessing game. Guess equals 14. It's oops, I did a minus sign there. Guess is too low. So I want to take a look at this code. And so this is kind of a typical crude basic PHP script, a bit disorganized. It starts with some HTML because that's what they are, is it's a template, and it drops into PHP and then does some logic and then puts a bunch of echo statements. And what it does do well is its structure overall, top to bottom, is not what I like, and I'll show you in a second how I want to restructure it. But it does do a pretty good job of, checking to see if there's a guess parameter and complaining if there's not, checking to see if the guess is too short. This is all input validation that's doing a pretty good job of. In my next application, I'll have it better structured, but I won't do this validation. And then once I know, by the time it gets to here, I know that I've got at least sane data, and it's a number, it's the right length, and it exists. And then I can say if it's too low or too high. And otherwise, if it's equal, then I say congratulations. So this is nice little error checking here, and nice structure with else ifs. I like that. But the fact that I just sort of like intermingle my PHP with my HTML gets a little bit sort of confusing after a while. And so, and this is not either the greatest application, but it demonstrates quickly and simply this notion of what I call, well, what the world calls model view controller, and this is my really simple implementations of model view controller. You can go Google model view controller, and you can view controller, and you can read so much stuff about model view controller. Oh, I even use that slide in my talk. And the whole idea of model view controller is that when you're doing the request response cycle, there are three basic things that happen. One is the data model gets updated, the database, the backend, etc. You generate a new page, and there's this thing called the controller, which decides what to do with the model data, what next screen to pick, how to respond to the incoming post data. And so I would call it controller model view rather than model view controller. And that's kind of like the picture that
Wikipedia is showing you here. And you can read and read and read and read and read more about Model View Controller, and there's whole frameworks that do Model View Controller. But what I do to keep it simple so that you know Model View Controller in kind of this low-level sense, and then when you move to a framework that's more advanced, then you can just use the framework to do all the Model View Controller magic. So in Model View, so this is kind of like the model. And so what I do is I always start my PHP files that are going to do data processing in PHP, not in HTML. And the model is handling the incoming data. And the view, there's always a line in every one of my scripts where you see, oh, I've switched from the model to the view, at least the ones that process data. So above the line, the idea is you talk to databases and do your data processing and handle post data. And below the line, you just mostly generate output. That doesn't mean that you don't sneak a little PHP in here, because PHP is both a programming language and a templating language. And in this case, I'm just deciding if the message is not false, print it, or print out the old value in the form using the HTML entities and the less than question mark equal for the echo. So the idea is there's always this line above which we are completely silent and below which we don't do any major data operations. We can do loops and whatever, but we don't talk to the database, we don't do that thing. And so that's my discipline. And controller is the whole script. And if we get later in more sophisticated things, we'll see that we're doing routing decisions. We're sometimes moving after we process the data, we send them to a different script. And so orchestration and routing is the function of controller. So this guessing game, Guess MVC, this Guess MVC is going to look like every other guessing game we've made. So if I say 12, now it's a post. If you look, it's going to be a post, so it's not going to show up here. So the old guess was 12, and it says too low and guess is 12. Okay, and then I can change it. 123, it's too high. How about 121? So all this stuff is working. But if you look at it, what's happening is old guess, and a get request, so let me do a get request by just hitting it and hitting enter, so I do a get request. There is nothing in post, so old guess is false and message is false. And there is a thing that's passed between the model and the controller, and the model and the view. I call that the context, and that's really, in this case, it's just two variables. Old guess and message are set and then fall into the template, passed into the template. In other frameworks, we're more explicit about constructing a context and rendering a template with that context, but I'm keeping it really simple by saying context is what falls through from here to here. And we have to do it in a get request because it's going to run these two lines of code and then skip all the way down to here. So old guess is nothing and message equals false, and that's why there is no guess here and there's no message. But then when I say 12 and I hit a post request, this is going to become true. And now there's no error checking. I'm sorry. I'm trying to keep this simple so it fits on a screen. So error checking would go up here. This is actually the logic of the guessing game. I'm just converting this to an integer by adding a 0 to it. That's kind of quick and dirty. And then I'm checking to see if it's 42 or less than 42. But what I'm doing is I'm not putting echo statements here. I'm setting the message and then letting it fall through into the template. So there will be silence up here. There will be a bit of silent work that you don't even see up here where message and old guess are being set right here, and then it falls in, and then it renders it, and away you go. And so that's the basic idea of Model View Controller, and we'll talk about this a bunch, especially when we have more interesting stuff to just looking at the guess. And especially when we get like 2 to 3 pages of code up here, it's important to really mentally separate the brains of your code from the look of the code. So model at the top, view at the bottom. Okay? So I hope that has been helpful to you. See you on the net. So now I want to talk about a pattern, a programming pattern that we call Model View Controller. And this is something that if you're going to be a web application developer, you might as well just be able to being part of a conversation about model view controller. So you should just know this, because everybody I'm MVC, you're MVC. My MVC is better than your MVC. That's how we talk. So MVC stands for model view controller. And what it really does is it breaks the request response cycle, at least how we kind of handle it, into 3 basic operations. And it's helpful to have this terminology so I can say, oh, that's the model, that's the view, and this other thing's the controller. And so the basic definition, sort of in a pure sense, is that we take data, we might update the model, and the model's the permanent storage. The controller is this thing that sort of decides when to do things and when to switch from one screen to another, and we'll start seeing that more later. And then the view is the next thing that you see. So you could think of it as it comes into the controller updates the model then is done. When we read the data, which is reading from the model, we produce a view, and then the user is involved. This notion of there is this sort of, model view controller, it should be called controller model view, but that doesn't roll off the tongue as well as model view controller. So MVC. And there turns out to be lots and lots of different ways inside of code. And if you're familiar with, or if you've heard of things like Cake PHP or Angular or React or Symfony, these are all ways of interpreting the model view controller differently. And so what I'm going to show you is one way of interpreting the model view controller. And this is the way I'm going to teach you. And what you'll probably find out is mine is very simple because it's all in one file. And it's very PHP-like. It's very sort of first principles. But ultimately, if you look in a framework, they will put sort of the model stuff in one file, the controller stuff in another file, and the view stuff in yet a third file, and then they'll knit those things together. And when you learn that, there's no right or wrong. They're just patterns that help organize things. And so if you're going to do a Symfony app, and you've done a bunch of Symfony apps, you know where all the models are at, you know where all the views are at, you know where all the controllers are at. What I'm doing is something that's kind of a more low level than that and putting it all in one file. So what I do is I basically make it so that when I'm writing a code, I break my code into 2 parts. And what I do is in the top part, I do all the model part. So the model is the top part, meaning that if there is incoming data, I handle it. Sometimes there is no incoming data and I go straight to the view. Sometimes there is model. And then I always can draw a line between the model code. This is also silent. And I mean by silent, there is no output, right? There's no output whatsoever. It's the silent part of you're handling input data. And again, there may be no data, and so you skip right past it. And then you fall into the view. So the bottom part is the view, and it produces the output. And there's some rules about what you're not supposed to do down here. You're supposed to pass some information down, and you're not supposed to talk to the database down here. You're supposed to talk to the database up here, because when you're talking to the database, you're working with the model, okay? And so this is what it looks like, right? And so in this case, I'm refactoring that guessing game a little bit, where I have the old guess and the message. These are the pieces of data that are going to be in the view. And so if you come down here, you will see that I'm going to print out the old guess, and I'm going to print out the message. But I'm going to start by saying the old guess is nothing and the message is false. And if I have some data, I'm going to handle that data. Now I could have put better validation in here, but I didn't do that because it wouldn't fit on a screen. So I'm just going to check to see if it's 42, less than 42, or greater than 42. And instead of printing it out in that if, I'm actually going to just have this variable message fall through into the view. And the data that we send between the model and the view is called the context. So the view has little bits that are to be replaced with data. It's not just static HTML, it's dynamically generated HTML. And the context is that set of things that we're sort of passing between the model and the view. And the controller is making all these decisions. Later, we'll do these more complex things, and these will route to other files, and that's another controller activity. Deciding when to do stuff, what to do with the model, deciding when to switch to the view, that's all the controller, and when to switch to completely different files, that's all controller stuff, okay? So a simple rule to follow is that you're not supposed to generate any HTML on the top part, and you're not supposed to touch the database in the bottom part. Any database stuff is supposed to be done before we cross this line and passed in as a variable into the view, okay? And that's just a discipline thing. It doesn't mean you can't do it. just means that we're going to be disciplined and we're going to follow this model view controller pattern. And so if you look at my code and I look at your code, we can follow the same convention. And so, like I said, this model part is in the top. And again, there's always this line that you can draw. We're going to pass the context, which is going to just be two variables, old, guess, and message. Sometimes contexts are much more complex. We have an if statement, and there's always an is set here, and it's always looking at post. And the first thing it's deciding is there any input data at all? And if it's a GET request, because we're coming in the top once with a GET request to show the page, and then when the submit button is, we're coming back in again as a post request. Okay? And so in the GET request, this is false. In the GET request, it's false. Actually, let me do it this way. Right? We come in once with a GET request, and the second time, we come in with a post request. Right? When the GET request happens, it's going to set this to negative, and then it's going to skip all this. It's just going to fall through, right? So there's no post data. But if we then have post, it's going to set this, but then this is going to be true, and then we're going to set message to be something different, and then we're still going to fall through. So in both the GET, we come at the top for both GET and post, and we exit at the bottom for both GET and post, but we've got a different context. Context are these two variables that are passing between and across the magic line. And if we take a bigger look at what's going on below the magic line, right? This is the magic line. The model is above, the view is below, and the context is coming through. So the context are these two variables. So we come in here, and we have to know that this view code is going to run two different ways. So we have to put some if code in it. So we're saying, if there's something in the message false means there's no message to show. But if there is, then we'll print it. So this is going to show up on the post, but not on the GET, because message is going to be false on a GET request. Continuing through, this is just HTML, and then we use a little shortcut. And of course, we use HTML entities. I'm very proud of us because we're using HTML entities of the old guess. Now remember, if this is a GET request, old guess is an empty string, and if it's not, it's 42 or whatever the old guess was. And so that's how our view constructs itself from the context that's passed in. So this is just a slightly more verbose way of doing exactly what we did before, with kind of our model, view, and controller all mixed into one file. But this discipline, as our code gets more complex, having a discipline that puts certain things here and rules about what we do up here and rules about what we do down there, it's really helpful. Okay? So in summary, we talked about the superglobals GET and post. We talked about when you might use them. We talked about form fields. We talked about these like colors and dates and all the validation that we can put in. We covered a lot of stuff in this lecture. How to use HTML entities to sanitize the HTML so you don't end up with HTML injection. Some of the functions and techniques that you can do to do data validation when data is coming into your server. And kind of a way to structure our server code using the model view controller pattern. Knowing that there are many ways to do this, many frameworks, many languages, but we're going to start with something that's sort of very pure PHP, and then we'll learn more about those other evolutions on model view controller later.